Hi everyone, and welcome to Global AI Student Conference. And if you're someone who's joining us for the very first time, this is our third edition of Global AI Student Conference. I'm your co-host Steven Simon, and welcome back everyone once again. It's going to be really exciting next 6, 7, 8 hours of the event where we're going to learn about the entire ecosystem of the AI and machine learning, and not from the experts, but actually from the students. We have students joining us from all across the globe. They're micro student partners. They are full-time students. So yeah, the next 8 hours is going to be really, really exciting. Having said that, the as I said, this is the third edition of the Global AI Student Conference, and the first two were really, really successful, where we reached about 2,500 live views for the first one. The second one was a lot better. We reached 8,000, and let's hope that the third one is bigger and better. So please feel free to go ahead and share about this event on social media, tag us at Global AI Community, and use the hashtags, and share it with your friends and connections. Having said that, the conference has been divided broadly into four categories. The first one is the learning sessions, where you get to learn about deep learning, about Microsoft Learn platform. Then you have content around deep dive into machine learning, and also some of the great content by Rohan Raj. The other session that the category that we have is these talking sessions, where we have roundtable discussions. That's around women data science, and there's one by Usman Khan, who's going to talk about what it takes to be an NLP engineer. Quite an interesting topic, to be honest. The following sessions then are about intro to products, where Fotheni talks about Azure Custom Vision and introduction to Azure HealthBot. Then we have sessions around the projects, which is always very exciting, where there's a project that's around Project Plant AI, and the other one is about No More Mathidas. So so you can actually divide the entire conference into these four categories. Having said that, this reminds me that the entire conference has the signed language, which is absolutely great. So I think that that's something to notice, that if there's someone who cannot attend this conference or hear it, there are some sign languages to help you out. Having said that, Global AI Community is committed to empower this entire AI community, and they do a lot of events across the globe and help in creating some of the amazing content. So going forward in the month of December, they're going to come up with some absolutely amazing content around AI and machine learning. So to stay updated with that and the other events that they do, please go ahead and join their Slack community and subscribe to their channel, that is #AI for Beginners. There's also a link in the on the screen. You can go ahead and check that. And what's really exciting and interesting about this event is if you go ahead and complete a learn module, right? There's a challenge in this event. If you go ahead and complete a learn module, for every module, we plant a tree, and together we can actually plant a forest. How noble is this? This is absolutely great, and I have never seen an event like this. This is one of its very own kind. Kudos to the entire team who has been working behind the scenes to organize this absolutely amazing event. This is great. So this time I highly encourage you all that if you go ahead and complete the challenge, and all the details you can find on the nav bar on the top of the website. So when you go ahead and complete these challenges, they will actually plant a tree for you. This also reminds me that we are streaming this event on different platforms. One is definitely on the website, that is aiconf.education. That is the official website. It's also being streamed with Microsoft Reactors, YouTube, and other partners. So that is absolutely great. And having said that, it's time we go ahead and invite our very first speaker of the day. She's Anam. Anam is a Microsoft Learn Student Ambassador, and today she's going to talk about learning deep learning. So let's bring her in. Hi, Anam. Welcome to Global AI Student Conference October edition.
Hello, it's nice to meet you all. I'm really excited for the event.
Thanks, Anam, for accepting the invitation. I really appreciate it. Your session is really, really exciting. That it's about how you can actually go ahead and get started with deep learning. I won't take much of your time. Please feel free to go ahead and share your screen, and then we can get started.
Yes, so let me start by sharing my screen.
And everyone who's watching, please feel free to go ahead and drop your questions in the comments on all the different platforms that you're watching. And towards the end of the session, we'll answer all your questions. So yeah, you can add your thoughts, views, and that will be great.
So I hope you can see my screen.
Yes, I can see you're good to go.
So hello to all of you. I'm Anam Sayeda Fatima, and I'm Microsoft Learn Student Ambassador of Oman. I would like to start by saying that I'm really grateful to this amazing community that connected me with other students around the globe, and also it helped me to build high quality skills. So I would highly recommend you to check this Microsoft Learn Student Ambassador community, and I can assure you that it's going to be very helpful for you. Also, if you would like to connect with me on social media, these are my links on Instagram, Twitter, YouTube, and Facebook. It is @theshecoder. And on LinkedIn also you can connect with me by typing my name. So as you know, today we're going to learn deep learning. So without further delay, let's get started. We humans are amazing at seeing different patterns. Most of us can quickly identify cat, dogs, different handwritings, and some of us can even speak and understand different languages. All these skills are so second nature to us that we don't even think about them. Yet, these same skills are very difficult to teach the machine. Imagine if we could create a machine that could identify different images or could translate all the different languages in the world. To do so, we need to create a network that works just like human brain. Think about the human brain. It is made up of billions of neurons, and these neurons connect together to form networks that allows you to learn things easily, and also it helps you to classify different patterns. So to create a machine that is similar to human brain, we have something called as neural network or deep learning. So the neural network takes what you do easily and scales it up to take the advantage of the speed of the modern computer. This means that we can classify thousands of images at an instant, and also we can translate all the different handwritings in the world. So this is how the neural network looks like. We have many layers. All of these layers perform different functions. The input layer receives the input signals and transfers it to the hidden layer. The hidden layer performs all the back-end calculations, and the output layer transmits the result that is of the hidden layer's calculations. Now, this looks quite intimidating, so let's break this down into one single unit of neuron, which is known as perceptron. So imagine the small circle to be a perceptron, mimicking a neuron in the brain. So perceptron is like a decision function. It takes several binary inputs and produces one binary output, which is either 0 or 1. Now, these inputs can be given weights. And what do I mean that these inputs can be given weights? It means that with the help of the weights, we know how much impact a particular input is going to have in calculating the output. So we're going to multiply the input with the respective weights, and at the end, we're going to get a weight sum. Next, we have something called as bias. Now, what is bias? Bias helps the model to be less sensitive to one single data point, and also it helps the model to generalize in a much better manner. Now, one example that I can give you is to think about a student that has to be promoted to next grade. So we are going to have the marks as the input, and our output is going to be yes or no. Now, we're going to have a threshold value of 0.5. If the student gets marks or the total result of the student is equal to 0.5 or greater than 0.5, that means that the student is going to be promoted. but we're going to keep an exception. We would also like to promote those students who are good at extracurricular activities, but their marks may not be that good. So for this reason, we're going to add a bias. Over here, I have just chosen a bias of 3. So what it does is that when we add these inputs and the bias, we're going to get the result which will be equal to 0.5 or greater than 0.5, and we can promote those students who are good at extracurricular activities to the next grade. So this is how bias helps. It makes the model less sensitive and helps it to generalize in much better manner. Now, one thing we should remember is that the output should always be between 0 and 1. So for this, we have an activation function such as sigmoid activation function that fits the end result between 0 and 1. Now, what I had spoken about was one single perceptron. But neural network contains more than one perceptron and it is quite complex. So to represent the final neural network, you use something called as matrix notation. So over here, we have 3 inputs and these lines are our weights. So we're going to represent our inputs using 1:3 matrix, and we're going to represent our weights using 3:4 matrix. Now we're going to multiply respective inputs with their weights. And then at the end, we're going to represent this whole neural network in form of matrix notation as shown. Now, what are the algorithms that are used in deep learning? So the algorithm we have is a gradient descent, which is an optimization algorithm, which is used to find the local minimum of a function. So how gradient descent work is, I have an example over here. So this is our graph, and this is the equation of a graph. So we need to find the local minimum of this graph. So first, we are going to start at a random point, which is -3. So we're going to start over here. And then we're going to find the derivative. Now, derivative is basically the gradient. So we're going to find the derivative of this equation, that is the gradient. And we should always remember that we're going to move in the direction negative to the gradient. But how much do we have to move is known by the learning rate, which over here we have kept 0.01. It's always better to keep a smaller learning rate than a higher learning rate because a machine that trains much more cycles, and at the end a model can predict accurately. So we're going to substitute all these values in this equation, and in the first iteration, after substituting the value, we're going to get -3.04. So from -3, we have moved to -3.04. Then in second iteration, we are going to repeat and we're going to substitute the values again. And then we move from -3.04 to -3.07. We keep on repeating these iterations till we reach the local minimum, which in this case is -5. Now, backpropagation is a very common algorithm in deep learning that uses the concept of gradient descent. So how this works is that we can perform the feed forward. So feed forward is the same thing which I had explained before. So we have these layers and we're going to go from input layer till the output layer. And we're going to, for each node, we're going to multiply with the weights. Then we're going to add the bias, use the activation function, and we're going to get the result, which will pass on to the next layer. We keep on doing this till we reach the output layer. And at the output layer, we're going to calculate the total error, which is the error between the predicted value and the accurate value. So we're going to calculate that. And after calculating the total error, we're going to propagate all the way back to the input layer. Now, as we are propagating all the way back, at each node, we're going to check how much each node contributes to that error. And subsequently, we're going to update the values of the nodes so as to minimize the error by giving the nodes with higher error rates, lower weight values, and vice versa. Now, what is the framework that is used in deep learning? So one of the framework that is used in deep learning is PyTorch. And PyTorch is an open source Python framework which was developed by Facebook AI research team, and it's very common for it's used for developing neural networks. This is the PyTorch, and I like to think of PyTorch as something similar to NumPy. It's just an extension of NumPy, but it has more convenient classes for defining neural networks, and also it runs faster since it's using GPU. So this was about PyTorch. And one more thing I would like to say is that PyTorch is based on the philosophy of Python. So it's basically Python first philosophy. So its syntax is similar to Python language, and thus it works with other Python packages very well. Now, what are the main ingredients of PyTorch? Tensors are the main data structures of PyTorch that are very similar to arrays and matrices. You can think of tensors as, let me give you one example. So suppose we have a baker, okay? And that baker wants the final output, or the baker wants to produce a pizza. So the dough will be the input and the output is the pizza. But in between that dough, we're reshaping that dough. So in PyTorch, basically, we reshape the tensors so as to fit our final model. So this is how the tensors look like. So we have one-dimensional tensor, which is called as vector. Then we have two-dimensional tensor, which is called as matrix. And then we have three-dimensional tensors. Now, at the end, I'm going to teach you how to build and train your own neural networks. And to do so, we're going to use the Fashionist dataset. The Fashionist dataset consists of 60,000 training examples and 10,000 test examples. So basically, Fashionist dataset basically is very common in AI and machine learning world, and it contains the images of clothes, as you can see over here. And to teach you how to build and train your own neural network, we are going to use PyTorch, Microsoft Learn's PyTorch Fundamental course. So let me show you how to do it. So this is the PyTorch Fundamentals course. As you can see, it has 4 modules. The first module is based on Introduction to PyTorch. And over here, it says it contains 10 units. But then you can exclude the introduction and summary, so it will be 8 units. So I'll just show you how this looks like. So as I explained about tensors, so over here we have a unit which is called What are Tensors? So I'm going to click over here. So yeah, this is how the unit looks like. Now, one thing very good about Microsoft Learn is that it has built-in sandbox. So the big advantage of this is that you don't have to take the headache of downloading PyTorch or then again downloading Anaconda, then Python and all. It has built-in sandbox which you can run then and there. So you can use in a day 10 sandbox, which I guess is more than sufficient. So you have to just activate the sandbox by clicking over here. And this all is free, so you are not even charged. And then, as you can see, they have explained what is tensors. And then again, they're going to teach you from the basics, from the starting. So here is import torch, then import NumPy. And then you can see they have also given how you can make tensors directly from the data or from the NumPy array. Now, what I recommend you is that instead of just running the code and reading the code and running the code, they have an option where you can practice your own code. So you just click over here and you can just practice over here because it provides hands-on learning experience, and this will help you to retain your information for much longer time. So you can just type, like suppose I'm just typing import, and then you can just run the code and it will run. Or you can run from here, but as I said, you should always practice. So it's a very good thing. It's a very great advantage of Microsoft Learn. And then I would say that you check this unit out if you want to know more in details about tensors and how to create tensors from different data structures like NumPy and arrays. Okay, so this was about tensors, and I showed you how Microsoft Learn this looks like. But since we are short in time, I'm going to show you the final unit, which is the full model building process. But before that, you can see we have other units. So I would say that before jumping to this unit, you should go through each unit because they have explained in details from the basics. So your understanding will be very good when you reach the final unit. So let me show you the final unit. Okay, so this was before I have to retry activating the sandbox, which you can do it again. So now let me explain. So PyTorch has two data primitives. One is the data set and another is data loader. Now data set basically stores the sample and their corresponding labels, whereas the data loader, it wraps an iterable around the data set so that you can access individual items. So over here, we are going to import the libraries. As you can see, we have import Torch. And then we're going to import the neural networks. And then again, we have data loaders. And Torch Vision is basically computer vision and contains computer vision packages related to image processing. And then we have to transform. Then, if you want to read about any of this function, you can just place your cursor over here and it will tell what this particular function does. So to tensor, as I said, tensors are the main data structures of PyTorch. So we are using torchvision.transform to transform all matrix or NumPy arrays to tensors. Then you have lambda function, compose function, then matplotlib, is used for visualizing the data. And also, if you want to learn or read more about them, you can just click on this link, which is given over here, and you can read in details about what each particular module does or function does. So now we have preloaded data set. As you can see, we'll be using fashionist data set. So that is preloaded. So we're going to load the data, and in that we have the root. Now what is root? Root basically is the path where the data is stored. So since our is preloaded, we have just given data. Then train is that in machine learning, you must be knowing that there is trained data set and test data set. That trained data set is used for training the data, whereas test data set is for testing, like if a model is predicting the values correctly. So since this is a training data set, so the train will be equals to true. Then, but over here you can see it's test data set. So over there our train is equals to false. And then we are going to download basically means suppose in any case our data is not available in the root or the path, we can download that data from the internet. So we're going to do that true. And transform is again, we're going to convert that to tensor. Now, what is batch size? Over here, we have given batch size equals to 64. Now, one example I would give you is that suppose we have 1000 samples. Now, and if we specify batch size equals to 64, it means that in the first training cycle, we're going to train the first 64 samples. Then in the second training cycle, we're going to train the second 64 samples. So that is what is meant by batch size. Then we're going to create our data loaders. As I said, data loaders are basically, it gives an iterable to the data set so that you can access individual items. And this is basically just giving the shape of the tensor or the shape of how the arrays are stored in the memory. So this is N is basically the batch size N. C is the channel for the channels. H is for the height, W is for the width. So that's where we are going to use x.shape just to see how it looks like, how it is stored in the memory. So this is the output. And as I said, PyTorch or deep learning, usually they run on GPU because GPU makes it run much more faster. So in this code, we are going to check if the GPU is available or not. And as I said, the neural networks basically consist of layers. So over here in the init function, we are going to create the layers. So over here, as you can see, we have flatten module. Now, remember I gave for tensors pizza example where we had the dough and then we had to reshape it so as to get the final output of pizza. So that's what flatten does. It basically reshapes the tensor. Now the input in neural network cannot be, two-dimensional, three-dimensional. It has to always be one-dimensional. And since in fashionist dataset, we are using images which consist of 28 into 28 pixel resolutions. So we cannot provide that as an input. So we're going to use the flatten function so that it flattens it into one-dimensional array, but the elements, all the elements are still present. It's just that it's in one dimension. And the linear is basically creating the layers. So as you can see, create single layer so as to perform the feed forward. Feed forward I had explained from the input layer till the output layer. And another over here is a ReLU. Now the sigmoid activation function was used back in 90s and it was very common in deep learning world. But now in recent times, since sigmoid function was difficult to train because of GPUs, we are now using ReLU, which is rectified linear unit. So ReLU is basically an activation function. We have different types of activation functions. And ReLU basically does is like the input, if it's greater than 0, is going to give the same input. But if it's less than 0, it's going to just print 0. That's ReLU. And in define forward, we are going to perform the feed forward propagation, as I said. So over here, we're going to perform the feed forward. So yeah, there you go. Now in Microsoft Learn, they already have GPU. As you can see, built-in GPU is there. So that's a very great advantage. So it will train faster and run faster. So as you can see, using CUDA device, and then you have all this input and output and bias. We have provided the bias also. Now, next we're going to optimize the parameters. So I had, what is cost function? So the cost function is basically the error between the predicted value and the accurate value. And we always want that to be minimum, as explained in gradient descent. So this is what the cost function is. Over here, we have cross entropy loss. Then we have learning rate, that is how much from the gradient descent, how much we have to move from the gradient descent. So that's where the learning rate is. And if you want to learn more about it, you can just go to these links which are provided. Now, as I said, at the output layer, we're going to calculate the total error. So this is where we're going to calculate the total error, and then we're going to perform the backpropagation. Now, these things are explained in much more details in previous units, so please check that out. Then over here, we're just checking the model's performance against the test data set. And this is where our training takes place. Epochs is basically the number of training cycles. So we have kept our training cycles equals to 15. And you can see the loss increases. It's from 2, the loss increases quite a lot. And our accuracy also increases. So our final accuracy is 70%. Then we're going to save and load the models. And yeah, this is how the final model will look like. It can now be used to make predictions. So you can see we have printed the predicted value and the actual value. So as I said, our model had predicted it was an ankle boot, and actually it was an ankle boot. So there you go, our accuracy is correct, our predictions are correct. Now, at the end, I would just like to wrap up by explaining one very small topic, which is the convolution neural network that will be there in the next modules of this learning path. So let me just start. So basically, convolutional neural network is quite different from the neural networks that we had discussed. The convolutional neural network does not contain, weights and neurons, but instead it contains layers. It casts multiple layers on images and uses filtration to analyze the image inputs. Now, one example that I can give of is, I can think, suppose we have a model that is used for predicting if it's a cat or dog. So in artificial neural network, you have to give the width of the nose and the length of the ears. But in convolutional neural network, we do not have to do that. The convolutional neural network by itself picks up these features, and you do not have to explicitly provide those features. So this makes neural network very useful, and it's very ideal when thousands of images need to be extracted. So that's the reason why convolutional neural network is used for working with image data, audio data, and text data. So the next modules are going to contain those things. So I would need to do that. So we just have over here, introduction to computer vision with PyTorch, natural language processing, and audio classification. So yeah, you should just do this. And with each module that you complete, Global AI Student Conference is going to plant a tree. So let's help our Mother Nature too, and let's help ourselves too by learning all these informations. And yeah, I hope you enjoyed it. Thank you so much for joining. I really enjoyed giving this session. So thank you.
That was absolutely great session, Anam. You did cover what is deep learning. You talked about gradient descendant. You talked about backpropagation. You also talk about the frameworks and an absolutely amazing Microsoft Learn modules that we have that people can use to go ahead and get started. I think it's time. We'll continue the discussion of this AI and deep learning in the following panels that we have that will be taken by Dimitri. So everyone who's watching, please continue your questions coming in as we'll take them after this panel. And Dimitri, from here, it's all you now.
Thank you so much, Simon. So actually, yeah, let's continue the same topic. Now we will kind of discuss what is really the best way to learn deep learning. Anna did a great introduction, and I hope she convinced you that Microsoft Learn modules is indeed one of the great ways to do it. Let me introduce myself. I am Dmitry Soshnikov. I work at Microsoft, and I was one of the authors of this module. And we have the great panel of speakers here, and I think I will let them introduce themselves. And while you are introducing themselves, can you please also tell us how you started your not career, but how you started learning deep learning yourself? What was your first experience? Let's start with Amir. Amir, you are on mute.
The usual mistake. Okay. Hello, everybody. My name is Amir Pur Abdullah. I am from Nottingham Trent University in the UK, and I run the course of artificial intelligence here for undergraduate and postgraduate students. So I'm very happy to be here. So in terms of the deep learning, I can just tell you that this has been one of the exciting parts of my module when I teach to the students. So when we come to the deep learning, they can see actually the real practical value of neural networks and convolutional neural networks. So for example, things like the similarity of that to how we process images in our brain, or when it comes to deep fake or deep dream, or also generative adversarial networks when we see some artworks made by computers. All of these are some exciting parts for my students. Thank you.
Thank you, Amir. Who wants to be next?
Okay, so I will start. So my introduction was already given before when I started the session. So how I came to deep learning is that I would first like to thank Microsoft Learn Student Ambassador community. It was because of Microsoft Learn Student Ambassador community that my interest in AI and machine learning ignited. So before I became Microsoft Learn Student Ambassador, we have so many different paths like game development, web development, etc. So I was very confused, like which path should I choose? But once I became the Microsoft Learn Student Ambassador, we had to choose a league. So it was compulsory for us to choose the league. And because of that, I chose AI and Machine Learning League. And then we had to complete the learning paths in Microsoft Learn. So I did that. And because of that, when I started learning, I'm like, okay, wait, it's very interesting, this AI and machine learning. And after that, I decided that I'm going to pursue my career in AI and machine learning. And then I started taking workshops for other students. Whatever I used to learn from Microsoft Learn, I used to give workshops. And then deep learning also, what had happened a few months back, I had got a scholarship from a very famous platform. And in that scholarship, we had a course which was Introduction to Deep Learning. So I completed that and I came to know about deep learning. Then from Microsoft Learn, I did PyTorch fundamentals. So before that, I only used to know the theory part of the deep learning. But after combining these two courses, I came to know a lot about deep learning.
Thank you. Syed, what about you?
Yeah. So hey everyone, this is Syed Farhan from Bangalore, India. So I'm currently a quantum computing research intern at University of California, Los Angeles. And my area of research is a mixture of artificial intelligence and quantum computing. So I'm also a fourth year undergrad student from Bangalore. And I got started off with artificial intelligence back in 2018 when I joined university. And I came to know about the Microsoft Student Partner Program. That's what it was called back then. Now it's the Learn Student Ambassadors Program. And it was pretty interesting to see the entire community coming together, teaching artificial intelligence, coming together, having workshops. And that's when, again, my interest in AI sparked up. And I also took up a course in my university on machine learning and artificial intelligence. And then I started working on several projects. And that's how I landed several internships at JP Morgan Chase and also at University of California, Los Angeles. Yeah, thank you.
Thank you. Rishit?
Sure. Hi, I'm excited to be here. Thanks so much, Dimitri, for having me over. I'm Rishit, a Gold Microsoft Learn Student Ambassador from India. I'm also a high school student and a 3-time TED speaker. I particularly love working with researching about machine learning, especially computer vision. And that's what I'm fascinated by the most. And I also try to share my knowledge with the community, and I mentor at the TensorFlow user group in my city. And I'm also quite interested in machine learning research. I've published quite a few papers on machine learning and maths, mostly about computer vision pertaining to my interests. And I also love hackathons and competitions. And I've also represented my country in some and won some on the international stage as well. And finally, I also love open source, and you can find me contributing to some open source projects I love. About how I got started into machine learning, my story is I was pretty interested in maths since a young age. And somewhere along the line, I found something as simple as I tried to explore something as simple as the raw gradient descent. And I could see it very well corroborating with what I had learned in my class. In my class, I was learning all about applications of derivatives and how you can find minima and maxima. And the very standard gradient descent was just a method to do so. So that kind of sparked my interest in machine learning in the start. And I also watched a nice podcast by Ian Goodfellow. I'm sure his research is read by most of us over here. That's how I started off in machine learning. And then I formally took up courses by Andrew Ng to learn more about machine learning. So I was pretty fascinated by how machine learning can bring novel ideas. And I started learning more about it through Microsoft Student Learn Ambassador community and contributing to open source projects. I majorly contribute to TensorFlow. I contribute to TensorFlow a lot. So started learning more about machine learning and developing a taste for it along the way.
Excellent. So let's talk a little bit about learning deep learning. So Microsoft Learn is the text-based course. You have the notebook, you can read content, you can execute code. That's one style of learning, but there are also a lot of courses which are video based, like many MOOC platforms like Coursera. They are like they show videos like lectures. And how would you compare that? I mean, which one do you find more comfortable? Which one do you prefer? I think Anam or Rishit, you can give some feedback on this.
Yes. So I had an opportunity to learn deep learning from Microsoft Learn Learning Path and from another popular platform. So in Microsoft Learn, learning is much more text-based, whereas in other platform learning, it has more videos. So I would like to say that I like text-based learning much better. So why I like text-based learning better is because at times, you might already be knowing a particular topic, but you may not be knowing parts of that particular topic. So in video-based learning, you have to go through the entire video to find out which part you want to learn and which part you have to skip. So that takes time. But in text-based, what happens is that you can directly go to that topic which you want to learn and can skip all those topics that you already know. So it's much easier and faster. Also, at times, suppose you want to quickly refer, like, okay, I just want to go through this topic. So in video-based, you have to, again, check where the topic is starting, then where the topic is ending. But in text-based, you can just directly go to that topic. It's like you don't have to go through each unit or each topic. You can just go directly to that topic. And then that makes it, quite faster and easier. Also, in a video-based, there might be sometimes, speakers whose accent might not be that easy to understand. So in text-based learning, you don't have to take that worry that whether you're going to understand what they're going to speak or not. You can just read it yourself and understand that by yourself. And also one very good thing about Microsoft Learn is that when I did the another course, I could not find the runnable notebooks. So for that, I had to again, download PyTorch in my own laptop, then Anaconda and all those things. So that was kind of complicated and not that easy. But with Microsoft Learn, you have runnable notebooks. So you can just run then and there. You don't have to download anything in your laptop. So yeah, this was a very big advantages of Microsoft.
Great. Go ahead.
I couldn't agree more with the points put forward by Anam. But I might be a bit biased towards video form of content just because I started learning a lot about machine learning through the graduate courses by MIT and Stanford. You can just go on to MIT's OpenCourseware and find real lectures given by at MIT or Stanford and other such universities. So often it happens that for some math concepts, you need someone to explain it. It might be really great to have someone draw it up or write it right in front of you. So in some cases, when you are learning more of theory-based stuff, it might be really good to have some videos on your side too. But in any case, I think doing your own work, running your own notebook, trying to edit the code, all of that is super important, even with video-based or text-based, both kind of content.
Thank you. You actually made an excellent point that for a theoretical kind of course, you need a person telling you something. So video-based learning is good. But if you know some basics, you want to catch up on technology, then text-based is much faster. I wonder, like, how does this work in academia? Can Microsoft Learn course, for example, be used in teaching together with the lectures from real people and real professors? So Amir, please share your thoughts on that because you probably have some experience.
Okay, thanks very much, Dimitri. Yes, the point raised by students are quite correct. Actually, everybody has his or her own learning style. So basically, it's quite subjective issue here. We can't say which one works better for each individual. So in academia, we try to have a mix of all the resources and do something in between that people can benefit according to their own learning style and signpost the students to more resources, either videos or text, to go and watch or learn from on their own time. For example, in my cases, I usually start from the text-based style of learning, or teaching, and then signpost a student to have some more videos. Perhaps I show them some short videos in the class, but not the detailed videos. I give them direction to do that. My teaching style is a kind of mix between the coding and concepts. So I prefer to have mini code and mini concept or mini lectures in between each other. So for example, if you look at the website of PyTorch, is a code first approach, but perhaps in other websites we have a theory first approach. So I prefer to have a combination of them. So that's quite matched to the way that Microsoft Learn recently is doing or is providing their materials. So for example, the example of the having embedded notebook within a PyTorch learning environment is a good example. So people can have a quick look at the theory, and at the same time they can practice it on their notebook. So for me, it is a quite efficient way of teaching and learning experience. So yes, so my approach is basically to give all options, but and try to give the enough resource materials to the users, to the students. Thank you.
Thank you. I actually want to take the opportunity to thank Syed and Rashid, who had a chance to review the PyTorch learning pad before it was released to the public. Can you maybe share like your experience? What are your thoughts about the content? Is it something that really needed by students, or we need to do some more?
Yeah, sure.
So yeah,
love to talk about it. Yep. So I'd like to say thanks, Dimitri, for giving us access to the course before it was released so that we could give some positive feedback. So the moment I had a look at code cells, which can be run directly along with the tutorials, it was pretty much fascinating initially. That was a initial overview. And then the moment we have GPU support right in the browser for free, which anyone can try, is also something really interesting to note. Talking about specific modules, in this case, I'd like to talk about a module on basically capturing patterns with recurrent neural networks. That was pretty interesting. LSTMs were introduced. They were spoken about. The math background was given about it. There's pictorial representations. And then there's Jupyter cells where you can try out stuff, which was pretty interesting, right? Then another module which caught my attention was basically the audio transforms and visualizations as part of the final learning module, which is learning path, which is available. So the reason why it caught my attention was I'm working on a similar project of basically working with spectrograms, MFCC values, basically working with audio data, transforming it into the frequency domain, doing machine learning stuff, and pretty much use it for classification, use it for clustering, etc. But this module introduced spectrograms from the beginning, the way audio signals are represented, the way you can convert that audio signal, extract values out of it, which can pass into a neural network, in this case, a normal neural network, or it can pass through a complicated neural network, which was pretty good, I would say. So it's very exciting stuff indeed. If you guys haven't tried it out, you should definitely give it a try. I'm sure you're going to love it. Thanks.
Yeah, and it's interesting that you don't often find a lot of materials on audio, because like images and text is something that you have a lot of tutorials about, and audio is somehow left behind. So I agree that's a good
part. Yes.
We have the great question from somebody from our audience. Marek asks, can I learn machine learning or deep learning without study? And I would rephrase it maybe and add a little bit, not without study, but maybe without learning a lot of theoretical background in math. Like, is it possible to master deep learning or machine learning, let's say, just by maybe doing some, learning some software things? What do you think?
Yeah, okay. I can totally relate to this question. When I started off with machine learning, I was like, oh, the math is so difficult. Should I go through the entire theory, or should I just directly jump into how to create a neural network, right? Because TensorFlow, PyTorch, these libraries, these frameworks allow you to just write some pieces of code, and then you don't have to know about the mathematical background to a great extent, right? So what I did instead, I started off with Azure Machine Learning Studio, which basically is drag and drop stuff. You drag and drop the type of network you want, the type of data pre-processing you want. And from there, I got some intuition of how machine learning works. and then moved into the theoretical side of it. So to answer your question, yes, it's possible to learn machine learning. I mean, there are a lot of business-oriented people who are going through tutorials which do not involve a lot of math. So it's definitely possible to work with data, pre-process it, do some machine learning stuff, and then get results, classification or clustering results. But if you want to move into research, if you want to actually understand what's happening inside, then you will need to learn the theory behind it. I mean, that's pretty much from my experience.
I could probably add on to something that Syed already said. Really great points. Thanks for sharing those, Syed. And I feel this too, that if you don't know a lot of maths, you can still learn about practical machine learning. But I would rephrase it to say you probably do not need all of the maths. So you probably don't need to know how to do integrals under signs for working with classification. A lot of that is abstracted away from you. But what I would say is, if you're working with practical machine learning, I've often found it really helpful to know if I'm working with a new algorithm, which I just want to try out. I've often found it really helpful to know a bit of maths, which is super helpful in case I want to customize the algorithm or probably do some pre-processing or some post-processing after the outputs to help me put it on my data. So I'd rephrase this to say not all of the math would be required if you want to go into practical machine learning, but it's really, really helpful to know quite some of the math. And if you're going into research, I'm pretty excited about machine learning research myself. In that case, I think math is a part of machine learning that excites me the most. So yeah, if you're going into research, I think maths would be super important.
And one more point, if you are going to implement some cutting edge, like in machine learning and AI, you probably would need to be reading scientific papers on that, and that you cannot do without math. So yeah, it's a wide spectrum, and you can do without math, but on the cutting edge, you need some math. Amir, any comments from you? Yes,
I agree. Yes, it depends on how deep you are going to work with this. Is it just a kind of shallow in deploying some machine learning or training model, or if you want to do for some advanced technology or cutting edge? So if people are really struggling to start with the math, perhaps one solution could be to start programming and to start do practical things when they see there's something is missing, and when they see that something is basically making problem for them to go forward, perhaps they can come back and review only those mathematical subjects which are necessary to go forward. Otherwise, as Rashid said, not everything might be needed by everybody from the math perspective.
Yeah, one more question that we have is what are prerequisites for learning deep learning? Like what you need to know to start?
From the mathematics?
I think that's pretty broad, like what you need to do to start.
Well, I think some basic knowledge of machine learning and data analytics would be necessary. Then we need to have some basic understanding about the neural networks starting from perceptron and going to some multi-layers. And then when we talk about the convolutional neural network, then we basically make a specific type of multi-layer perceptron to satisfy a specific job for image or audio classification. So yes, it may need some basic knowledge of data and data analytics, what is machine learning, and some basic knowledge of neural networks.
And also, sorry, yeah, also a lot of code.
Dimitri might have a better advice on this.
I just wanted to mention that a lot of code is also written in Python, so you should probably understand like basic Python. And
yes.
Apart from that, yeah, it shouldn't discourage you from starting, definitely. Yes. And one more question that we have is machine learning better than web development for beginners? That's an interesting question. What do you think?
It depends on what is the direction of the job or career or ambitions that the person has. So each one of these may lead to a different or basically separate parts of services, basically.
I wonder. Yeah, I think let's go and hear what other participants think. Like, what do you think, Anam? Web development or machine learning?
So what I felt like starting, as I said before, Microsoft launched an ambassador, I was like, I should go for web development. So in my initial college years, I had done web development, but like I had just started the basic of web development. But then if I feel like, but then after Microsoft launched an ambassador, then I saw like, I was really interested how these things works, like how computer vision, where, you're just placing your mobile and then you can, the mobile is like, okay, it's identifying the different images, right? And then you have natural language processing where, this Siri and Alexa and all these Cortana, they all use natural language processing. So then from web development, I was like, no, I should look for this because that was much more interesting for me. But then it actually, as Sir said before, Amit Sir said, like, it depends upon you, what career you want to choose. But for me, as I said, I jumped from web development to machine learning.
Yes.
Yeah, I think web development is not likely to excite you very much because web development is very traditional. You just do websites. In AI, you are doing cutting edge. As Amir mentioned, computers, they start to produce pictures. They can write music. They can write texts. And that is really amazing. So it's like the barriers, there is no limit to what you can do. And that is, I think, really fascinating. But it also requires kind of more constant learning, like keeping up to date with your knowledge and so on.
Yes, I can also add that why not mixing these two together? So they might have some kind of web development which are empowered by artificial intelligence backend. So think about mixing them together. Don't draw a border.
Yeah, there is one question. How can we start a startup in the field of ML? So I guess in general, like ML is probably will open you more thoughts for original ideas, like in startups. So anyone has a comment on ML startups, how to start? Okay, so I think you should start with the idea, right? So it's not fair to ask us how to start a startup because if we had the great idea, we would have done that ourselves.
Yeah. So machine learning is just a means of achieving your goals. So first of all, draw your goal, understand what you are going to achieve, and then perhaps web development, machine learning, AI, other technologies are going to help you to achieve your goal. They are not themselves goals.
Right, and we have also in the comments somebody saying that linear algebra is important as a prerequisite for deep learning, which is, yeah, absolutely correct because we need to know how to multiply matrices. And I think we forgot to mention that because, like, it's probably very natural for us to know that, but indeed not everybody does. So yeah, the final question, Gupta is asking how to convert from existing applications to AI. Are there any tools that can be used in existing applications? So maybe yeah, go ahead.
Sorry. So I could probably give you a rough answer for this. There's no one correct answer, and and I think there are a plethora of tools. The first thing being you need to identify what kind of problem you want to work with. Then you can probably use cognitive services or custom vision, or probably there are so many wonderful machine learning APIs out there. If you have a general kind of use case you want to work on, if you want to do probably something, if you probably want to do something more customized, you might want to develop your own model or fine tune an existing model. So there's a plethora of tools available. If you want to create your own models, you have a large number of frameworks. And on Microsoft Learn, you can also see modules about PyTorch and TensorFlow and start working with those. If you want to make use, or if you want to fine tune an existing model, not make one from the ground up. Probably use researchers' work who have built models on millions of images and trained for days. You can still do that with all of these machine learning frameworks. And actually, fine tuning is also there on the Microsoft.
Thank you, Rishit. And I want to thank all the participants of this panel. We are running out of time. So any other questions we can try to answer in the chat. So thanks again for taking part in this. And let's see next talk in the conference. I will pass it back to Simon or
All right, so that was a great panel that you just saw from the Dimitri and the other Microsoft partners. I now have a co-host with me, and Nigama, welcome to Global AI Student Conference.
Thank you so much. That was a great session on personal development and machine learning and how to learn for beginners. So in our next session, we're going to have a session about recommendation systems and different types that are used in our daily lives. Our next speaker is Kaushik, and he's a final year undergrad student, and he's also a Microsoft student ambassador. So let's welcome Kaushik.
Yeah, hi.
Hi, how are you?
Yeah, I'm fine.
Hi, Kaushik.
Yeah, so the stage is all yours.
Sure,
You can take it.
So let me know whether my screen is visible or not.
Not yet.
Yeah, I think it's.
Yes.
So, so hi everyone. Like I'll be speaking about recommendation systems and their types in our daily lives and all the different applications that we have. So, like speaking of myself, like I'm also a Microsoft Learn student ambassador. I'm currently doing my undergrad final year at PVRIT. Which is in India. So, like I'm also a research intern at Carnegie Mellon University, Thailand before. So I'm currently working as a machine learning engineer at Omdana. So I'm really passionate about machine learning, deep learning, data science, and all the different applications. So especially recommendation systems, natural language processing, etc. So like let's get started with this. So like for today, we'll be speaking about the introduction to recommendation systems. We'll be like diving deep into real-time applications that we have, and also like we'll also like work on like checking out different types of recommendation systems. And also like we'll be checking out the Microsoft Azure services for recommendation systems, and also I'll be linking all the resources that are being used so that you can try out like afterwards, like you can go and research more and like more regarding the other topics if you really want. So like coming to the introduction part, like recommendation systems are like general data science application. Like data science is all about providing insights, but coming to recommendation systems, it is all about providing recommendations to the user or to the customer or to any different organization. So like recommendation system itself is present in like each and every field, like coming from healthcare, finance, e-commerce, etc. Like each and every field is using recommendation systems. So like one thing, first of all, let's understand what is a recommendation. So for example, like if I want to go to a pizza place near my home, so my friend suggests that like there is a new place which has been opened, so that like which the pizzas are really tasty and also which is really affordable. So then like this is some kind of indirect recommendation that my friend is giving. So this is something up to me whether to take it or not. So this is something like one-to-one interaction that is going on. So this is some basic thing like where it will go on till the Netflix applications, which is like Netflix recommendation systems, and also like which is the main thing, which is Google search. So when we type a word, we'll get the entire words in the sentence. Like there's a lot, like much better like percentage that the words we are typing is the right one. So coming to the real-time application part, so nowadays, like recommendations are everywhere. So like, for example, when we choose like entertainment zone, So some of the like movies and TV shows that we actually get up as on Netflix and Amazon. So like there are multiple algorithms which are actually used in Netflix. For example, when we first subscribe to Netflix, and then like it will ask you to choose a genre, which is like whether it may be action or whether it may be a comedy or any other thing. So like for example, if I choose action, I'll get all like for one section which is like only like only related to action movies or action shows, etc. So these are like actually sorted based on the popularity. Like when you choose a movie there, it will tell you the popularity index. So this is something which Netflix, Amazon Prime, etc. does, which is based on the entertainment entertainment things. So like, and also like LinkedIn uses recommendation systems. When we actually use LinkedIn, we have different types of connections, like first degree connection, second degree, or third degree. So this is like the people who are very close, and also like which are like segregated into different levels. So like the other applications are based on location, like food delivery apps. For example, I want to actually like book some order, etc. from my application. Like it will actually show all the all the located ones which are nearby. So which is like recommendations. So we can choose it or not. Like it is up to us. So then like Amazon, Flipkart, and all the other e-commerce websites uses recommendations very hugely. I mean, for example, when we choose Amazon or Flipkart, like we get the running list of top selling products or like each and everything from that. So we can choose something which is like whether like people are choosing more on that, which is the top selling products that are represented like on the top shelves, etc. So the other real-time applications that we have is like which is used to determine the destinations for the users, which is done by Airbnb. So Airbnb is a very famous company outside India. Like they're like what this is basically does is like it will like recommend, or it will give you some recommendations which are providing some real-time destinations which you can choose from. Like there are like multiple filters that are available there, so you can choose like many different locations based on, and also your kind of like income and also income based things, etc. So the next thing is like for example, when we choose a product on Amazon, it will ask you from which like retailer you want to purchase from. So there are multiple of retailers below, so it will recommend you to choose from any one, but it will like by default it will choose you one, but you can choose anything from that. And also like coming to other applications like music based applications, we have Spotify. So Spotify is like, for example, if you like one type of genre, it will actually give out the recommendations based on other view patterns of other people, which will make a more and more personalized based on other users. So like on the below side, you can see like the first one is like based from Amazon. So it will tell you more people have chosen the products from the like below 4 cameras. So this is like one-to-one recommendation for yours. And then like the next screen. So the next like screenshot is based on which is LinkedIn. So it is actually like suggesting some of the like well-known newsletters so that we can like subscribe them, etc. So these are some of the real-time applications which are used. And coming to the base case, which is like base cases or business case for recommendations. So because recommendations itself is a very big deal, because like if a company does not give out good recommendations, it's going to lose out a lot of revenue, and also like they can like certainly go into debt also. So there are many things to assume like before building a recommendation system. So some of the cases that have to be taken care of is like the first one is relevance. So like the relevance itself is like how relevant are the recommendations to the users, like whether they are getting the right recommendations or like different recommendations. So based on that, it is really important for this for the organization to choose from. Then comes the novelty effect. Like the novelty is something like to attract the users based on different different offers, etc. on an like application on an e-commerce website or etc. So then comes the serendipity part, which is serendipity is nothing but like surprised or happy. So for example, once a user is searching for an object or for a product for a long period of time, and like for example, he he has recommended that product which is like he will be kind of surprised to see that which is a great recommendation. So the next one to consider is the increased diversity part. So like increased diversity part in a sense, like for example, if you want to purchase a mobile phone, so like you can like select a filter from maybe select from 10,000 rupees to 1 lakh. So like it should provide all the mobile phones from that range, which is from 10,000 to 1 lakh. So it should it should not only showcase the top which is 1 lakh products or the 10,000 products. It should kind of have the frequency, like it should display each and every set, which is from 10,000 to 20,000, etc., like till 1 lakh. So this is like these are the 4 factors which are really important when it comes to recommendations. When we are actually building recommendation systems, the most important thing that comes up is the data understanding part, because like for data understanding, we require a lot of time, first of all, to understand what the data is offering us, and also how we can create a recommendation system from that. So like before building any recommendation system, like these are the 2 things that we have to consider, which is like understanding the data characteristics and also data cleaning. So like when you work with machine learning or deep learning or data science, you will know that most of the work, which is like 60%, just depends on data cleaning. So like this is also very important when it comes to recommendation systems. Like for example, like I want to actually show like how like for one use case where we build the like user item matrix, which is for recommendation systems. So here to build a recommendation system, like we have a movies data set. So where we have the movie ID, where we have the movie and also the genre. So like here, for example, like when we want the like date, which is for like the first movie, which is the ID 8. So we we want the date, which is 1894, in a separate column, so that we can sort it out like based on different metrics that based on different algorithms and the use case. And also coming to the genre, we can actually identify that it is not like sorted properly. I mean, there is a slash between documentary and short where it has to be separate. And also we have some NaN values, which is like in the movie ID 25, we have the NaN values. So we don't want the NaN values, etc. So like this is some code that I'll be presenting now, which is like the first snippet, which is on the top left corner, is based on like whether there is a kind of a date which is present with the column or not. So like we will be using some slicing operator. So based on the slicing operator, we'll check whether there is a date or not. So if there is no date, we'll be just simply using NaN. Otherwise, we'll be providing an other column, which is from we'll be creating other columns like 1800s, 1900s, and 2000s. So this is like an alternative method to use like based on one-hot encoding. So like one-hot encoding is like just a function that you can use, but this is like more like default manner that you can use. And the last snippet that I'll be using here to actually like do the data cleaning part is like for each and every genre, you will be you will be placing them into separate columns, and like inside that column, if the movie ID has that genre, it will represent 1, otherwise it will be 0. So this is the kind of output that you can get after doing the above 2 functions. So like based on the genre, we can see that for the first movie ID, we have genres as documentary and short. So here, for the column documentary and unswim row, we can see that the value is 1. And for all the other things, it's 0. And also, like the date is 1894, so it comes under 1800. So it was mentioned as 1. So this is a kind of alternative that you can use for one-hot encoding. That is some like technique which is present in machine learning. So coming to the different types of algorithms that we have in recommendation systems. The first one is the rank-based recommendation system. So this is generally the most used recommendation system that is most popular in sites like Amazon or Netflix or like all the other things, where we will get the popular items, for example, like popular books or popular shows or famous items, etc. So this is actually based on the sorting mechanism which is done. So sorting mechanism can be done in ascending or descending order, which is based on completely the use case and also the different kind of things that we'll be dealing with in that project. So and also one more thing that we can actually say with this rank-based recommendation system is that this is not personalized to the user, because this is related to the whole general population. Whole general population in a sense, it will it will kind of infer from the entire population and it will give out the results. But we may like it or dislike it, like it is up to us, but like this doesn't seem to be personalized to many different users. So like for this kind of alternatives, we have different algorithms like knowledge-based recommendation system. So for this knowledge-based recommendation system, so this is kind of a recommendation system which is actually based on a rank-based recommendation system, but like there is a small extension which is added to the like before base system, which is like the filter. So like so the filter, in a sense, like on the right side, you can see that like you can actually choose number of baths and also the square feet and also the lot size, ear belt, or like home type, like days on Zillow or keywords, etc., and then click on apply. So this is something like more personalized to the given user or the customer, so that like he can have a choice to choose from. And this is like a small extension, and also like he or she can get more freedom to choose from, like other than the whole general population results that the rank-based recommendation system is like giving out. And also like there is one alternative to rank-based recommendation system, like instead of sorting, etc., we can also use the weighted average. So based on the weighted average technique, we can also get the like recommendations by sorting their like weighted average thing. So like coming to the other recommendation system, which is very personalized and which is like kind of like used in all the different applications, which is called as collaborative filtering. So like for this collaborative filtering, like it is based on like it will give out recommendations which is completely based on other users, which is like other users in a sense like we'll have some transactional data or the historical data. So from that we'll be inferring inferring from our choices and also from other data, and based on that it will be giving out recommendations. So like here, like we can have different kind of filtering, which is like item to item filtering, or item to user filtering, or user to user filtering. So it totally depends on the use case, and also it totally depends on the application that we are using in the project. So like on the right hand side, you can see that we have three different users: user 1, user 2, and user 3. So they are choosing like different different things like oranges, like we have banana, apple, and strawberry, which are different fruits. So for example, when user 1 is picking orange, apple, and banana, and user 2 is picking orange and apple, and user 3 is purchasing, which is the apple. So like if you if user 3 wants more and more recommendations, so then what it can say, like info from that is like user 1 is also liking banana, which is apple, and also it is also liking orange, and the user 2 is also liking apple, which is chosen by user 3, and like user 2 is also liking orange. So based on that like understanding, orange is also recommended to user 3. So this is like based on like not the like general population, but it is like individual population. Based on that, we will get the insights and we'll get the recommendations based on that. So for like another one more example that I want to like mention here is that, like for example, when let's say John watched Titanic, Avengers, and Avatar, I think like everyone knows this kind of films. So like if Lily saw Titanic and Avatar, it may like also recommend Avengers to Lily based on the John's view patterns, because like there is some kind of similar movies which are present in both the view patterns. So this is like collaborative filtering approach, which is present in all the different applications that we are using currently. So like another example that I want to mention here is like we have 4 different users, and we have we have a main user that like he wants to get the recommendations from. So like for example, here like let's say like he has already seen some movies, so that is crossed out like already. So based on that, we only have some movies, but afterwards, like we don't want to recommend each and every movie to that user, but we want to filter out like some person may give like 5 out of 10 rating, some person may give 9 out of 10 rating. So we don't want to recommend like ratings which are below 5 or 6, and like we only want to recommend movies which are like created more by the different users and which has similar taste, etc., based on different genres, etc. So like based on that, like the user will be getting recommendations which are filtered, like more personalized, and also like there is a greater probability or the greater chance so that the user may like that. So coming to the other recommendation systems, which is the content-based recommendation system. So like previously we have discussed about collaborative based filtering. So in that collaborative based filtering, like we need to have transactional data, which is the historical data. Like otherwise, we cannot infer from that, or we can do different operations like nearest neighbor, similarity metrics. So that is really necessary. But coming to the content-based recommendation systems, we don't need the historical data. We only need the characteristics of the data. So like before it was based on behaviors, but this is based on characteristics. So for example, like when I want to purchase a bicycle from Amazon, so it will actually tell me all the like other recommendations like helmet or all the other things which are related to bicycle, where other users may also purchase, or like it is related to bicycle, like it is something where it has some similar characteristics with all the other objects. So like coming to the genre, it's left, for example, if I choose Iron Man, it will recommend me like all the other action movies, because Iron Man comes under action and also like other genres. So like based on that, it will give out the genres that are based on that genre itself. So like here we don't need the like user item connections like that we like before that we need for the collaborative based filtering. So like more things you can explore is that like there are many different algorithms. So some of the other algorithms that you can choose from is the weighted average algorithm. Then we have the SVD algorithm, which is very famous, which is singular value decomposition algorithm. And then we have the FunkSVD algorithm, which is kind of extension to the SVD algorithm. And then we also have different techniques that can be based in deep learning and machine learning techniques. So like coming to the SVD algorithm, this is like so this includes matrix factorization, and also like this algorithm doesn't work with null values, so you have to clear out you have to clear all the null values, and then you have to use this algorithm. So but coming to the FunkSVD algorithm, this is like you can have null values in that. So it is just based on the latent features that you have. So based on that, it will actually get the recommendations and it will provide the recommendations. So that is all about FunkSVD algorithm. And like if you're really interested about like FunkSVD algorithm and collaborative filtering, so these are all the projects like that I did. So I'll be actually like listing out at the end so that you can actually like go there and practice afterwards. So like coming to the like Microsoft Azure services for recommendation systems. So we do have a lot of different Azure services, but I'll be speaking about products recommendation service or the solution. So so this is actually tailored towards e-commerce or like based on like e-commerce based solutions or problem statements. So this is like for e-commerce. Product recommendation is the most important feature. Like almost all the e-commerce are using this, because by providing better recommendations, they are able to get more more result in terms of more money, etc. So and also they are providing more user experience to the users. So like the only requirement here for this Microsoft Azure service is, which is for the product recommendation, is we need historical data, because the underlying algorithm for this Azure service is like the SAS algorithm. So like for the so inside the SAS algorithm, the running algorithm is a collaborative filtering algorithm. So like as previously we have seen, we need the transactional data, which is the historical data, so that we can get the recommendations from that. So like from the product recommendation solution, we can get two types of recommendations. So the first one is the like item to item recommendation, and the second one is the personalized recommendation. So like the item to item recommendation is something like which is like more like content based recommendation, where you don't need the historical data and it will just take the characteristics, and based on that it will give out the recommendation. But coming to the personalized recommendation, it is more like collaborative filtering, which uses some filtering algorithms like cosine similarity or other things, where like based on that it will give out the recommendation, and for this you need the transactional data. So this is the main reason that for this service we need the like data. And also one more thing regarding this service is that like all the data should be present in a normal like different form that is mentioned. So you have to like adjust all the variables and also all the columns based on that, so that you can use that data to train that in the Azure, using Azure services. So like speaking about the architecture of the system, which is based on the Microsoft Azure service, which is the a product recommendation solution. So like first, when we actually create the product recommendation solution, like we so with that like a web application will be deployed with that, where it will have an like inbuilt API, where first of all, API is an application programming interface where it can actually get the request and also to like transfer all the requests from one side to other side, which is from user to server or any other thing. So like from the like app service web app, like it will actually like first it will create the like web application, it will deploy it, it will create an API, and then like from that it will create an Azure storage service where it will use the blob storage, it will create tables, and it will also create queues. And and afterwards we have the job like web job instance, which is used for like training machine learning algorithms or any other algorithms here. So like when the data is transferred from the like product recommendation solution, which is like all the data is stored in the transactional data, which is the historical data that I was speaking about. So like the historical data, which is like stored in the blob storage, will be like going towards the web job instance where the algorithm is trained, and then it will be transferred again to the blob storage, where from there you can use the algorithm. So for example, when we have the data, which is like when like all the training part is completed, and then when we want to like get the recommendation for some for ID, etc. So we give that like through an API when we provide that request to the Azure storage, and like this process will be pretty fast because like the training process is completed. It will just give out the recommendation from the Azure storage service. It will like provide like it will transfer from the storage to the training client or the user who is requesting that recommendation. And also we have the model registry. So this is used for like providing the status whether the training is completed or not. So based on that, you can actually choose like try out different things until then until the training is completed. So this is all about the architectural part. So the resources I was speaking about, which is the recommendation systems in Azure, you can like check out the first link where you have each and everything related to this. So you can go there out, like you can like understand the like in-depth architecture of the Microsoft Azure service. And like speaking about the FunKSVD algorithm before, like if you're really interested to check out the algorithm and also like how to create the user item matrix, which is really important. So you can check the last link, which is the GitHub repository that I actually provided you here. So you can go here, like play with this code, or use this in your own applications, which can be deployed afterwards. So, like speaking about the which is the Global AI Core Student Conference. For example, when you complete a Learn module, like for each and every Learn module, we will plant a tree, and like based on that, like when we complete more and more modules, it will be like forming a forest. So like this is a very great like initiative that is taken, and I think like based on that, we can also learn different things, and also we can actually kind of make a positive impact to the society, because like planting trees is something which is very good for the environment. So this is all about it. So thank you, everyone. So if you have any questions, you can post it here or in any different platforms. Otherwise, you can contact me via LinkedIn, where I'm really active there. So thank you so much.
Thank you so much for the session, Kaushik. That was amazing. That was very informative as well. I learned a lot. So we have some questions.
Yep.
So what, in your opinion, is the best algorithm for recommendation system, in your opinion?
So, like in my opinion, like if you want to get personalized recommendations, then go with the collaborative filtering, because it gives out the best recommendations, because it is based on all the different users, and like based on that, you like he or she can get personalized ones. But if you want the rank-based one, you can go with the weighted average, or you have the rank-based recommendation system. So it totally depends on the use case, which is dependent on the different application.
Okay, that's great. One more question is that what are the best and most important metrics to tell that this recommendation system is very good or this is very bad?
So first of all, like for this evaluation, we can like what we can do is like the similar thing that we can do is in machine learning, is that we can first train the model based on the data and then test it out, so that we can understand how the recommendations are going, and based on that we can actually try out different algorithms. So you can use the machine learning, which is the entire pipeline, for this same thing. So we can get, based on that, we can do the evaluation.
Okay, that's it from my side. If Stephen has any questions.
No, I think that was absolutely great. We did talk about different recommendation engine and covered a lot in just about 25 minutes. I think that was a great session, and thank you, Kaushik, for being a part of this event. I know it's Saturday, it's weekend, so we really appreciate your time, and we'd love to have you back when you're available. And yeah, thank you so much. And maybe it's time we move to the next session. All right, having said that, the next session is by Fateni. Fateni is going to talk about computer vision made easy with Azure. And before we actually do that, here's a gentle reminder that everyone who is completing the challenge, please take a screenshot and drop an email at aiconf@globalai.community. All the details on how to do it, the username, email, the type of screenshot is mentioned on the challenge page. So don't forget that. And also we are giving away 5 Amazon gift cards to 5 lucky winners. So that's also important. There's a lot to be taken away from this event. Having said that, welcome Fateni to Global AI Student Conference.
Hello, I'm so glad to be here. Today is actually my second time speaking at Global AI Student Conference. So this is very exciting for me.
Yeah, we're really happy to have you today. And in today's session, I believe you're going to talk about computer vision, which is absolutely interesting topic. So feel free to go ahead and share your screen, and then we can get started.
Okay, this is great. Just give me 1 moment to share my screen. I think it's okay now.
Yeah, we can see your screen.
So welcome everyone. Today we will explore the pre-trained models of Azure Cosmos Vision and build an image classification model for bird species detection. So my name is Fotini Savidou. I'm a Microsoft Learn Student Ambassador of Greece, and I study electrical and computer engineering at Aristotle University of Thessaloniki. You can find me on LinkedIn and Twitter, and you can also find my blogs about Azure, Python, and AI at my personal blog at fotinisavidou.com. Today we will learn the basics of AI and computer vision, explain the concept of transfer learning, and understand how Azure Cosmos Vision works. We will then build and deploy our own image classification model and create a simple Python app to test the prediction endpoint and discuss how we can improve a computer vision model. So let's get started and discuss the difference between AI, machine learning, and deep learning. In everyday life, we use the terms artificial intelligence and machine learning interchangeably. But the truth is that machine learning is the subset of AI. AI includes every technique that enables computers to mimic human intelligence. Machine learning is a subset of AI that uses techniques to train machines based on data, based on experience. Every machine learning process consists of 4 basic steps. First, we collect and feed the data into an algorithm, and we train the model using this data. And then we test and deploy the model, and finally we consume the deployed model to get predictions. For example, we can build a machine learning model that predicts stock prices based on historical data, or we can combine historical data with real-time data. Now, deep learning is a subset of machine learning, and it's based on artificial neural networks. An artificial neural network consists of multiple input and output layers and some hidden layers. For example, deep learning can be applied in computer vision tasks such as image classification or object detection. Now, computer vision is an area of AI that focuses on creating applications that are capable of processing images that can be either from a live camera feed or digital photographs and videos. Computer vision enables us to create software that can emulate human visual perception. What are some possible use cases of computer vision? For example, we can build a computer vision solution that processes images from X-ray or MRI devices and detects, for example, cancerous tumors. We can also use computer vision in text extraction. For instance, we can build applications that process large quantities of data, such as medical records or PDF documents, recognize patterns, and extract the text into a structured format. Computer vision can also be used in self-driving cars for detecting nearby vehicles, pedestrians, traffic light, or for analyzing road signs. The Azure Cosmos Vision uses transfer learning to build intelligent computer vision solutions. Transfer learning is a technique that applies knowledge gained from solving one problem to a different but related problem. For example, if you already have a model that recognizes cars, you can repurpose this model using transfer learning to also recognize trucks, motorcycles, and other kinds of vehicles. You can see the process of building a transfer learning model in this simple figure. Now, in the Cosmos Vision service, transfer learning works by adding a layer that consists of a pre-trained model to the neural network. The trained model gives us a head start when we train our model using new data. Training starts with a general knowledge domain, and new layers are added to the neural network to better solve a specific problem. In our demo, the problem we want to solve is to identify bird species using digital images. By starting with a pre-trained model, we get better results with less training time and without adding large amounts of images. Now, let's get deeper and explore the Azure Cosmos Vision service. Azure Cosmos Vision is part of the Azure Cognitive Services and is used to build and deploy your own image recognition models. Using Azure Cosmos Vision, you can build effective computer vision models using either a graphical user interface and without writing any line of code, or using one of the Cosmos Vision SDKs and your preferred programming language. Today we'll use the web portal to build our model. Cosmos Vision functionality can be divided into two features: image classification and object detection. Image classification applies labels to an image. For example, if we have an image of a house, we can train the model to predict the label house. We can also apply two or more tags in an image. For example, consider the second image. Here we can apply both the label house and the label person. Object detection is similar to image classification. In object detection, a model is trained to recognize individual type of object in the image and to identify their location. For example, consider again the second image of a house and a person. An object detection model can be used to identify the individual object in the image and return the label of each object, either house or person, the coordinates of the bounding box for each object, and the probability score for each predicted label, which can be interpreted as the confidence of this label to be correct. Now, I think we learned many things about computer vision, transfer learning, and Azure Cosmos Vision, so we are ready to go into our demo and build an image classification model for bird species detection. But first, we need to create some Azure resources and collect our data. To use Azure Cosmos Vision, you need two types of resources: a training resource, which will be used to train your model, and a prediction resource used by a client application to get predictions. These two types of resources can be either a Cosmos Vision resource or a Cognitive Service resource. You can use a Cognitive Services resource if you plan to use Cosmos Vision along with other cognitive services, such as computer vision or test analytics. Today I'll show you how to create a Cosmos Vision resource. So sign into your Azure portal, click on Create a Resource and search for Azure Cosmos Vision. Now you need to specify some values. Next to Create option, select both in order to create both a training and a prediction resource. Then select your subscription and choose a resource group or create a new one. And specify a unique name for your resource, and this name will be part of your prediction endpoint. Under training and prediction resources, select a location and a pricing tier. For this demo, you can just use the free pricing tier. Once you are ready, click on Review and Create, and once the deployment is complete, you will see that you have created two resources in the same resource group. Now that we have provisioned our Azure resources, we are ready to explore our data. I will use a small part of the BERT dataset by the Cornell Lab of Ornithology. And this demo dataset contains 115 photographs of 5 common bird species observed in North America. You can download the full dataset in the link in our slide. Now let's go to the Cosmos Vision Help portal and start building our model. First, I will create a new project, such as bird classification demo, and data resource description, such as bird species classification model. Under resource, choose the training resource that you created in the previous step, and select classification and multiclass. Multiclass classification is a task where each image is assigned to one and only one tag. Multi-label is a classification task where one image can be assigned to one or more tags at the same time. In our case, the dataset contains images of one bird, so I will use the multi-class type. And other domains, you can choose one of the general domains. And let's say that you will see that some domains have the value compact. Compact domains are optimized for real-time classification on edge devices. Models that are created in a compact domain can be exported in one of the available formats, such as TensorFlow, TensorFlow Lite for mobile IoT devices, TensorFlow.js for JavaScript applications, CoreML, and many other formats. Now click Create, and you will be redirected to the project's dashboard. Okay, the first step is to upload some images in our model. Click on Add Images, and upload all the images in the first folder, and specify the first tag. Okay, we need to create some seconds. And once all the images have been uploaded, we are ready to add more images in our model. So I think everything is working. And again, click on Add Images. Find the next folder, upload all the images, and specify the new tag, American Robin. You can repeat the same process for the remaining training images. I think this is pretty easy, isn't it? So once you have uploaded all of your images and you are ready to train your model. In the top toolbar, you see a train button, so you can click on that and select. You can click on that, select quick training, and train your model. And once the training is complete, you will see some performance metrics that help you assess the performance of your model. I have already trained the same models because the training process takes 5 to 10 minutes to be complete, and we don't have much time today. So I will close that and go back and select my model, which is this one. Okay, here's the performance tab. We can see the 3 metrics that the Cosmo Vision service calculates: precision, recall, and average precision. Precision indicates the percentage of cloud predictions that were correct. What does it mean? For example, consider an image classification model for dogs and cats. If the model predicted that 10 images are cats, of which only 8 were actually cats, then the precision is 80%. Recall indicates the percentage of cloud predictions that were correctly identified. For example, for the dogs and cats image classification model, if there are 10 images of cats, but the model found 8 of them, then the recall is 80%. And average precision is a metric that measures model performance by calculating precision and recall at different thresholds. In the top left corner, you can also see the probability threshold metric. Probability threshold indicates the minimum probability score for a prediction to be valid when calculating precision and recall. You can just adjust this slider, and you will see that this metric changes. Now, at the bottom of the page, you can also see precision, recall, and average precision for each label of your model. I think our model is pretty accurate, so I will go and click on Quick Test to test our model using new data. Here you can enter a URL of an online image or click on Browse Local Files and upload a local image. I will select this one. Okay, and here you can see the tags and the probability score. As we can see, our model predicts the correct tag. Now let's go back to our presentation. And before deploying our model, let's talk about some possible ways of improving our image classification model. One common problem that we may deal when building machine learning or computer vision solutions is overfitting. An overfitted model performs well on the training data, but performs poorly on new data. So how can we prevent overfitting when building computer vision models? You should include a variety of images to ensure that your model can generalize well. For example, provide images of your object in front of different backgrounds, or provide images with varied lighting, images taken with different camera angles, or images in which the object vary in size, in number, or in style. The number of training images is another important factor to prevent overfitting. With fewer images, there is a higher risk of the model to be overfitted. Based on the Azure Custom Vision documentation, for the first training iteration, you should use at least 50 images per label. But it's also important to consider the relative quantities of your training data. You should ensure that the distribution of images per tag is uniform. For instance, if you use 200 images for one label and only 50 images for another label, then this will cause your model to be more accurate in predicting one label over another. So after this brief discussion about possible ways of improving your image classification models, you can go back to your image classification model and ensure that you have enough data and your data is diverse enough. I will just move on to the next step and show you how you can publish a training iteration and consume the deployed model in a Python app. To publish your model, you can just click on the Publish button in the Performance tab and specify a name for your model and select the prediction resource that you created in a previous step. I have already published my model, so we are ready to consume the model from a client application. The first step is to install the Azure Cognitive Services Custom Vision SDK for Python. If you are not interested in Python, you can use one of the other available programming languages, such as C#, Go, Java, or JavaScript. So I like Python, and will build this simple Python app to test our model. Firstly, we need to create some variables to save information about our model. This information is the name of the published model, the ID of your project, the key and the endpoint of the prediction resource. To find the ID of your project, you can select your project in the Custom Vision web portal and click on the settings icon. To find the key and the endpoint of your prediction resource, navigate to the homepage of the Custom Vision web portal and click on the settings icon. Once you have saved all this information, create a Custom Vision prediction client object and name the new object predictor. Then you can open one of your images that you have in your computer and use the classify image method of the predictor object to classify this image. The classification results contain the labels and the probability scores. So using a simple for loop, I can print the labels along with the predicted score. If you want to learn more about the Python SDK for Custom Vision and understand all the information about this small piece of code, you can go to the Azure Custom Vision documentation on Microsoft Docs. I think it's time to open the Visual Studio Code and run this code and make some predictions. So click on Run. And this code will first open one image and display the tags along with the probability scores. And then the code classifies 10 images and displays the label with the highest probability score. As you can see, the model is pretty accurate and all the predicted labels are the correct labels. So, congratulations, you have built, trained, deployed, and tested your own image classification model. Let's summarize some of our today's session. We talk about the concept of AI and how it differs from machine learning and deep learning. explore some interesting use case of computer vision, and explain the concept of transfer learning. We then create the Cosmos Vision resource and built and trained an image classification model in Cosmos Vision web portal and deployed this model. We also discussed some possible ways of improving your models and preventing overfitting, and created a simple Python app to test the prediction endpoint. Now that you learned the basics of Azure Cosmos Vision, you can go to Microsoft Learn and complete these 3 Learn modules. You will find some interesting interactive exercises, some Python notebooks, and quizzes to test your skills. These Learn modules are also part of the requirements to get the AI certifications of Microsoft. And there is more. I have recently published a complete exercise about how to build a flower classification model using Azure Cosmos Vision. You can find my article at my blog for fotonista.video.coach, or you can find it on the Microsoft Tech Community Educator Developer blog at ak.ms/faculty. This blog also contains a visual guide that describes the basic features of Azure Cosmos Vision. So that's the end of my session. Thank you everyone for being here today. I hope you have a great time at Global AI Student Conference and enjoyed my session. If you have any questions, you can ask them now in the chat or reach out to me on LinkedIn and Twitter. Thank you.
That was absolutely great session, Fotoni, around Azure Custom Vision. What I really loved is that in the first half, you didn't write even a single line of code, and you were able to go ahead and use the Azure Cognitive Services and build a custom model, right? That would recognize with your custom images. A quick question, Fotoni, for someone who actually comes from the background of from this machine learning training models, right? The very first step that people like to do is to go ahead and create a compute resource. Right, they want to go ahead and create a compute resource. How does that work with the cognitive service? Is it like Azure takes care everything on its own, or we have to go ahead and also create compute services from our end?
Everything is built on the Microsoft Cloud. You don't need to provision.
Looks pretty easy, right? I mean, if I don't have any experience with machine learning, I can go ahead and get started with that. But what are some of the challenges one would face?
One of the challenges that many beginners may face when building machine learning models is the overfitting that we discussed in my session. And one other important thing that I want to mention is that when you test your model, you should use new data. If you use training data, the errors of the model will be very small, and if you take this model into production, you will notice that when users submit their own photos, the testing errors will be very, very large. So always, when testing your model, use new images. And also use a large quantity of images and ensure that you have enough images for every label.
That's great. That's great. I think those are some of the pitfalls people should take care of it when they go ahead and build Azure Custom Vision model. Any final thing you want to plug in for the before we move to the next session?
Sorry, I don't hear you.
Any final thing you want to plug in before we move to the next session?
No, thank you. I had a great time today.
All right, thank you so much. Really appreciate for your time, and yeah, have a nice weekend ahead, and hope to see you soon. Bye bye. Take care.
Thank you. Bye.
Thank you for tuning. Bye. Okay.
Bye.
For our next session, we have our speaker Narcisse. He's going to do a deep dive into machine learning. So, hello, Narcisse.
Hello. Can you hear me?
Yes, we can hear you.
Oh, welcome. I didn't catch the names. My name is Narcisse.
Yeah, welcome to the Global AI Student Conference, Narcisse. So thank you so much. Feel free to go ahead and share your screen, and then we can get started.
Awesome. Thank you. Is my screen visible?
Yes, it's visible.
Okay, thank you. Oh, 1 minute. Forgot to share with sound. Is the sound visible? Is the sound audible? Is it audible?
It's not.
Yes,
it's not audible. The audio is not audible. You can skip the video. Yeah, maybe you can skip the video and move to the next slide. Yeah.
Okay. Start again.
Intelligence helps us meet the needs of today, so we're prepared for tomorrow.
By 2050, we need to produce 60% more food. So how are we going to feed the world without wrecking the planet? Using Microsoft Artificial Intelligence, we can reduce waste and produce more food. Any grower will tell you every row, every crop is different. We can use Microsoft AI to make local predictions about light, wind, rain. This helps farmers know when to plant, irrigate and harvest. It's making a difference.
Artificial intelligence helps farmers grow more while wasting less.
And there you go. Welcome. My name is Narcisse Mpuyo, and I'll be taking you through a deep dive into machine learning. As demonstrated in that video, that's just some of the capabilities that we'll be able to do with machine learning. So a bit about who I am. My name is Narcisse Mpuyo. I'm a student I'm a student at DUT. I'm a beta Microsoft Student Learning Ambassador, and I'm also part of the IoT Club, and below are my socials. Feel free to connect. So to begin, I'll quickly start off by a small introduction about what is artificial intelligence. As mentioned, artificial intelligence is the intelligence demonstrated by machines. As us human beings, living organisms, we have something called, we have an intelligence called natural intelligence, which is the intelligence displayed by living organisms. But now with machines, they have something called artificial intelligence, giving them the ability to basically do what we can do, but even at a better rate. Just as a small definition about what is artificial intelligence. What are some of the key elements of artificial intelligence, which is machine learning, anomaly detection, computer vision, natural language processing, and conversational AI. Today, I'll be focusing more on machine learning because of time. I won't be able to go through the others. So what is machine learning? So machine learning is the foundation of the most AI solutions. So basically all the AI solutions that we see, all the AI solutions that I just mentioned earlier on, they're all built on machine learning. So basically machine learning in definition is like the ability to give a machine or a machine some information, and they're able to make that information and do something with it, like in simple terms, as I've just explained. But in the definition, it gives computers the ability to learn from the environment with the use of data. What is big data? So big data is a huge chunk of information, right? Huge chunk of information given to machines in order for them to work with. What do I mean by huge chunks of data? So, for example, our devices, our Facebook, our Instagram, all of those things, they generate huge amounts of data, and that's why the Facebook companies and everything like that, they use those information to improve their AI, to improve their models and everything like that, because of the information that we give them, or they generate from us on their platform. That's just an example of big data. Even the video that we just watched about the farming, they have sensors, and the sensors keep track of the temperature, they keep track of everything related to the outside, and that's all the meantime generating data for the AI to use. So that's an example of big data. So what's the relationship between big data and machine learning? The relationship is that machine learning needs a lot of data for it to work with. Data. More data, the more effective your machine learning model will be. So a bit about how machine learning works. As I mentioned, the more data that you give it, the better it becomes. By looking at this example, here wants to detect different types of flowers. So you have to collect all different species of flowers, collect them, train them, and then you're gonna be able, your machine learning model will be able to detect which type of flower it is. As you can see in the demonstration below, I'll start from the beginning. So over here, the different types of flowers are collected. Now the machine learning has been trained, and now it's able to detect that this is that's the type of flowers that it detects, as you can see through the example. So moving on, right? So now, how can one get started with machine learning? To be honest, machine learning usually revolves around Python. You know, your Python, and mostly Python is the language people prefer using when it comes to machine learning, because Python is very flexible. It gives you a wide range of options and everything like that. But now, for us who do not know Python, or who are not comfortable with Python, or like prefer sticking in our own comfort zone. For me, like I grew up with C# and I prefer staying within the Microsoft community. So Microsoft came up with something called ML.NET, machine learning in .NET applications. So with the use of ML.NET, we're able to include machine learning in our .NET application, in our Windows application that we use every day, without leaving our comfort zone, without leaving our language C# or other Microsoft languages to implement machine learning. So with the help of machine learning, ML.NET, it helps to incorporate that. So what exactly is ML.NET? ML.NET, as I mentioned, it gives you the ability to add machine learning in .NET application. It's simplified with custom machine learning and automated machine learning. Custom ML meaning you can customize the machine learning model to do what you want. And automated machine learning, it automates the process for you, so you don't have to do anything. And that's for those who do not know anything about coding, or have no idea about coding. They just want machine learning. They can use AutoML. And then it makes use of other technologies such as TensorFlow and ONNX. And it's also been proven has a great performance, and it's also very scalable, as you can see. Moving on, I'm just moving a bit fast because of time. So what type of predictions can we make with ML.NET? So we can use classification, regression, anomaly detection, recommendation, time series, and image classification. So those are the types of predictions that we can make with the help of ML.NET. To just go a bit about what each of these predictions are. Classification is when you try and determine something, or you try to categorize something, whether it's negative or positive, whether it's good or bad, whether it's an apple or not. Those are like you categorizing it, you're putting it into a certain place. Regression is predicting the price of a product, or predicting the value of something over a series of time. Anomaly detection, detecting mistakes. For example, us human beings, over a wide amount of time, we can make mistakes. We are susceptible to mistakes. But now with the help of artificial intelligence or machine learning, it helps detect those mistakes so that when we careless, it covers that for us. It can recommend products, recommend movies, apps to use, etc. All of that comes from AI, machine learning. Time series focus the weather of a series of time, and most importantly, image classification, which the session previously was all about. So how can one get started with ML.NET, right? So how ML.NET offers 3 tools for us to get started with. There's Model Builder tool, ML.NET Command Line Interface tool, and ML.NET API. So hopefully by the end of the session, I can be able to do a small session to get started with all these 3 tools. So moving on, more about the tools. So machine learning model builder tool is within Visual Studio. So once you go into your Visual Studio, and I have to put out this disclaimer that it's within, you have to use Visual Studio Code for you to implement machine learning capability into your application. So you just choose your scenarios, you input your data, and you let it train the model. The model will do the training for you, and it's going to generate the code for you to use wherever you want it to use, all within Visual Studio. And then command line tool is the exact same thing, but now this time you're just putting in the command line interface, you're putting the code, and it does everything for you without the graphical user interface. So this one is better because it's available on all platforms, Windows, Mac, Linux, etc. But this builder tool is only available on Windows devices. So those are the 2 tools. First of the 2 of 3 tools that you can use to get started with ML.NET. Moving on. So now we've talked about machine learning model on a local basis, like locally speaking. Now we are going to talk about machine learning on Microsoft Azure on the cloud platform. So there are various ways to tackle it. The other cloud providers, your Google, your Amazon, but for this instance, that's another disclaimer. For this instance, we'll be talking about machine learning on Microsoft Azure and what Azure offers, what services that Azure offers for machine learning. So moving on. So Azure offers automated machine learning, Azure Machine Learning Designer, data and compute management, and pipelines. So AutoML, as I mentioned, automated machine learning is just a drag and drop interface. Sorry, I'm mistaken. Automated machine learning is a place on Azure where you just import your data and Azure will take care of the rest. It will train the model for you. It then will give you the best model for you to use. Azure Machine Learning Designer is for those who are in between, who have a bit of coding experience, and they also don't get involved with the code, so they can just simply drag and drop which model that they want, which data they want to use, etc. It's a matter of drag and drop. And then data and compute management is for the it's like a cloud-based storage on Azure, and pipelines as well. Pipelines is like is like for the pros. I would say for the pros who know exactly what they're doing and they work hand in hand with APIs. So we'll get to this one last. I'll leave that for now because it's just getting started. If you have any questions, you can leave them in the chat for me. Moving on to just clearly explain everything I've just mentioned now. So I said auto machine learning is for those who are new to coding, who are new to programming. They have no experience. They don't even know anything. They just want to use machine learning in what they want to do. So this one is for them. As it says, it's a feature that enables non-experts to quickly create effective machine learning models from data. So all you need is just your data, and Azure will take care of the rest for you. When can you use machine learning? You can use auto machine learning for classification, regression, and time series forecasting. And last but not least, how does it work? So over there, at the bottom of the screen, it gives you an indication of how AutoML works. You just choose your problem, you choose your scenario, and you let Azure Auto Machine Learning do the rest for you. That with the graphical user interface, graphical representation of of what I just mentioned right now. So you, the user, you input your data, you choose your settings that you want, and you let auto machine learning do the rest for you. As you can see, it trains all the algorithms, and chooses the best one for you and gives you the results. That's just a graphical user interface. A graphical representation of what I just mentioned. And now we move on to Azure Machine Learning Designer. So with Azure Machine Learning Designer, as I said, is for those who are in between, who have an idea of what they want, but they don't want to get involved into the heavy lifting. So all they can do is just simply drag and drop and assign the dots together. As simple as that. It lets you visually connect data sets and modules to an interactive canvas to create a machine learning model as demonstrated in the picture on the side. So how exactly does it work? So as I said, you choose your data model and you just drag and drop, as simple as that. I would want to explain further, but because of time and I want to show you the demonstration at the end, I'll continue. So just a graphical representation of the node below. So Machine Learning Designer, right? It works with pipelines. I mentioned pipelines earlier on. So what is pipeline? So think of it of this scenario. So you in your house, there's the bathroom, there's a kitchen, and all of these things need water. They have to work with water one way or another. So there's a pipe connected to the bathroom, there's a pipe connected to the kitchen, and everything comes together in one pipe. Bringing water to the household and taking out the waste and everything like that. That's the same thing with Azure, with Machine Learning Designer. That's how it works with pipelines as well. How exactly? So you have a pipeline that will do this amount of code. You have a pipeline that will do this amount of code and just bring it together to have one model. So it basically breaks down certain bits and bits for you to understand exactly what you are doing. So there's a pipeline for that does the experiment. It has a pipeline that does this. It has a pipeline that does, and all of together comes together for one whole thing. I hope that makes sense. Moving on. So I mentioned about ML.NET API. So API, what is an API? API is an application programmable interface. So it's a computing interface that defines interactions between multiple software, application, or mixed software intermediaries. That's like a big definition. Wow. So in simple terms, an API is basically an application that is made by another person and you just use it to do whatever you want. Think of it like this, right? So you're at a restaurant, and then at the restaurant you want to eat, all you can send is just your food and for you eating. How your food is being made, what goes on in the process of making your food, you really do not know what happens. All you know is just you're gonna eat. So that's just one example. Another example is like I don't know how to dance, but I want to dance. So I can just call the dance API, choose the dance moves that I want, and I'll be able to dance. That's an example of an API. It's just a program made by another person, which I'm using to do what I want. So with ML.NET API, you're doing everything from scratch, from like from no interface, no builder tool, anything like that. You're doing everything from scratch. You're building your machine learning model from scratch. As I said, this is for the professionals who know what they want and who know what they're doing. They use an ML.NET API to make their machine learning models. So this is an example of a machine learning model API in Python. As you can see, it involves pipelines. That's in Python. Moving forward, this is a pipeline in C#. As you can see, I was working on this one, pipeline in C#. And last but not least, it is time for the demos. So that was a lot to say in under 20 minutes, but I hope it makes sense and you've got something out of it. If you have anything, you can please let me know the questions and I'll be sure to answer that. So now it's time for demos. It's enough with the theories. So what you'll need a machine learning, you'll need a machine learning Visual Studio, Azure account with credits, and focus and determination, because it's not easy at first try, but over time, you'll get the hang of it and it'll become easy for you. So let's get started. So the first thing we're gonna do is we're gonna start on Visual Studio. Let me open Visual Studio. As you can see, I've already created a Visual Studio project, and it's a console application in .NET Core. So 1 minute. Setting up for you. Okay. Okay. Can't find what I'm looking for, but I'll go on. So to get started, I hope the font is visible because I was trying to look for the zoom function. So I hope it's visible. So first thing to get started is that you come to your Solution Explorer and you click on your project, right? After clicking on your project, you right click it and you're gonna see all these options and you're just gonna come to add. Once you come to add, you'll see machine learning models in green over here. And that's what you're gonna click for you to add your machine learning template. So this is normally how you do it, but because I have Visual Studio 2022.
Excuse me, Narcisse, I'm really sorry to interrupt. If you could just zoom a little bit, that would be absolutely great.
Okay, no problem. Let me just sort out the zoom for you.
Use Control Plus.
Yes. Okay.
Yeah, you can just close this window, and once you go back, maybe you can, yeah, Control
Plus. It doesn't seem to be working. I have this tool, I'm looking for it. Just give me a minute. I'm sorry about this. In the meantime, is there any questions while I look for the zoom?
Or maybe on the bottom left, you can find a drop down that says 133%, maybe inside Visual Studio. Yeah,
yes,
you can make it like 200.
Okay.
Maybe a little more.
Nah.
Thank you.
Okay, thank you. Okay, so we're not working with the code at the moment. We're first implementing the machine learning model into our Visual Studio application. So let me just use the zoom function in Windows. Yeah, doesn't seem to be working. So I'll just continue. I'll be sure to zoom in after I'm done with the demonstration because of time. So you just come to right click your solution, you come to add, and you click machine learning model. And then you name the name of your model, machine learning model, and you click enter. It's gonna create. It's creating. It's adding it to the project. It's adding to the project. So now the machine learning model has machine learning capabilities has been added to your project. So now after it's been added to your project, then you have to choose the scenario of which you want to do. So now there's data classification, value prediction, image classification, recommendation, object detection, anomaly detection, all types of scenarios that you can imagine and think of. So right now we're going to do let's do data classification. So basically, we're going to classify two things in a certain category. So now after choosing your scenario that you want, you can choose to work on your local machine, or you can use to work on Azure. So on my one, it says I can use my local machine for me to do my training. And now after training, you need your data source. So now over here, I have my data source set up already. Let me open it. Text stack classification. So we can do a fake or real job post. So we can use machine learning to determine if something is real or fake. We can do a movie review, etc. So we're gonna do a fake or fake job posting to see if the post is fake or real. So that's what we're gonna do. With loading our data onto the machine learning model. It can be either a CSV file or an SQL server. You can work from SQL servers as well. So after your data has been loaded, you choose the title which you want to predict. So now I want to predict the job. I want to predict the job description. So just make sure you choose the right heading for it to work. So now I chose the industry because that's what the table related to the job. I click next, and then you choose your training time. So the bigger your data, the more training time it's gonna need, and the less your data, the less time. But the more training you give it, the more accurate your results will be. So for the demonstration, because of time, I'll just say 200 seconds. And then I'll still train anyway, even though it gives me a warning. So it's training for 200 seconds. So now whilst it's training, I'm gonna go over to the command line interface to show you how to get started there as well. So as you can see, I'm on my Windows terminal, and let me zoom in over here. Okay. As you can see, I've already gone into the file location in which I want to my model to be saved in. So once you've settled that out, you're now gonna move on to installing the machine learning capabilities on your PC for your command line interface. And how do you do that? You just type .NET tool install -g ml.net. So that's the tool the code that you're gonna use to install machine learning model on your command line interface. It's installing now. It's installing. Okay, it's taking a bit of time. But let me just show you the end results of what is expected. So I'm sharing the screen. So it's installing. Whilst it's installing, let's just double check. You see the training is almost done. Whilst I'm showing you this one, we're waiting for this one. We're just waiting for it to load. As I said, in this training, almost time. Okay. So this is how it's supposed to go, like the training. So basically, this is how it's supposed to go. Let me share this one with you. Okay. So this is the result, the end result of what I wanted us to do, but because of time, I just took a picture for you. So after installing your ML.NET onto your command line, you can choose classification, regression, recommendation image classification, and then you type ML.NET regression. You choose your data source, your column which you want to predict, and your training time that you want to train. And it's going to do the training for you, as you can see. And that's just the first part. And then the second part for the results, going to the results page. So for the results, this is how the results summary is going to be like. So now after you finish training, it's going to show you a summary of the results, show you the model that you want to use, which was regression, and the top 5 regression models that it used. And on top of it, it generates a Visual Studio application for you to use hands-on so that you don't have to worry about that. That's on command line interface. And lastly, to move on before time runs out, Microsoft Azure. So on Microsoft Azure, you can get started by creating a machine learning model. Or how do you get started on Microsoft Azure? You just type ml. Zoom. Okay, I hope that's visible. So you just machine learning. You just type machine learning for you to get started with machine learning. Okay, my PC is frozen. It's really frozen. I think because of time, I can stop here. I can stop here because of time. So due to the technical difficulties on my side, I think I'll end it off here if that's okay. Sorry about this. Over to you, the host. Any questions?
No problem, Marcy. That was a good session. I hope you enjoyed it.
Yeah.
We enjoyed it as well. So just one question, since we are running out of time. Just an overall general question. What do you think is the most often committed setback faced by people while trying to learn or trying to train models in machine learning?
For me, I would say is the data, because people don't have a lot of data available to them. So that's why they can't really implement their model in the way that they want to. So as I said earlier on, the more data you have, the easier it is for you to make your machine learning model or your machine learning experience easy, as I said.
That is exactly correct. So we need to move on to the next session. So.
Thank you.
Okay, thank you. Thank you so much.
All right, Nigama, it's time we move to the next session, isn't it?
Yes.
All right, and what is our next session about?
Our next session is about biometric artificial intelligence, and our speaker is Siddharth. Let's welcome Siddharth.
Am I audible?
Yes,
yeah,
we can hear you. How are you, Siddharth?
I'm doing great. How are you?
We are good, thank you. You can start your presentation right away.
Sure, thank you.
After you share your screen, we can get started.
Oh, okay. Is it visible?
Yeah.
Okay,
yes.
Thank you. So let me introduce myself. My name is Siddharth, and I'm a student in VIT Chennai, Vellore Institute of Chennai. It's in India, and I'm doing my undergraduation second year in computer science. So a bit about this topic before I start. Let me give you a heads up right away, which is there won't be coding involved as much as the others. This is more like an algorithm analysis, so keep that in mind. So let's start off. So the fundamental question which is raised is, what is biometrics? So biometrics is that form of technology that incorporates the biological uniqueness of an individual into a technical aspect for the purpose of security and data. And these may include face recognition, fingerprint scanning, iris scanning, DNA, all in many levels. And today we'll talk about biometrics in some simple level, if you don't mind. The question is, since this is a global AI conference, so the question is how AI biometric technologies work. And in order to perceive that, you have to divide biometric identification into two, broadly physical and behavioral. Let's get it physical first. So physical biometric solutions use measurable characteristics. Please know that word. Of particular parts of the body, as said earlier, like a person's face, iris, DNA, fingerprints, and what technically does is that it transforms this particular information into a code readable by the AI system with which you have built this algorithm. And just a fun fact, the oldest known biometric technology is a DNA test done for discovering lineage, biological parents. And moving on, you often, you realize what is the essence of biometrics. So if you see this picture right here, this is a facial recognition system in Osaka Metro Station. And as it sounds, this was implemented as a CCTV setup, so to capture information of anyone and everyone who is captured on the screen. And so in layman terms, this was actually built to monitor the passengers at the station and capture the identity for any future investigation, survey, etc., done by the government whatsoever. So now let's just wonder, which is this huge setup that you saw for face recognition is being compressed to a size that fits on our phones and other electronic devices. So it's a mind-blowing fact if you think about it, how that huge thing has come down to being so handy as our phones. So as I said earlier, this is a global AI conference. So where does AI come in? To answer that, let me give two scenarios, which is why can't a well-developed facial recognition system be fooled by the photo of the authenticator? Second question would be, why can't a fingerprint smudge validate a fingerprint scanner? A fingerprint smudge of the laptop, a glass, whatsoever. Yeah. The answer in brief would be the art of depth sensing, pressure sensing, etc. So to detail this more, let's talk about the face recognition first. So each person's face is broken up into numerous data points, and these can be the distance between the eyes, the height of cheekbones, and other distinctive features. And this facial recognition algorithm with which you have built the system searches on those data points and tries to account for the variation. So in simple terms, the face is broken down to millions of Cartesian coordinates XYZ, and the distance between each coordinate is measured to extreme precision. This is an image which shows a small representation of what the IR scanner and the AI does. So this data which you captured with this face is accessed again while attempting an authentication. A single point of precision, as said earlier, is enough to render the entire authentication invalid. And as mentioned, the depth factor involved here would be how deep your eyes are compared to your other facial features, how protruding your nose is, etc. In case of fingerprints, how is AI involved in that? So in order to understand, it should understand the machine learning part of fingerprint scanning, which is an optical scanner based work. So this is done by shining a bright light over your fingerprint and taking a digital photo of it. And this is a light sensitive microchip. So the digital image which you get is filled with ridges, a rise and a valley, a fall. And they turn these ridges and valleys to a binary code consisting of ones and zeros. And this creates a user's personal code. So let's say an example, which is, let's say Jonathan has 15 ridges and 12 valleys in his thumb, all in a unique order. Hence, the binary data can be, underline that word, please, as follows. The role AI plays in here is the encryption of this binary code so as to avoid any option of data breaching. This is a digital image of a fingerprint with data points similar to the face, but this time instead of calculating a depth, it senses pressure and ridges and valleys. And as mentioned, the AI encrypts this unique binary code. So it's pretty obvious that the AI not only enhances the biometric technology, but also scrutinizes any possibility of a breach. Now let's get to the most interesting part of this, which is the biometric. The behavioral biometric, sorry. The behavioral biometric identifies and measures human activities, not the common measurements, although human activities such as keystroke dynamics, voice print, device usage, signature analysis, error patterns. From the words, keystroke dynamics include the speed with which you type, the number of emoticons and emojis that you use, the number of abbreviations, and how often you rely on autocorrect. Voice print, as the name suggests, it is something which is identified depending on how you sound. But to be honest, this could be recreated by a voice recorder. The next thing would be device usage. So device usage is something that comes along nowadays, along with your online transaction, something that deals with money. let's take a normal month. Let's take a scenario, all right? Let's take a normal month wherein an individual has a set of common transactions such as his telecom service, his cable bills, his insurance, and let's say you make an unusual transaction. Let's say a fine, a speeding ticket, a fine to the road and safety department. Your bank would intimidate you of that behavior, saying you have made an unusual transaction to so and so for an amount. Is it you? And this is done in order to verify the authenticity of the transaction so as to prevent any fraud. That is where behavioral biometrics come in play. The next one is signature analysis, which clearly are the e-signature or the digital signatures that you use for your government purposes or any other thing which involves online sanctioning. And the other one are error patterns, which are common in our mobile devices, the security logs and stuff. However, even though this has been categorized as biometric security, this is not used as an authentication factor. It's more or less an additional layer of security along with the other basic biometric information like fingerprints. So one thing which is often questioned is the future of this field. And the reason why I brought up this topic would be the same. The future, as mentioned, is evidently bright. Day by day, if you think about this, we are trying to reduce the amount of passwords to remember while increasing the data to store. Let's take payment, for example. What started with cash has slowly transitioned into credit cards, which gave the rise of online banking right now to mobile payment. Now, if you recall that entire path, the use of passwords has decreased drastically. What is once a combination of letters, numbers, pins, and passwords is now merely a fingerprint and face. Another fitting example is the lock screen of your phone. So today, if you go purchase any phone off a store or from the online market, the first thing that is done is adding a biometrics, a fingerprint or the face. Here's just similar to online payment, what started as passwords, PIN, pattern unlocks has now become a face unlock or a fingerprint scanner. And now to think about it, even smartwatches right nowadays, as said earlier in the previous slide, even smartwatches today have used behavioral biometrics, keeping track of routine, calories intake, measuring heart rate, and even observing oxygen levels, which today, considering the pandemic situation, I feel it's a great boon. And more recently, ironically, we were able to detect if a person fell to the ground, obviously. And if so, was it because of a silly mistake like slipping on a banana peel, as cartoons teaches us, or a medical condition such as low glucose level, etc. Just to show you all a context of this, the first picture you see is of an ECG machine, which is a hospital equipment to measure the heart rate of an individual. The second picture is a smartwatch, which is capable of the same thing and yet is more portable. So you see, this is how the evolution of biometrics have come into play today. So as I said earlier, this was nothing to do with coding per se. It was just an algorithm-based session. And to conclude, today what I have given in this allotted time was just a very small walkthrough of a topic still under study. And as I said, this field is way more vast than one could imagine. New forms of biometrics are being discovered and implemented every day. And let's face the truth. It's very less people actually agree to testing something in its beta phase. And yet, even though this particular field is still under testing phases, it is one of the most used technologies today. So thank you so much for having me here. And if you feel like I have missed out on something or you want to connect with me, these are my contacts. Thank you, Global AI Student Conference, for giving me this opportunity. And while we are on that subject, it's a great initiative put forth by Global AI Student Conference. As you know, deforestation is something that we all learn in our geography classes, and yet today it's one of the most prominent issue. Hence, please, I implore you all to take part in this challenge, and let's hope for a better tomorrow. Thank you so much.
Thank you, Siddharth. That was an insightful session, short but insightful.
Yes.
Yeah. So I have a question about your topic. So
yes.
where do you think the future of biometrics in artificial intelligence is heading towards, and what are the things that you're most excited about?
Okay, that's a nice question to answer to, because as I said, the future is evidently bright. As one key example was earlier, like your basic functions such as measuring one's heart rate is now available. It's portable. That's the most the key feature according to me. And the future of it would be, I think tomorrow at this one point, I saw a session today which will happen in the future. I guess I saw a session wherein you read human emotions. So I mean, it's a very enlightening aspect of technology and biometrics as a combination. And I guess that's where I feel biometrics will lead us to. So let's hope that's so.
And also, in which field do you think it is more prevalent these days, and in which field do you think it is going to be more prevalent in the future?
I would say the medical field, because I think security at the moment we have topped with facial recognition, but
exactly.
Yeah, and so the medical field would highly benefit this. I think that's the way this is heading towards. So tomorrow, more or less, going to the hospital, the first concern would be checking your smartwatch whether your heart rate is low. So that's the way I think things would go.
Exactly, I completely agree on that. Stephen, do you have any questions to share?
There's one question I think coming from the comments. There's the how train cat facial detection model. That's interesting.
Sorry, I didn't get you.
It says how train cat facial detection model. Someone has to train about cat, right? I don't know if it's about this session.
Okay.
But never mind. Never mind. Maybe something I missed up. So that was a great session, Siddharth. You know, I would say very, very crisp and very, very niche. We have not had many sessions around it. I've been following up with this global AI community events, the other students from that feed too, but your one was very different and very niche. And I know you come from a very premium institute in India. That's absolutely great too. Any final thing you want to plug in, Siddharth, before we move to the next session?
Yeah, the one thing that I would like to plug in is, I guess, whenever I've talked about this particular topic was, how do you learn, how do you become a biometric engineer? How do you learn this particular line? So the thing is, this particular as a profession, this is just growing. It's still very new to people. You can't go up to a person and say, I want to become a biometric engineer today. They are clueless. So I think the first and foremost thing would be like making like it's as I said, it's a vast field of study. So probably would be more educating yourself. And secondly, how do you train to be one is mainly, I personally use Python OpenCV, the Open Computer Vision. So that's one way. And as far as I've heard, you can do this in any programming language that has a base of data structures and object-oriented programming, along with a tinge of machine learning and all. So that's just a basic thing. I'm still new to this, so.
Well, makes sense. That makes sense, right? Yeah. That definitely makes sense. So Siddharth, that was great. Thank you so much once again for accepting the invitation. So we'd love to have you back, and yeah, have a nice weekend ahead.
Thank you. Thank you so much.
Bye-bye. All right, Nigama. Now, before we move to the next section, I think we still have time, but before we do that, let's make a certain announcement. That is, the first one is definitely about the challenge that we have. Definitely go ahead and participate in that challenge. Every module that you complete, we plant a tree, and I think they're going to plant up to around 1,500 trees. Having said that, there are also some of the Amazon vouchers that we're giving away to 5 lucky winners. So how to actually claim it, you have to take a screenshot, and how to take a screenshot, where to email, it's all mentioned on that challenge page. So definitely go ahead and check that out. Also, please feel free to go ahead and ask any question to the speaker, maybe any platform that you are watching. And maybe I think let's take a short break, Nigama, and let's play a video, and then we'll be back.
Sure, sounds good.
Okay, we good. Ian, we good. Okay. What is it that we can do that is unique, that is impactful? We are going to empower every individual to do more and achieve more.
That's what technology really is. It's possibility.
more power at your fingertips than entire generations that came before you. Tomorrow is here today. What will you do? What will you do with it?
So this is an augmented reality device called HoloLens.
Wow. People can really use it to take things to the next level. And that's what technology is supposed to do. That can change the world.
Hello everyone, and welcome to our talk, The Age of Applied AI. AI is going to take a huge impact in everybody's daily life, embedded in everything we do. And this talk is really about where we came from and emphasizing that each of us has a huge responsibility in terms how we make AI work for good and ethics of how AI will work for everyone. My name is Henk Boelman, Cloud Advocate at Microsoft, and I live in the Netherlands. And I'm really excited to take you on this journey through the AI landscape, where we will find out what AI actually is and learn what is possible now.
And hi everyone, my name's Amy Boyd. I am also a cloud advocate at Microsoft and I live in the UK. Along with what Henk said, we're going to dive into the past, the history of AI. We're going to talk a bit about what we can do today with AI, and then we're going to use the saying, just because we can doesn't mean we should, and apply that to responsible AI.
We have divided this talk in 5 chapters. In our first chapter, Amy will take us through the history of AI. Then we talk with Seth Juarez about what AI actually is, see what we can do with AI, and dive into the ethics part. Let's not waste any time. Amy, the stage is yours.
Okay, so I want to briefly talk to you about where it all started, the history of AI. We're going to give you a few different segments. I highly recommend going and researching a little bit more yourself. But we'll start in 1950. In 1950, there was a gentleman named Alan Turing, and he created the Turing test. When he did this, he speculated about the possibility of creating machines that think. This could be said to be the first time we've truly started to think about this idea of intelligent machines. And it wasn't long after that in 1956, we saw the Dartmouth Summer Research Project. Now, the Dartmouth Summer Research Project was led by John McCarthy, and he got himself and a lot of his reputable colleagues together, and they started and named the field of artificial intelligence. They used this quote to proceed on the basis of conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. And so this was the original definition of AI, and we know that AI has changed almost its expectations and its definitions over time. So let's take a look at a little bit further on in the AI cycle. So from around this time, 1956, all the way up to the mid-70s, this was where we saw the gold rush of AI. This is where research was being extremely well funded, optimism was through the roof, and everyone was really excited about what this new type of technology, this idea of intelligent machines, could start to do. Some of the good examples include things like Shaky, the robot, who was able to maneuver and make logical reasoning tasks. We also saw what you could call the first chatbot, called Eliza, and Eliza was able to converse with people, and people thought that they were talking to a human. We also had things like Bloxworld and all sorts of other different new AI ventures. But unfortunately, it didn't last too long. Through the mid-70s into the early 80s, we saw an AI winter. Now, in research, a winter means that funding stops to being given, so ceases to exist. And unfortunately, optimism is lowered on what is actually possible. This can happen for many different reasons. Let's explore a couple of them. So these 4 symbols show some of the issues that might have come up during that AI winter. So one being compute power, the limited compute power that we had in the mid-70s to 80s. Then also looking at combinatorial explosion. So this idea of the amount of parameters or the amount of options that need training in an artificial intelligence agent. This was too much given the power, and also when we start to really optimize algorithms, we start to see better choices of combinatorial explosion. We then start looking at the data. We take advantage so much right now of how much data we have available, data we can create even. At the time, there was not as much digital data, and this did hinder the process of creating some powerful algorithms. And then finally, framing the problem. So thinking about the question that we're going to ask of the AI. Were we asking the right questions? Were they narrow enough? Because we know that AI can be good at, incredibly good at one thing. It was also during this AI winter and with these issues that we saw quite a lot of criticism of approaches. So we burst through with huge optimism, but sometimes we do have to critique each other's work so that we can continue to progress. At the time, there was criticisms on the Turing test by John Searle and his Chinese room theory, but there was also criticisms based on things like Eliza being the first chatbot and whether it was ethical what Eliza was doing in all the different forms that it was available. During this time and as we progress forward, Marvin Minsky was known for talking a lot about scruffy versus neat AI. So neat AI being this idea that you have lots of different options and trees and logical reasoning behind the applications of AI that you would build. Scruffy AI became something slightly different. It was this first idea that you have an object, they describe it as a small bird. If you have a bird, there's this whole world that lives around this bird, all the different things that you associate with birds or that bird would associate with life. And that was the idea that people started to build. They built them into something called scripts or frames, and interestingly enough, it's said that this type of technology actually led to some progressions in object-oriented programming. Into the 1980s, we were starting to get somewhere in production. Expert systems were becoming really popular because they became the focus of AI, given their huge business impact. People were saving millions and they were finding it incredibly useful to their business processes. This was also the time, probably a little bit more behind the scenes in research, that there was the revival of something called connectionism. Now, myself and you, we might know connectionism actually by a better name now, which is the application of neural networks. So things like Hopfield net, backpropagation, and applying these different processes to neural networks was a real step forward and something that was being revisited. Just before the early 90s, AI hit another cold wind, let's call it maybe, over an AI winter, in the sense that these expert systems that were showing such value for large business were actually really struggling now to maintain them. The hardware was really specialized, and this was at a time where we were democratizing other technologies. So we were starting to say things like a personal computer on everyone's desk and all sorts of other things in the space as well, that actually it was all about giving it to everyone and not keeping it for certain people. During this time and in the 90s, we started to find that a lot of different AI approaches would come out of things with faces or things with human-like appearances. This was the promise of AI, the introduction of robotics. And we started to see everything that came out of our AI felt like it had to have a face, which was not always the case. And we know that now, that it doesn't necessarily have to have a face to be incredibly powerful. And during this time where we saw AI with a face, we also started to see all of those issues that we described in that first AI winter coming into fruition. We have much larger scale compute power. We have an excessive amount of data. We're getting better at framing the exact question that we want our AI to answer. And we have algorithms that are getting incredibly optimized for different approaches that you're going to use. And so all of these things meant we can keep pushing forward with AI projects. And so we kind of get to the now, and I have these pictures of jigsaw pieces because artificial intelligence started as a single area. Over time, it's broken down into different jigsaw pieces or different segments. That means different parts of the AI spectrum can be focused on in a certain way. It also means, if you ever heard it, if someone says, oh, someone's an expert in AI, they probably absolutely are. But one of the interesting things is, what specific parts of AI have they been working in? Because they all follow and all cross-collaborate across the different areas. Sometimes AI can feel like too much of a broad term, and so these jigsaw pieces have helped us really understand what's possible with AI. And so in this segment, I've taken you on a really whirlwind tour. I highly recommend going and researching the history of AI yourself. It's fascinating. So now we've talked about where it's come from, I'm thinking we're going to go and explore a little bit more about what it actually is, AI.
Well, Nikama, that was a great video, right? That 10 minutes video had so much to cover about the history of AI, and especially. Never mind. I had the tab open on different window. There was so much that Amy covered in just about 10 minutes. I really liked that winter AI part where she covered on how things stopped in the field of AI. Having said that, Nigama, what is the next session at this event?
Our next session is implementation of linear regression models, and our speaker is Karthikey. Welcome, Karthikey.
Hello everyone. So specifically talking hello folks because community is related to inclusive event, so we are talking on hello folks. Yeah.
Okay, that's great, Karthikey. You have a very exciting topic to talk today. Linear regression, very basic, and I would say the very first step, but it's on TensorFlow.js now, which makes it very, very exciting. We are looking forward for your session. I see you have shared your screen, and yeah, you can get started.
Great. I hope so. My screen is visible to all the attendees. So like implementation of linear regression model using TensorFlow.js. Even though those who are not familiar with machine learning as such, I also give a small introduction of linear regression. So getting into anything, what is TensorFlow.js, especially that what I will go to. So actually who I am. So my name is Karthikey Rawat. I'm also been a member of TensorFlow.js SIG and working group member. I am also GSOC student this year under TensorFlow.org, and I contributed to TensorFlow.js for MLSA, and I'm a beta MLSA right now. I'm a founder of my own local community, OpenCo. I'm also an organizer at TensorFlow user group Chandigarh, and you can see him on Twitter on KerryCoolDude if you want to join me. Yeah, cool. So what is TensorFlow.js especially? So it's an open source library for machine learning, specifically for the web developers, those who are using JavaScript, obviously. Cool. So machine learning in JavaScript, why and what is TensorFlow? Those who didn't know about, I am talking about here totally on beginner's end. So TensorFlow is a free and open source software library for data flow, differential programming, or specifically some scientific programming across a range of tasks. So it is a basically symbolic math library, you can say. When we're talking about machine learning, computer vision kind of stuff, it's only related to mathematics only. So all the mathematical libraries, in short, in terms we can say it's a machine learning or deep learning library specifically. Yeah. So in TensorFlow.js, why TensorFlow.js? So because use ML anywhere using JavaScript. So actually, JavaScript can run on browser, server, and browser talking about like we can support on the Safari, and like I will talk about later on that also. But you can also work on server, desktop application, mobile application, and also for IoT. That's pretty much cool. So talking about more on the tf.js for where it can support. So in browser, it can support Chrome, Google Chrome, Safari, and Firefox. In server side, the whole server, you can say backend stuff is based on Node.js. So you can go on there. Cool. In mobile application also, if you are a React Native developer, if you are a WeChat developer, or specifically I'm talking about PW, that is you can say professionally web application specifically. So you can go on there. In desktop, Electron framework is also we are supporting here also. If you are very fond of desktop application. IoT, Raspberry Pi, I hope so many of you know those who are being active in IoT community specifically. So yeah. So via TensorFlow.js, so it basically run, retrain, and write the very existing model also. If you want, you can use pre-trained model that is obviously in TensorFlow Hub. You can see all the models of machine learning models that is supported by TensorFlow. Again, if you want, you can retrain that existing model that we called transfer learning. At the end, I will show a small demonstration also. So, and how you can also write the model in JavaScript. Like many people thought that we only write the machine learning model in Python. But now that's the power of JavaScript, you can say. You can write the model, machine learning model in JavaScript also without very from scratch. Cool. So pre-trained model, I'm just giving you a small intro about what is pre-trained, what are the pre-trained model that is there in the TensorFlow Hub. Image classification, object detection, body segmentation, pose estimation, text toxicity. If you are in NLP also, so sentence encoding, like text toxicity, speech command, and KNN classifier if you want. And if you want to explore more on it, you can go to TensorFlow.org JS model and you can see over it. Cool. Now, talking about object recognition using Cocoa, so that is a demo that is demonstrated by by our community, and you can see over. I will just going through on that end. So with a little bit of creativity, yes, that's a superpower. Web development, those who thinking like machine learning is a very trendiest thing, but we web developer can't understand. No. You just need to have a basic knowledge of machine learning, and you can do a lot of in a creative end. Also not in creative end, if you want to explore on the development end also, that's a great opportunity for web developers to get into machine learning using TensorFlow.js. Cool. So another delightful creation that's like you can say TensorFlow.js has used of like using a clothing size estimation. So it's just like it's done by our developer, senior developer advocate, that is Jason Maves, and it's a like open source, so you can go there and like if you want you can contribute to, because I'm like a big fan of open source. Cool. Now transfer learning. So we can retrain the existing model to work with your own data. That's the transfer learning meaning. And talking about how you can do in cloud AutoML also. As machine learning, as TF.js also support in Azure also. So if you are very good with Azure, you are good with deployment, that is when we call MLOps. It also supporting Google or Google Cloud also, but also it's supporting Azure also. And I am also like working on over it. So we can give a on that end. So how it works is simple. You have to create a model, just optimize it. Why I'm giving you this kind of, so you can kind of a brief if you want to deploy the whole machine learning TFJS model on your cloud. That's super easy, because all things are specifically on the cloud only right now. Cool. So I'm not going into, so the basic command was when we talking about very basic kind of thing, why like how you can do that stuff. Cool. So with the use of that, what you can do is like just create you didn't need to install anything. I'm truly saying you didn't need to install anything. You just have to connect it with internet. You have to use a CDN link that is in script tag that you are seeing source equal to cdn.js deliver . So you can use that, directly use these CDN. You didn't need to install anything. You have to use directly using internet. You didn't have to train. Again, training is done on the cloud. So you didn't have to pay anything. It's all free. So you have to use directly on that end. And normal thing, because it's a training, when we're talking about training, it takes time. It takes a lot of time. If I'm like building if I have a lot of data, so training that data for that particular model, it needs time. So that's why we use async function in JavaScript. Those who are pretty much familiar with JavaScript, they pretty much know why I'm saying on that end. Cool. Now TensorFlow, write your own code. That is superpower of TensorFlow.js. Cool. And on the API structuring, how you can create your own models. Today I'm talking about linear regression, but again, how you can make a bigger models also using TensorFlow.js if you are a JavaScript developer. Cool. So I'm just giving you a normal architecture out of it, how you can do that stuff. So there are 3 layers: model, layer API, and core ops API. You can say that is the main high level stuff, but you didn't have to go there. You have to work on mostly on the model and layer API as a beginner. If you want to go in depth of TensorFlow, you can do a lot of things. So just giving you there is two part. First is client, that is you can work on browser, WeChat, and React Native that I am show earlier. So what it support, CPU, WebGL, and WASM. Now it's added on WebGPU also to enhance the power of model in terms of like speedability, or you can say in terms of sustainability of talking about models. Cool. And in server end, if you are like a backend developer, okay, so you have to work on only on a server and you can say Node.js kind of thing. So it also supports CPU, GPU, and also now in recent year we are working on TPU also, that is tensor processing unit. And I think I hope so you got something over that end. So again, all the Keras model again, because TensorFlow is inspired by Keras total stuff. So the whole starting layer are from Keras, and you can say again, there are all other feature, that is TensorFlow shaped model, TFJS converter. If you are like a Python developer, you're not in JavaScript developer, suppose. So what you can do, you can use TFJS converter. You need to do anything. You just create a Python script on that particular maybe if you're creating or training that model. So just convert it using TFJS converter. It's just a simple thing. I will ping all the resources in the end. Cool. So the modern inference that what we got from the server is great, talking about when we're comparing about say. So you can also use Hugging Faces. That Hugging Face right now very popular right now. So you can use that also. Cool. So 5 server-side superpower that TensorFlow.js can give you: privacy, lower latency, lower cost. Lower cost is like ineligible because it's like a free kind of thing. If you're deploying any stuff on the cloud, so again, but it's kind of you're contributing to open source community. It's like that only. And reach and scale, because it support GPU support most of the 84% of device through you can say WebGL. Cool. Talking about server, use TensorFlow saved model without conversion. You didn't need to like if you have like a 2 to 3 GB data and you are training that. I'm taking an example, but it's okay for our system also because it's again supporting WebGL. So it's a very, very safe space, you can say, all on that end. And coding in one level, if you already use JavaScript, it's cool. Also, I'm again talking about like you can convert the whole stuff. If you're a Python developer, you can directly convert the whole stuff into JavaScript. And processing, it's also supports C-binding, JetBoost. Basically if you are very, you can say WASM means WebAssembly kind of thing. And you want to specifically talking about, or like you want to speed up the model because binary binding are the fastest one because it directly connected to the assembly level language or machine level language, you can say. So that's the power of TensorFlow.js. Again, we are working on WASM part also. Cool. Now the main topic that we want to create, that is linear regression model. So talking about, even though if you are from a school folk also, and you want to explore linear regression model, so what you can do actually, so just go a normal y is equal to mx plus c. I think so many people have got this. So it's even though you didn't know about what is y is equal to mx plus c, it's simple. It's a straight line and dot. If I get a data points are suppose if I'm taking a comparison of what image that is showing in the PPT, you're taking there is many dots are there, and if the majority dots are creating a line, that's a linear regression model. Again, linear regression model talking about if you have a straight line with connected with data points, that's the linear regression model. Linear regression means straight. Cool. Now how I implement, because I implement linear regression model in terms of very graphical and representative end. So what I have to do. So libraries that we will use, again, TensorFlow.js. So you have to use script source. CDN file, you didn't need to install anything. Again, I'm saying you didn't need to install anything. Just add CDN file to it and you can do awesome stuff. Again, I'm using p5.js. Why I'm using here? Because I have to create, because in JavaScript, we have to create canvas for that. So I have to create canvas and many stuff also. So it makes p5.js helps me better to use that because it's a framework again. So there is a like code from one of the researcher called Smith. Somewhere between simple linear regression, deep neural network, he grew up become as a data scientist. Cool. So those who are thinking linear regression is a very basic, it's not came into maybe deep learning. No, you are wrong. It's like a very basic part of the deep neural network. Cool. So let's jump into the code. So what we will do, first we create a HTML file and JSS file, add CDN to HTML file and link the JavaScript file with the HTML, as you know, normal thing, and jump into the linear regression one. So I will come back to the slide of this one because I will show you the the link specifically. I will share with you all if you want to give collaborate on my small project. Cool. So what we need to do here, normal, create HTML file. Cool. tag if you want to give a title like tensor. I've given a title tensor. So just add script tag, 2 script tag I added. First one is for tf.js and second one is for p5.js. Again, because in p5.js you didn't need to install anything, directly use CDN link, and you can just directly go to the Google and search it about what a CDN link for p5.js and CDN link for tf.js you will got easily. Cool. And you need to add body kind of thing, anything, because it's very basic stuff. So I'm going now the main thing, what we are doing here. So as talking about linear regression, that means y is equal to mx plus c. Cool. So yeah, so here m, that is slope, and the other part, that is b, is the constant one, because it basically iterate on that, and iterate means it will just fluctuate on that. I have to retweet on that end, because if we want to stabilize the model, or if you create a better model, a better prediction, so I have to reiterate it. So again, I'm then given the depth of what is linear learning rate and optimize. Just understand what I'm doing here. Cool. So suppose I'm taking a constant called learning rate about 0.5. Cool. Now, optimizer, those who didn't know what is optimizer, just to optimize the whole model in a better way. So I'm using a model optimizer called SGD, that is stochastic gradient descent. And those who are pretty much familiar with machine learning, they pretty much know on that end. Now, function setup. So this is the part of p5.js. So there is 2 functions that I will use, setup function and draw function. So that's the part of p5.js. So what I'm doing, I'm creating a canvas that is a 400 cross 400. Now, m and b is like a tweaking kind of thing. So what I'm doing, I'm just creating 2 variables. In TensorFlow, those who know, in tf.js, I'm creating variable like this: tf.variable, tf.scalar, and random one, because it can be created a random generation on that end. Same with b, because it's I have to tweak these parameters actually. M and b, I have to tweak this parameter to make a stable model again. Cool. Now we are here. Okay. So for talking about the loss function, and why I am coming with a loss function, those who didn't know what is loss function, actually it's normal thing, like how I can reduce the errors that I got from the loss function. Basically, I have to reduce the error, or I have just find out the error. So what I can do with it. So there is a function in JavaScript, you can say prediction. Again, it's a part of tf.js. You can go to the documentation of tf.js and you can see all the function out there, what I'm using. So prediction.sub means subtraction, labels dot square dot mean. What is the meaning of this? The subtraction of labels. Labels means it can be, I'm taking an example like x0, x1. I'm taking in a coordinate of it. So what is the subtraction of labels mean? x0 minus x1 dot square mean x0 minus x1 ka whole square. Then I'm taking a mean, and after that I get a prediction out of it. Cool. Now I take a function called creating a function called predict, because I have to predict also. It's not like that I just giving from that in the loss function, what we got the errors. Now I have with removing that error, I have to use it into real time, that is in prediction. So I'm creating a variable called access. So I'm creating a tensor basically, because if you're talking about deep learning, all things are done under tensors. Tensors are talking about, it's just a upgrade version of vectors. Vector is a 2-dimension, so tensor is a 3-dimension. We contain 3-dimension kind of stuff. Cool. So what we are taking, I'm taking an x over what is the value and storing in form of tensor. Same with ys. So ys, what I'm doing, access dot mul, that is multiplication of m dot add b. That is mean as simple as mx plus c. If you say m into x plus sorry, not c, that is b, and I'm just returning that particular ys to the prediction, that what I got a prediction. Okay, cool. And the function mouse pressed is that I have to add the data points also over here. Cool. Now for adding the data points, again, there's a function in p5.js mousepad. If I click and I'm just creating some of the parameters, that is mouse x, mouse y, 0,0. That is from the coordinate of, you can say coordinate of x, y common thing. And what I'm doing here, I'm starting from 0 to width, same with 0 to height. And talking about the x and y coordinate 0,1 and 1,0 is the normal thing, is like from the x, what I'm doing from starting from 0 to 1, and from y I'm starting from 1 to 0, like dropping that. Again, if I increase the x, y will decrease. As simple as the logic is. Cool. Now, this is the main important thing, why I'm doing this and why it is happening here. So cool. I created a function called draw. Now tf.tidy, it's the because on every constant, or that the value or the retweeting parameter that I'm doing, because it's creating new values. So I am actually creating new tensors specifically. So I have to, because I have to use only my only the tensor, like about maybe I want to, because I reiterate that, so I didn't want to create extra tensors. So removing that extra tensor, I'm using here. So what I'm doing, if x dot value dot length is greater than 0, I'm just taking a condition over there. So if the ys, that is, I'm just converting the whole thing into tensor and just optimizing that part in a minimize, like I have to minimize that stuff. So that's what I'm doing here. Cool. Now the starting one, if you will see, background 0 is the color I have given in a black, I hope so, black one. Cool. I'm just giving a stroke of 255, that is white. Stroke weight is 4. So yeah, I hope so you got in that end. And I'm just creating a loop. Why I'm creating a loop? This is the p5.js part that I'm doing, the background, stroke and stroke weight. So actually what I'm doing, I'm creating a loop from 0 to, like, I'm starting from I equal to 0 to x value. That is the particular length of that particular maybe array. And I'm mapping that part basically. I'm just mapping. If I'm creating a dot, so it should be create like a symbolize over there. And as I want to accept that as a data point. Cool. So I'm just taking as okay. So this is the looping I have to done from 0 to x and from 0 to y kind of thing. Cool. Now what I'm creating, I'm creating a line x kind of variable which is starting from 0 to 1, and I'm just predicting that stuff with a function again, tidy and predict line x. From line y, this is the function called data sync, because I have to sync the data from the ys. Why I'm doing that? Because I have to compare with 0, because line x, that is 0, 1, that I created a parameter over here. And ys.dispose, the dispose function is to kill the all tensor that I created for this particular model or train that particular model. Cool. Now what I'm doing again, it's the same thing with I've done with access. So I will same thing will happen with ys. So again, and the ending ys.dispose, I'm killing I'm killing all the tensor that I created during my whole training stuff. Cool. Now at the last, what I'm doing, last but not the least, you can say, so I'm just adding 4 available x1, x2, y1, y2, because linear regression have a straight line. Cool. So if I'm talking from starting from one point, that is comma, that will be x1, y1, and it's ended from the point x2, y2. So that's what I created here, like line x, I'm taking 0, 0, then 0, 1, 0, from 0 to 1 and 0 to width. Same with x2, y1 and y2. And I'm just adding the stroke weight because I have to create a line for that. That's the data point that I've added over there. Cool. At the last, if you want to check up like my tensors are killing or not, so just console.log tf.memory.num tensor basically is a function, it's a function, basically memory function. It contains a sub function that is num tensor, in which it's telling about what are the number of tensor that it's created by him. Cool. Now let's go to the demo to get indulged with you on that end. Cool. So I hope so it's visible to all, and I'm just going to the you can say the tensors part, and yep, so this I'm just adding random values over here. Cool. I'm just adding random values over here, and it's stabilized. Like I'm just going like in a, like suppose I have to make in a line, so I'm just adding, and it's actually stabilizing it. And if you see after 5, why it happened only for 5, because it use only 5 tensor, because if I remove the dispose part, so it will generate so many tensors, and you can do stuff again. All the things are open source in my GitHub, so you can, if you want, you can do that stuff also. And it's stabilizing. If I'm going suppose here also, so it's stabilizing on that end also. Cool. So I hope so you got the, you can say, descriptive point of that end. And yeah, cool. So let me go to the next one. Now I done with my demo. So how TensorFlow.js can use, it's a come a long way again, because we got it like it's like old stats, you can say 2.6 million downloads, but right now I think so it's about 3 million plus. I hope so. And there is so many issues. If you are like an open source contributor, if you want to explore WebML, so that's a chance you can start contributing to it. And yeah, community is so much welcoming about it. And yeah, at the end, what are the future WebML? If you're very interested in projects of WebML, so what you can do? Machine learning offers enormous possibility for the web. We are still early, but we need like trendiest kind of thing you can say on that end. So high value application and solution for the ML use in front end web, because we want to make it as simple as it is for the web developers, because again, machine learning is the future, you can say on that end. Parity and unification with the rest of TensorFlow tooling, and we are performing very improvements on the performance-based improvement. Also, we are coming with some hardware stuff in collaboration with the Intel and Microsoft also. support for more platform, task-oriented model with standardized metadata. Also, we just collaborated with Microsoft, TensorFlow.js and Microsoft collaborated on a data science kind of tool. And if you want, you can explore it. It is on the TensorFlow YouTube channel if you want to explore on that part. And we also working on security and privacy, because why I'm saying security privacy are important, because again, your whole model and whole data that we are consuming to train yourself, or you train that particular model is really important, because data security nowadays is a very, very important thing. Cool. So what are the resources you can use? So again, this is a book, Deep Learning with JavaScript. So you can go there. It's from the Manning publication. So you can go there. If you want to explore more, you can go to the website, tensorflow.org/js. All the models are in the tensorflow.org/js/models. If you want to contribute to GitHub, so again, github.com/tensorflow/tfjs, it's under TensorFlow organization. Google Groups, again, if you want to join a mailing list, tfjs@tensorflow.org is there. CodePen of TensorFlow is also open. So if you want to explore TensorFlow or TensorFlow project, all the CodePen, all the projects are listed in CodePens. And also we are on the Glitch also. So if you want to join a Glitch and we want to explore through Glitch, the tutorials that we are creating over here. Cool. So join the community. If you got something insight from this session, take a screenshot out of this, folks. Tag me, tag Global AI Community, tag MLSA, and tag if you want, you can use this hashtag Made with TFJS. We are bringing so much in the machine learning stuff, and we are increasing day by day, and we are focusing on that. Community can do anything if you can support us, and community is a way you can explore so much thing from worldwide. Cool. So this is the thing that you can just go to this challenge and you can complete learning book, because again, learning a model by focusing on learn module, because again, if you can learn model, you are basically doing a social value kind of stuff, and that's really important nowadays. If you can learn, because it's also increasing your skills, and that's a positive or greater impact for social environment also. From your learning model, it's creating a tree. You are planting a tree in short, you can say. So it's a great thing that what global AI has come over it. So I hope so you got challenge on that end, and stay in touch with me. If you want to connect with me, you can follow me on Twitter. And if you want to connect with me, my whole stuff is on Kerrycooldude on that stuff. So yeah, that's what I am indulged with right now. So yeah, I am ended with the session. Yeah.
That was a great session. I would say a very fast-paced session. It sounded more like a Channing Express. But that was absolutely great. So Karthik, a quick question. I saw you using the CDNs right now. Yep. CDNs are very fast, but sometimes they would also give you a problem with the page loads. Are there any other ways where we can incorporate the TensorFlow.js in that existing, say, Vue project or React project or Node project?
Yep, sure. So also, if you are not good, it's truly saying by Simmons on that end. Like CDN is also sometimes maybe it's not preferable, because if we are working on development end. So yeah, NPM packages are open to NPM and Yarn packages are open for, again, if you want to explore more models, you can again go for there. And if you just want to use the framework, again, NPM package for all Tensor, if you want to install directly from NPM also. And if you're a Linux guy, if you're a Linux folk, again, you can use a Yarn also. Yarn is preferable over that end. So yeah, you can check out the NPM packages, search NPM package of TensorFlow.js or TensorFlow.js, and you can easily got it. Yeah.
That's perfect, right? That solves the problem that, hey, if I don't want to use the CDNs, I want to install in my project itself, then there are NPM and Yarn available. Okay, having said that, you did create a canvas, right? So that was a pretty cool demo, and you did say about linear regression. So are there an entire library, just like we would have in scikit-learn or other like PyTorch, an entire library for algorithms? Is it the same way how it works for TensorFlow.js?
Yeah, so there is a repository, not about the library I can say, but there is a repository called TensorFlow.js, TensorFlow.js examples, where many people just collaborated over there and share their project, like mini project. Maybe I created a small project for linear regression, but there are many people who just created small code labs on that end. So if anyone wants to, if anyone created using TensorFlow.js, so they can contribute over that project also. Again, if you contribute there also, it's like you are being a part of the family of TensorFlow. So yeah, again, it's like open source kind of stuff. It's not a library as such, but if you want to explore more, and there are many projects listed in that particular repository. And again, if you think you have a greater idea during TensorFlow.js, again, you can made it tag JSON may and use hashtag made with TFJS. So actually there is a stream by Jason has done on more. And it's kind of a 3+ session has gone on that end, where from around the world, people, those who are used TensorFlow.js in their project, it's kind of a like showcasing that stuff. And yeah, again, if you're not good with that showcasing kind of stuff, again, you can contribute to TensorFlow.js. Also, we are here in the GSOC also, so you can also create a maybe kind of a project idea like I want to work in. So if you are good with bringing that idea into GSOC, that's also preferable also. Yeah.
Absolutely great. That reminds me that there's also not just with TensorFlow.js, right? There are other I would say libraries like Rubix ML. It's a library that's used for the PHP developers, right? If you want to, if you're on a Laravel application and you want to use PHP to write all this linear regression, you can also use Rubix ML. So that was great, Karthikeya. I would say you covered a lot in just about 25 minutes, right? Well-paid session. Any final thing you want to plug in before we move to the next session?
Yeah, so I just want to say, folks, those who are listening to us, do not take tension. Like many people I saw in community, they are very fear of like machine learning. It's a kind of big thing. No, it's a not big thing. If you want to get started with the machine learning, again, you are a web developer. I must say start with TensorFlow.js because all things are pre-trained. You didn't need to create anything. But after that, if you got a you can say energy kind of thing to more work with machine learning, then you can start get deep dig into like throughout the organization of TensorFlow or PyTorch or any machine learning organization that is available in GitHub and start working on it. So yeah, that's what I want to say on that end. Cool.
All right, that was good, Karthikeya. Thank you so much. Have a nice weekend ahead and really appreciate your time. And yeah, take care. Have a nice weekend. Ta-da.
See you all, folks. Yeah.
All right, Nemgama, I think it's one session until we wrap it up. We both wrap it up, right? So what is the next session we are looking at?
Exactly. I hope everyone is still engaged in the conference. Yeah. We have a lot more interesting sessions to look forward to. Talking about that, our next session is going to be about what it takes to be an NLP engineer. So let's welcome our speaker, Usman.
Hi, Usman. Welcome to Global AI Student Conference. How are you doing today?
Hey, Stephen. Thank you for having me here. Can you hear me properly?
Yeah, you are loud and clear, and we can see very clearly. Thank you so much for your time, Usman. I really appreciate it. We won't take much of your time. Feel free to go ahead and share screen, and then you can get started.
Sure.
All the best.
Thank you. Okay. Hey everyone, so today we're going to be talking about what it takes to be an NLP engineer, and this is just like sort of an introduction about me. Who am I? I'm a beta MLSA, and other than that, I'm a Microsoft certified trainer. I have conducted sessions for well over 500 people, and other than that, I'm professionally a machine learning engineer in NLP, and all of the other certifications, you can see it on the screen. So before any further ado, let's get started. This is going to be the agenda for the talk. We're going to be looking at machine learning because in order to address the elephant in the room, which is NLP, you first need to know what actually is ML. And you need to understand how ML, DL, AI, and NLP works in order to properly dive deep into NLP. So this is the agenda for the talk. Let's move forward. Now, the very first question most people who just start off with machine learning have is what even is machine learning, and they usually come across the equation like Karthikeya also explained, which was y is equal to mx plus b, and that is like the very first thing that comes up if you search what is machine learning, and it can get a bit tedious. So I've simplified it for you. Like machine learning is the process of building models that can understand and predict patterns in text, numeric, and visual data. It doesn't have to be just numbers, or it doesn't have to be just images or those sort of things. It covers a very broad perspective. So this is like sort of a Venn diagram. This will help you visualize what actually is ML, DL, and AI. AI is you can say the master class, and ML is its subclass, and DL is its subclass as well. And you can see that data science, like this is one of the like I've seen 10 to 20 posts every 1 to 2 hours on LinkedIn on people getting jobs in data science, like in and getting a 6-figure salary in that. So data science is also covered in this domain too, and you can see that it is like standing out from this domain as well. That's because you also deal with statistics and data science as well. That's the reason it's here. Okay, so moving forward, we have 3 types of machine learning. We have supervised, unsupervised, and reinforcement learning. And then each of those types have 2 different types, like we have regression and supervised learning and classification. You can think of regression as like sort of problems in which you're dealing with continuous variables, like whenever you're predicting something that is continuous, that comes under the domain of supervised regression. And when you're dealing with discrete values, like whenever you're predicting something which is something discrete, it comes under the domain of classification. And same goes for unsupervised. We have clustering and dimensionality reduction, where you basically we're not providing any label data to our models in unsupervised learning. And then we have reinforcement learning. This is something which is like applicable to real life, and this you can everyone has heard about Tesla, right? And that can come under the reinforcement learning because it's real-time decision making. It works on the principle of reward and punishment model. So these are just like the basic info that you need in order to get started in NLP. Okay. This will help you understand the entire ML space much better. We have real life examples here, and if you guys want to take a screenshot of this will help you, especially if you're a newbie. Okay, so let me move forward. Now, what can you do in ML? You can you can be an AI engineer. You can cover the broader AI perspective and deliver AI applications, or you can work as a machine learning scientist or an engineer, and all of the domains are listed here. And the top domains that are in AI are NLP, computer vision, and data science. Other domains are there as well, but these are the most prominent ones. In computer vision, you're usually dealing with problems which are related to images or videos, and in NLP, you're usually dealing with problems which are related to text. So we are going to be covering NLP. We're not going to be covering computer vision. Karthike, or like another speaker already covered that. Okay, so now we're starting NLP. Now, you might see yourself, you might put yourself in this situation. You might be thinking, what is NLP? Like, it sounds so much like a buzzword. Let me break it down for you. It's not that big of a thing. It's really like a simple domain, if you might say. Everything that is related to text, and you're using an interaction between the computers and the human language, and you're building something off of that, and so that your model understands the natural language, that comes under the domain of NLP. It's a subfield of linguistics, computer science, and artificial intelligence. It like overlaps all of these domains, and it can be either text or speech. Like it's not only that you're dealing with textual data in NLP. There's also an audio or speech part in the NLP space. Okay, so now we have 2 different types of NLP. We have NLU and NLG. NLU is natural language understanding, and NLG is natural language generation. And what do both of these domains do? We'll see in the next few slides. This is like the Venn diagram of NLP, where NLP lies. You can see that just like data science, a lot of the space is being covered by linguistics, and like NLP lies somewhere in between artificial intelligence and linguistics. That's because if you ever had a chance to work with NLP problems, you might have seen that a lot of these problems are not related to computer science at all. Like let's say you're writing a regex or a pattern matching algorithm in NLP for your pre-processing stuff, and like all of the rules that you've written for your regex, they are nothing related to computer science. They are always related to linguistics, like subject should come before the verb or after the word, and context-free grammars and those sort of things. So yeah, moving forward, this is the difference between NLU and NLG. In NLU, you're usually dealing with decisions and actions. Yeah, and you're also dealing with classification, NER, sentiment analysis, and clustering. Like you're trying to understand what the text means. Let's say I am saying, I'm not feeling well today. What does this text mean? What category does it belong to? Does it belong to happy category or a sad category? Those sort of things. This comes under the NLU domain. And when you're dealing with text generation, like whenever you're generating something, you all might have heard about GPT-3 or GitHub Copilot. That comes under the domain of NLG because you're just providing your model instructions on what to do, and your model will generate the entire text for you. Some of the prominent examples are LSTMs and BERT. BERT is really prominent in the industry right now, and I really recommend you guys to look into BERT. Okay. And what can you do with NLP? That is like the main question people have. You can do text classification. As I said earlier, if I'm stating that I'm not feeling well today, what category does my statement belong to? It belongs to a happy category or a sad category. Or let's say I'm traveling today, or let's say I'm writing a blog which is about food. How do you classify your article so that it automatically detects its category? You might have seen some news websites, they have proper sections for categories, they have proper sections for subcategories, they have proper tags and everything. Do you think that a person can manually do everything? Like there is around 5 to 10 articles which are published every now and then, like in every 15 to 20 minutes. And how can you keep up with that? Like you have to have a huge team in order to do that sort of stuff. But if you bring NLP to the table, you don't have to worry about anything. You can automate everything in that. You can automatically generate the tags with name entity recognition. You can also classify your articles with text classification. You can also do some sort of sentiment analysis in the comments or something else. You can also make chatbots in it as well. And if like you're dealing with a summarization task, you can deal with the summarization as well. And some of the examples of NLP is, you can see one example here. This is dependency parsing. What this does is this basically parses your sentence, and it evaluates your sentence and visualizes what word is dependent on which other word in that same sentence. You can clearly see that it has correctly identified that A is a determiner to a sentence, and the sentence is an attribute of is, and is the noun subject of this. And you can like start off small, like start off with words and then move towards sentences and then towards paragraphs and then towards entire articles. and then maybe towards entire corpuses. And then we have another example called named entity recognition. Let's say you're writing an article, and that article is about, let's say it's about the new president that has been selected for the US, and you want all of the candidates to be detected from your article automatically. And whenever a person queries on Google or maybe your own custom search engine, that who were the candidates for let's say 2021 elections, your NER model should be able to detect those persons from your article and present them to your user. So these sort of problems are they usually come under the domain of named entity recognition, and you can detect almost anything with it. This is an example of it. This is done via Spatie. We'll see some resources by the end of the slides on how you can achieve these sort of things. And what does a normal NLP pipeline looks like? Let's say you're hired as an NLP engineer and you're asked to like make a model for your company, and you have to make a productionized model which can sustain like different scenarios. So you start off by data acquisition. You acquire the data, and that can be done by various techniques. You can get data in the form of flat files. You can get data from other databases, and totally depends upon the usage. It varies from company to company. Okay, then you have to perform text cleaning. Uh, like this is, I might say this is the most important step in the entire NLP pipeline, because if your data is not cleaned and it's not cleaned properly, you will see issues by the end of the pipeline, and by that time you have wasted your precious time in training the model, evaluating the model, and all of that stuff. So you need to spend some extra time in the text cleaning phase, because this cleaning is different from the cleaning in other domains. Then you have to pre-process it, and then you have to feature engineer it. You have to extract features from your text. You have to remove the stop words and all of the unimportant words in that. Then you have to do the modeling. This is like you can use normal ML models for NLP. It's not that different. The only thing different here is the feature engineering part, because you have to convert your text features into numerical features, because your model doesn't understand text. It only understands like numerical values. So in order to convert that, you can use multiple techniques, and then you have to evaluate your model. And if the model is not performing correctly, you can go back to the pre-processing step, and this cycle goes on. Then you go towards deployment, and then you monitor and update your model as time passes. And then we have the text pre-processing pipeline. This is the thing that I was talking about, that you need to clean your data in such a way that it doesn't affect your model by the end of your pipeline, and rather it improves your performance as well. So you start off with your text document, then you segment your sentences. Like you have an article, you split it into sentences, and then you split those sentences into words. This is called sentence tokenization or segmentation, and this is called word tokenization. And then we have stop words like is, am, I. These sort of things are called stop words. These do not add any meaning to the sentence, so we need to remove it. Then we need to lemmatize it. Lemmatization is like the base form of a verb. Let's say I'm saying winning, and ing, that's a suffix, and we do not need that, so we need to convert that into win, because that's the base form. That's called lemmatization. And then we have POS tagging, dependency parsing. We've already looked into that. Then we have non-phrases identification, then we have NER, and then conference resolution. This is sort of a dependency parsing as well, but it's mostly related to nouns being related to pronouns and all of that stuff. And then we output the data structure representing the parsed text. And then the question arises, who even uses NLP? All of the major FANG companies use that. And one of the major use cases of NLP is in reviews. Like you've seen restaurant reviews in almost every website. Amazon, not only restaurant, like every review. You have product reviews in Amazon. You have like organization and business reviews in Google. You also have like almost everything that you deal with in your daily life. Everyone is dealing with NLP. And why should you care about NLP? Like we're here talking about NLP, and why should you even care about it? And why shouldn't you go towards computer vision and convolution neural networks? Well, the thing is, computer vision and CNN are not bad. I'm not saying that they are better or this is better. All I'm saying is we're just comparing both of these things. And the major reason for being in NLP is that there's a lot of research that needs to be done in NLP. And almost most of the professors that I've met in the university are doing research in NLP as well as compared to other domains. And like major companies are also doing research in NLP too, like GPT that comes under the domain of NLP as well. GitHub Copilot that comes under NLP as well. Like you will see this field booming up really fast, and this is also a very less saturated field. Not everyone knows about it, and you have a like really bright chance in excelling in it. Lastly, you will never get bored. There is always something new. Like there was a trend of LSTMs, and then when people started they started to get proficient in it, then BERT started, and it might be possible that in a few years something else will come, and everything is interesting that is coming in the space of NLP. So these are the responsibilities of an NLP engineer. Let's say you're hired as a NLP engineer, and what do you hope to do? Like this can be your JD. You can like have a look at it, and if you're already studying NLP, you can prepare for these sort of things. You need to design and develop NLP systems, define appropriate data set for language learning, effective text representation to transform natural language into useful features. This comes under the domain of feature engineering, by the way. And like, how should you learn NLP? I always tell people that you shouldn't directly dive into NLP. You should first like focus on your foundations and get a stronger theoretical grip on things before moving on to practical stuff. Because practical stuff isn't that much difficult. Like Python, you can write a three-liner, and that can like train an entire model and like test it as well. So you don't have to worry about implementing it. You have to spend an extra time in like building a good foundation in your ML and in NLP. You should start off by C++ as a first language. And many people might disagree with me that we should always start with Python or JavaScript. But the thing is, when you start with C++, you usually like it might seem difficult to you, but it is really helpful for you in the long term because it tells you what is going on the back end. Like you're assigning data types to variables, you're using pointers, how is the data stored, and what happens if you store a different type of variables in a single array. And like there's a lot of stuff that you can learn if you start with C++. So this is my recommendation, and you'll never regret it. And then after you've learned C++, then move on to Python. No one is saying that you shouldn't start learning Python. I'm just saying that this should be your priority, and then the second priority should be Python. Then start off with OOP, and then start off by the theoretical foundation for NLP and machine learning. I'll also state some resources in the upcoming slide as well, and then you can do all of these stuff as well. Also, you can go to my GitHub because like since I'm an open source contributor, I strongly believe in the open source world, and I've been committed to open source as well. And you can find a lot of resources related to NLP and ML on the GitHub, which are totally open source. If you want to contribute to it, you can contribute to it as well. And then the like specific resources that I would like to recommend are the first one is Andrew Ng's Coursera course. Like this is a must-have. Like if you're coming into AI and if you haven't done Andrew's course, like it is considered a sin. You have to do it. Okay. And then another recommendation is called DataCamp. DataCamp is like a great starting place. They have a proper path for data scientists, proper path for data engineer, and all of the paths are clearly defined. You can like go there and check them out. They have free courses as well, and yeah, there's a YouTube channel called IntelliPath. They have a NLP course as well. I would highly recommend it. They have spent a lot of time like curating the course, and I will really recommend it. And I would also recommend you guys to look into GitHub Student Pack. GitHub Student Pack is an offer for students by GitHub, which provides you a lot of features. Like it provides a lot of services to you for free, and then I would highly suggest going for Microsoft Azure as well. And if you're a student, you can get a lot of resources for free. And last but not the least, Microsoft Learn. They have like a really good curated platform where everything is separated into separate modules, and it is really summarized well. I would highly recommend you guys to watch it. And what do you need to get started in terms of tool? All you need to do is install Anaconda, and you need to install Microsoft VS Code. That's it. You do not need to install anything else. You can just start off with Python as well, but Anaconda comes with Jupyter Notebook and all of other stuff. So it can help you in the long term. Okay. So moving forward, there are some myths in NLP and ML that you need a lot of math in ML. And believe me, you do not need a lot of math in ML. And I'm not saying that you don't need math at all. You do need that. You do need it. But I'm not saying that you need a lot of it. You just need to have a sound understanding of whatever like you're working with, whatever you're dealing with. Like if you've come to graduation, believe me, you are more than capable in dealing with math problems that you face in NLP or ML. And there is also some people who say you don't need math at all. I would disagree with them as well. As I said earlier, I'm not saying you need a lot of math, and I'm not saying that you don't need math at all. You don't need to be at the extremes. It's not like black and white. There's a gray area as well. So do not go towards extreme, and just have a sound understanding on what you're working with, and just go on with it. Okay. And then there are some people who miss all of these stuff and directly hop into machine learning. Don't do this, please. It will only hurt you. Do start off with like proper data structures, then problem solving, discrete structures, calculus, and statistics. And the chances are, if you've done your graduation, you've already studied all of these things. But for self-learners out there, I know there are a lot of ML engineers who are self-taught. So please do follow the proper path. It will help you in the long term. And another question, that you need to be a PhD. This is like a really famous question asked on forums. No, you don't need to be a PhD in order to be in ML. I've seen people without degrees, without graduations, making a career out of NLP or ML. And last Lastly, you need to be a CS major to be an ML engineer. No, you don't need to be a CS major. You can be from electrical engineering. You can be from the English domain. You can be from anywhere and from any domain. There's no restriction. You just have to put in the effort. And there's some comparison between academia and industry. What is going on in the academia? You can like see the comparison here. In thing that I would focus on in academia and in the industry is that in academia you're usually dealing with some old and legacy papers because you're trying to improve on the papers that were already published, and you're trying to come up with a better solution. And there are a lot of opportunities in it, and the language you might face are Scala, R, Python, Julia, and you might go like, what? Scala, R, Julia? Yeah, you can come across those sort of languages if you're working in NLP, because back in the days, Python wasn't that famous, and most researchers went on with whatever they felt comfortable at that time. And this is the average pace position. Things are not as fast as in the industry, and these sort of things do not include deployment most of the time. And in the industry, things are very fast paced, and you're mostly dealing with Python or SQL. And 80% of the time, you're dealing with deployment if you're working in the industry, and you're dealing with state of the art models as well, which are BERT and transformers. And again, if you guys want to connect with me, here is my LinkedIn, here's my GitHub, and this is my email. If you guys have any question, anything, just reach out to me, and I'll help you guys out in whatever way possible. So this is like the session for question and answer. If you guys have any questions, just let me know.
Well, that was a great session. Yeah, go ahead, Niyama. I'll follow up.
No, it's fine. It's fine. I was just saying that was an amazing session. Great memes as well. So you have addressed all the questions that were running through my mind. So I personally have only one question.
Okay.
So what is one application that you think that is using NLP to its full extent, to its full potential? For example, let's say for me it's Gmail, because nowadays Gmail is recommending when we forget something. Let's say we forget to attach a file. Gmail recommends us to do it. So what is one application, in your opinion, that is using NLP to its full potential these days?
Okay, like that's a really good question. And what I would say is the integration of NLP in your social media, because there are times, let's say if I'm a part of the student ambassador community, I get text all of the time. People are reaching out to me, and like my inbox is usually full, and I usually don't have time to reply to all of them on time. Like I do reply to them, but it takes time. What I would like is Facebook, Twitter, or like in whichever social media we're talking about, to integrate NLP services in it. So whatever like depending on the situation, our chatbot or whatever application we're using, it should automatically reply based off of the situation. And they already have our data, so why not make the best use out of it? And it is possible. It's not like I'm dealing with chatbots myself. I know it's possible, and with the resources that these social media giants FANG has, and they can do it. It's not a big deal for them. But yeah, that's my opinion.
Okay, that's very well put. Any other questions, Steven?
No, I'm good. This also reminds me that also in Outlook, right? If you forget to attach put an attachment, it will just say that, hey, I use Outlook, but glad that it also exists in Gmail. So that was absolutely great session, Usman. Thank you so much. Thanks for accepting the invitation. I know it's evening at your place. It's weekend, so you definitely like to go ahead and spend some time out. Thank you so much. And yeah, have a nice day ahead and see you soon. Ta-da. Bye.
Thank you. Bye.
All right, Nigama, I think it's time where we take a break, and we have our next host, that is Luxi and Luisa. Welcome to Global AI Student Conference.
Thank you so much, Stefan and Nagama, for the amazing introduction to our third Global AI Student Conference. That was absolutely amazing to watch at the end. It's so cool. Usman's up super late. I'm up super early, and that's the joy of being at a global conference. Like, absolutely amazing. And so for our second half, we'll have Louisa and I will step in as co-hosts. So nice to meet all of you.
Bye. Have a nice rest of the day.
Goodbye, Stefan. Goodbye, Nagama. Okay, fantastic. So our next speaker is Rohan Raj, and he is a Gold Microsoft Learn Student Ambassador, and he is currently an undergraduate student pursuing his Bachelor of Science in Information Science and Engineering. I love information science, so it's so exciting to meet from him, and he'll be doing his introduction to the Siamese Network. And with that, Rohan, I will let you take it away.
Thank you very much, Luxley. So I'll just share my screen first, and then we'll just go ahead with it. All right, so, okay. So is it visible now?
Yes, I can see.
Hello? Is it visible now?
Yes, it is.
All right, thank you. Thank you very much. So, okay, so starting with this, hello everyone, my name is Rohan, and I hope that all of you are doing well and keeping safe in this time of pandemic now, which is obviously now like things are getting better and we are nearing the end of it. So yeah, it's great to be back here, and thank you for this opportunity to be speaking here at Global AI Conference. So starting with this, today I'll be talking about Siamese network. So I'll discuss in details about what Siamese networks are and how are these different from typical networks, convolutional networks, and how do these work and what's the application of this. So, and in this session, I'll just, so basically this is an introductory session. So here I'll be just speaking about the creamy part of the this application, this technique which is used. So here I won't be going into code and other things like how do we deploy, how do we use it into the main applications and everything like that. But it's just like how do these things work and the background. So first and foremost, let's say where we have seen this in our everyday life when it's we want to unlock our phone, we want to unlock any of the devices or anything related to such stuff. The face verification technique is used in our phones. So how is it different or something like that? Over the decades, what we have been doing is we have been using, let's suppose, passwords for our phone, or let's say 5 to 6 digit PIN, and let's suppose, and if it's an online authentication or something, we use an OTP for that. So these have been the parts which we have been using, but these have they have some defects or something. So over the time we have used this face recognition technique has developed, and it's really good. It's working really good. Like nowadays, the camera which is present on our phone is able to sense the depths of our face. Like let's suppose someone wants to cheat the AI, or it says that if it puts up a picture in front of the camera, your picture, and tries to unlock the device, it won't, because we have seen that, as I mentioned earlier, they try to detect the depth of your face, like the depth of your eyes, the facial structure, and everything. So it's becoming quite advanced now because of the upcoming researches and things that are being done here. So it's a huge growth in this part. So here, I'm assuming that the people who are watching this do have some experience about machine learning and AI, and do have some experience in Python, because I'll be speaking totally about, so I'll be using TensorFlow for this. So TensorFlow is a general tool for Python. So you can this is the prerequisite of it and nothing else. This is just an introductory session, as I mentioned. So we'll be going just over the top. So let's start with this. The first and foremost thing is, how does a face verification technique works on a phone? It might seem that it's like something we take the phone or a device in front of our face, and it's just a verification that's done. But it's quite a bit I'd not say complex, but it's quite, let's say, some things are being done in the background, and we cannot. If you are a computer engineer or you are working in this field of machine learning and AI, you must know this, that how these things work. So first thing first, you show your face towards the camera, and because obviously without showing your face, it won't unlock anything. So moving forward, it captures an image and it runs an algorithm. And here's the algorithm will be today's one of the algorithms which we'll be talking about and how do those work. Next is it tries to find the similarity between your face. Like you had observed that once you're trying to set up a face unlock on a device, it takes several images of your face, like, and even from the different angles, I'd say. Like, let's suppose if you're trying to unlock your phone from right facing, making your face turn towards right, it does unlock it. It does not say that hey, your face is not positioned correctly and I'm not going to unlock it here. So yes, this tries to find the similarity score with your face so that you can unlock the device, and then it does some action based on the similarity score which it has produced. So these are the four major steps, I'd say, which are involved, and these do have some minor steps in between, which are like running the algorithm and as fast as it can, utilizing the device resources and everything. This is first. So the major question between, like, what is the difference between recognition and detection? So yeah, this was the first question which I even asked myself when I got into this. Like, what's the difference between these? Recognition and detection are like, there's not much different. They both use convolution neural networks. They use have a full deep neural network, and they use images. The model tries to learn, and the model tries to have remember the parameters, and then it tries to predict and everything. So the basic difference between the recognition and detection is, like, let's suppose you have a camera and you switch it on and you try to point towards object. So you might have noticed that a bounding box is created around faces of the people or some other objects if it's known to the device. Like, it would try to localize what's present on the present frame of the computer. So this is known as detection. Like, an algorithm is continuously running at the background, and it's like fetching the current frames from the camera feed, and it's spitting it back to the neural network, and the neural network is producing the bounding boxes around it. So these bounding boxes are like ongoing model, I'd say. Like, it's a single pass neural network where an image is fed in, the model does some computation, model does some recognition, and draws the bounding boxes around this. Whereas in recognition, it's like you already have one of your faces present in your system. Like, you have saved while setting up a face verification, you have already set it up. And the second time when you're trying to unlock your devices, it just takes a glimpse of your face, passes it to the neural network, tries, so both the images will be passed thoroughly once, and a similarity score will be produced. So based on this similarity score, let's suppose the device is set to unlock if the similarity score between the two given faces are, let's suppose, 80%. So if it's an 80% match, the device will unlock. So sometimes you would have noticed that your device gets unlocked from the faces of your siblings or your parents, because even though you have not set it up, it's because we have some similarity matching with our parents and siblings. So this, I'd say, sometimes become like tragic, because once my brother unlocked my phone and I was awestruck because why, how did this happen and everything like that. So this is how the recognition system works. So this is an authentication algorithm, typical authentication algorithm, I'd say. Like, we are authenticating how the devices work, authenticating our phone with this, or our device with this. So let's get deep and let's get further into what we will be talking about, the Siamese network. So I'll give you a little background about what does the term Siamese mean? How did it originate and everything supposedly like that. So the term originally comes from the co-joined twin brothers Chang and Eng Bunker, from who were the first pair to be known internationally. So these brothers were pairs, both of them were joined together from abdomen and pelvis. So these two pairs, the first originally from Thailand, formerly known as Siam, and hence the name Siamese brother came from here. Similarly, in this neural network architecture, which we'll be talking about next, is somewhat same to this. Hence, it also has the name Siamese network. You must have seen Siamese cat. It's also a reference to this network because Siamese cat look much alike with each other. The black face and the white fur and everything related to this. This is Siamese cats are also known for the same. So what are the objectives of the network which we'll be talking about? What would it be doing? What would it be trying to achieve next and during its whole course of runtime? So comparing this with a conventional convolution neural network in which we are trying to do detection, we are trying to do classification, and all those models which we have learned about, which we have seen, like pointing at capturing faces from a camera, and neural network identifies what are the things present in it. So this is known as So how do these convolution neural networks have been working? We have a data set which has data and a label which is fed into the neural network. The neural network tries to learn from the data. Like let's suppose we feed it to the neural network. Neural network gives up one pass, and after one pass, it tries to learn the parameters, the difference, which is getting the score, which is trying to have. Like let's suppose it's a mean absolute error or something like that. The score which we have used for our neural network to improve upon, and then it goes back to the starting of the neural network, starts the iteration again, adjusting its weights, like weights and biases, which the neural network was set upon initially, the random weights which I'm talking about, and then it again improves, again goes back. So it keeps it repeating. In terms of machine learning, we'd say that it keeps on iterating over epochs. So let's suppose if I've set my neural network to train for 30 epochs, and after 30 epochs, it would produce an absolute score, which the accuracy which it has got on the training data as well as the validation data. So based on this, the neural network we can examine how good or bad our neural network is. Moving forward, so rather what it does is like. In contrast, what our Siamese network would be doing is, given a pair of images, it finds out the amount of difference or similarity between those two. It's like I'd say the probability of how much the images are matching together, and it's really a state-of-the-art neural network because running these in no amount of time, as we have seen of our face recognition unlock procedure, it's quite fast. It's lightning fast because as soon as our face is detected, the device unlocks. Boom! It's like magic, complete magic. So we'd say that it's not a typical convolutional neural network, but it does use neural networks. So in this part, what happens is the neural network tries to learn the parameters about how to differentiate between two images rather than how to classify the two images. It is trying to differentiate between the two images. It's like producing a similarity score, then going back and improving again, like what's the mistake I made in recognizing, because let's suppose we have fed a data which says that yes, these two are the faces of people who are same. So it's labeled as one. But let's suppose the neural network in its validation part said that it got the assumption that these are not the matching faces. So it will again try to improve upon it. So in the two network, so I will again move with the architecture of the neural network now. So here's the component which I have been talking about. So this in the neural network, as I mentioned, we pass the two faces, as I mentioned, and these two faces are labeled as if it's the face of a same person or if it's the face of a different person. So these are the two images present here, which would be fed to the neural network first. But it's the general architecture of the neural network. It's when the face unlock is working, and these network 1 and network 2, which is shown here, these are known as sister networks. Like it's because these two are almost similar, as I say, all similar, and so that hence the names sister networks is present. At the end of the network, we have an embedding layer of, let's suppose, 128 neuron embedding layer, and this is producing all the parameters of the weights and everything that the network has learned about. What we do is we calculate the Euclidean distance between the given output of the two networks. So if the output, if the Euclidean distance is very small, then it's the face of these are the face of the two people, similar people. But if the Euclidean distance is large, so it's not the face of similar people. So that's how the neural network is working. And at the end, we have a sigmoid layer, which we say that it's like zeros or ones, like it's just a probability score, or not a something like that. Zero between gives a value between 0 or 1s, as I mentioned earlier. So if it's a probability is matching more, if it's matching, then the score would be more, and then the unlocking would happen, else it won't. So this is the complete part here, like the components of the network which I have mentioned. So let's get into the code here. Like this is the basic general architecture of the code which we use. So the model which I'm trying to create. So the network takes in 64 cross 64 image into the network. And so we need to resize it and everything, because the neural network needs some kinds of consistency with that image it is trying to deal with. The next is there are 3 batches of convolution, pooling, and dropout, as you can see here. And for the implementation part, for this we do need to use the TensorFlow API technique with this, not like the sequential model, but with the functional API, because because it's not as conventional sequential model in which we have one pass things happening. We have 2 models. So we do need to connect these 2 models together. And these 2 models have 2 different inputs and 1 output. So the sequential net layer API won't work here, because these layers are not stacked over one another as we saw in the previous slide. Rather, these two models are at let's suppose running parallelly with each other. So that's how the part would be working. Then the network ends with a 128 node fully connected embedding layer, as I mentioned in the previous slide. So this is where we'd say that the model is saying that yes, these are the things which I have learned here, and now I want you to evaluate if I'm good or if I'm bad. That's it. That's the part where it's working. Mentioning about the Euclidean distance, why do we use this? What the Euclidean distance is. The Euclidean distance is calculated by finding out the square root of the sum of the squares of the difference of both the embeddings. As I mentioned, that there are 2 networks present, so these 2 both have 128 layer embedding present assigned together there. And then we calculate the Euclidean distance. It's the mean square root of the sum of the squares. And let's suppose we calculate the difference again, and if the distance is very less, the sigmoid layer will produce an output of very much closer to 1. And if it's very large, the distance is very large. Let's suppose I'm trying to unlock my face with just another person who does not look at all similar to me. So the Euclidean distance for this scenario would be very large, and the sigmoid score which it will produce would be very much closer to 0, indicating that these 2 faces do not match at all. So this is what's happening in the background of the given model. We have used the Lambda API from TensorFlow for this purpose, and the distance value is adjusted to a range of 0s or 1s. As you can see here in the distance, the code written as distance equals to lambda Euclidean distance feature A and feature B. So we are trying to adjust for the sigmoid layer which I talked about previously. So this and again, for moving to the next part, the model is compiled with a binary cross entropy, with the loss as binary cross entropy, and we have used the optimizer as Adam. So for those who do not know what an optimizer is, this is a mathematical expression which I'd say which is used to adjust the weights and biases on which the neural network is working upon. As I mentioned earlier, in the initial state, the neural network, the weights and biases of the neural network are completely randomized. These are not fixed, because we do not know how the neural network will be learning things, how the things will be behaving inside once the data is fed into it. So moving forward, so this is the Adam is the optimizer which we'll be using. It is used to adjust the weights and biases, and then we are evaluating our model based on its accuracy, how accurate it is. If it's, so let's suppose if the model is doing very good on the training data, then its accuracy will keep on increasing. But let's suppose it's there comes a term known as the overfitting. So in this scenario, what the great part would be that our model is doing very good on training data, but it's doing very poor on validation. It's like, let's suppose I'm achieving an accuracy of 95% on my training data, but I'm just hanging around a value of, let's suppose, 75% accuracy on the validation data. So this, and it does not improve. The score becomes frozen. The score does not change overall, even over the given epochs. So this is known as overfitting in terms of machine learning, where we are doing very good on our training data, but we do not perform well on our validation data. So these models do not work well when put into use, when put into test. It's because it has not learned properly, because it has not tried to differentiate between what's correct and what's not correct, what's wrong, something like that. So yeah, this is all about that. So in the given, so since we're talking about faces, there is a data set known as Olivetti data set for faces. And here I have shown you that how we're trying to train the network with it, how we're trying to feed the network with it. Here you can see that we have a positive pair of faces where both the faces present here are of the same person. Whereas here you can see that it's a negative pair of faces because both the faces are of two different persons. And this is an open data set, and you can use it for your projects and everything. So as I mentioned earlier, our neural network needs to have two faces to differentiate between those. So once we are trying to train our model with this, what we'll be supposedly doing is, once you have a data set, you'll have to create pairs of faces. Like, let's suppose even if you're using fashion MNIST, or anything suppose like that, or MNIST, simple MNIST or something like that, or horses versus humans, something. What we'll be doing in this is we have to, these data sets comes in, let's suppose, in simple directories or something, I'd say that like that. Like we have a directory in which we have images of all horses in case of horses versus human. And in another directory, we have images all about humans. So what we have to do is we have to generate pairs of faces as shown in this figure, that we'll have to produce two images together, and we have to label it for creating our data set. So let's suppose in this scenario, if it's a positive face, then it would be labeled as 1. Whereas if it's a negative face, then it would be labeled as 0. So this is the Olivetti data set. And like, as I mentioned, these are like, once the model is trained, so if you want to have an end-to-end application, like you want to run this algorithm into your device or something, this network is really fast because, as I mentioned, like we have an amazing lightning speed once we try to unlock our devices or something. So what we come to the conclusion here, like when do we use a Siamese network? Because there are several algorithms, there are several things which can do face unlocking and something like that. So, but we still need to have a sure shot about where do we need to use. So let's suppose we have a very small data set. Like let's suppose in the scenario of a office building or something like where we do not have sufficient amount of data to train our neural network for it. And as we all know, to have a much better neural network, very robust neural network, we need to have a very, very huge data set, or I'd say not very huge, but enough amount of data set to let the model learn things, to let the model learn about the embeddings and the weights and biases and everything for which it can classify things, or it can work upon classifying, or it can perform the task which we are trying to make it do. So Siamese network, on the other hand, does not need very much huge data. Let's suppose in an office building, we have only let's suppose we have if an employer comes in and joins the office, we don't for his face verification to work, we do not have to train the model again so that we have his images augmented and everything like that, and then we feed it into the neural network, we train a neural network again, and then we again set it back to the office infrastructure, and then it starts to work. It's quite tedious, or it's, let's suppose, in a long run, it becomes quite impossible for people to do this on and on every time. So what a Siamese network does is it's like for the first time, an administrator comes in and he takes a picture of the face, puts it into the database. That's it. The next time you come into your office, you show your face, and yeah, it's working. It's verifying your face. It's doing the things which is what it is supposed to do. And yeah, this is all about introductory part of the Siamese network. So if you want to learn things about it, you should begin with, like, if you're a complete beginner in machine learning or AI, first learn about what basic typical machine learning is, then learn about if you are into image processing or something, if you want to go into that field. Like, as we know, the AI field is vast and there are things to explore. But if you want to go into images, then it's like you learn about convolutional neural networks and how to build it using, then you choose a deep learning tool. You can use TensorFlow, you can use PyTorch, or you can use, in Azure, we do have like built-in APIs for that, which we can train upon and everything, supposedly. So these are the parts which we should focus upon, then deep dive into it. So if you want to learn more about Siamese network, you should go and, yeah, Google can give us everything. So go through the research papers which have been published for this. So like, as I know that, I say that because reading about the article and reading from the people who have researched about it gives you a better sense of how things are working in the background, rather than just reading out chunks of it. So if you really want to learn about it, go read about the research paper which have been used. So that will be all from my side. Thank you very much. And if you want to connect with me, I'm on Twitter and LinkedIn, and I'm by Rohan Raj, and on Twitter I'm by Rohan Pai. And thank you very much. All right. If you have any questions. Yeah.
Great. I really like and enjoyed your presentation. So I have one question. And what other application will the Siamese network have outside of the facial recognition side?
So basically, Siamese network, I'd say that since it's based on images, like I have learned about images because I'm into convolution, these networks and typical images. So I do not know the other applications of it. So it's like I'm not pointing out if it cannot be used somewhere else, but yet like in office buildings or somewhere else, you can, these Siamese networks, like let's suppose we have the Instagram filters or the Snapchat filters for the show. You click your image and you have some things around like the doggy filter or something like that. So these are the best applications of it, because you have your face on one side and we have another algorithm running parallelly, which will be drawing things around your faces and bring out filters and everything like that. So Siamese filters is the best application which can be used at that part. Yes.
God, that's good. That's good. That's good. So thank you so much also for giving an introduction about how other students can learn and start using this Siamese network. And I think we can start giving the introduction to our next speakers. So yeah.
Thank you. Thank you very much. Bye-bye. Have a good day.
Bye. So hello, Rasha and Rishit and Rohan. Are you there?
Yes, I'm here.
Hi, hello.
Hello.
How are you? Are you ready for your presentation?
Surely.
Excited? That's good. So what are you gonna talk about today in this presentation?
Sure. So hi, and today we'll be talking about our project. We'll be showcasing our project, which is called Plant AI. And we have been working on this project for quite some while, and we have been using Azure and Azure Machine Learning, a lot of Azure Web Apps, a lot of cool stuff from Azure. So we are quite honored to have a chance to participate in the project showcase and show our project. So first off, if you want to know a bit about us, hi, I'm Rishit. and I worked on a lot of the machine learning aspect of this project. I'm also a high school student, and you might have seen me earlier today in one of those talks, one of those panel discussions, if you were there that time.
Hey, Rishit, before you go any further, I think there might be something covering the first half of your screen, like the main part of your screen.
Better now?
Yeah.
Yes, looks awesome. Thank you.
Thanks for bringing that up. Rucha, would you like to go on?
Sure. So, hello everyone. I'm Rucha Yagnik. I'm a Gold Student Ambassador. I'm a graduate student at University of Southern California. For this project, I basically worked as a React developer, and that's my contribution to this project. I had an awesome team to work with, so I'd have Rishabh go on next.
Thanks, Rucha. All right, so I am the UI UX designer of our project, right from the starting, how it is going to work, from how it is going to look. I managed all of it, and it was great working with Rishit and Rucha. And this is just the beginning. We have lots of things planned ahead, so I'm pretty excited about that.
So next up, probably Rishabh could go on and start talking about the project.
Sure, perfect. All right, so let's first get into the motivation and why we decided to create Plant AI in the first place. So it was a really normal day on the internet, and we were just browsing through our socials when we came across a really disturbing headline. And the headline, which was printed on the India's biggest newspaper, which was Times of India, and it said that a farmer killed his 2 kids and wife because of death. So, and that was a huge shock for all of us reading that headline, because it's not something really old. It just happened earlier this year, which was really, really shocking for all of us. So to actually see what's happening behind the scenes, actually see what's going on, we decided to do some research. And we realized that it's not just our country. There are a lot of countries which have been going through this problem, and a lot of crops are being destroyed. But what was the issue? Why it was actually happening? We found out that it was nothing but the diseases which are affecting the crops and hence causing the issues which we can see in the graph right now. Coming to the next thing, as we are passion-driven individuals who love to solve problems, it was a great opportunity for us to come together, to form a team, and to create something which can actually help people solve this problem. But now, since we talked about the motivation behind and a little bit a background story of everything that happened before, let's talk about what's the actual problem and summarize it in a few points. So coming to that, so the first problem was the diseases and deficiencies. As we all know, it's not easy to find out. If you had plants before, so you know what I'm talking about. You can't just look at the plant and you can't just find out what's causing the issues.
Sorry for that. I think I stumbled upon something and missed a couple of slides over there. Sorry for that. Please go on, Rishabh. I'll read your slide. Yeah, please go on.
Sure. Okay. Digging a little more into the problem, we found out that in just India, around 67% crops, that is more than the half, are getting destroyed every single year. And when you think about the bigger picture, It's like 2 in 5 crop yields around the world are usually affected and get destroyed, and they never come to your plate. So, and that's not reasonable. If you think about it, it's actually a massive scale, and it's happening right now. The problem was actually huge. So, but the solution was very much possible. We just wanted to help people to find out why it is happening and what they can do about it right away. So one thing we realized that mostly all the farmers around the world have access to smartphones with some internet connectivity, which was a breaking point for all of us. And we decided to bring our product in a form that can be used for everyone, and that was the web. So coming to what we actually did. So we basically created a AI model which is capable of diagnosing diseases from plant images early. So you just have to point your camera into it, and it will tell you what are the things which are wrong with the plant, and there you go. Coming up, we are not, and that's not all. We also provide actionable ways to solve the diseases. So you don't have to visit a laboratory, you don't have to call an expert to find out what's wrong with the plant and how you can treat it. You can do that right from the app. Next up, and since not every cure can fit a single plant, we provide various alternative ways also to find out what works best for your plant and how you can treat it right from the app. Coming to the next, but the most important point was that a lot of people, especially in India, don't have access to a stable internet connection, which was really something we needed to focus on, because what's the use if the app is not working on your field? So we also worked on bringing offline support and PWA support to the app, which will definitely help us people get the job done, no matter where they are, no matter about the internet connection. So coming forward, this is a screenshot of our app, and this is basically how you have to select and how this works. So Rishit will be coming over and giving you a short demo of how the entire app works.
Sure. So let me reshare my screen, and this time I'll show around a live demo of our app, and I'll try to show how well our app can work in action. So we just talked about how we thought of building the app. So I think a nice thing to top this off would be to probably show our app live in action. So while we keep this up, so by the way, you might think this is a website, and well, it's a PWA, so it works offline as well. And we'll soon talk about the parts, how we make it accessible to people with low internet connection, or how we make it accessible to, since most of the crop growers do not have super advanced smartphones. We'll soon talk about that. But what I wanted to do is, in our research, we also wanted to support a large number of plant species. So we ended up supporting 38 different plant species and diseases. So I want to show you a live demo of one of them. So I'll just take a very common disease, which is called apple seed or rust. So this is a really common disease, which, as you might have guessed, happens in apples. So I'll just go on to Google Images, try taking an image of this, just an image from Google Images, and see if our app can work well with this. So yeah, that's what my goal is. So yeah, this is also the website. It works on desktop as well, though most of what we showed you was about how well it works on mobile devices. So let me try putting this in. The image we just got from Google Images. I just searched up cedar apple rust, and this was a real life plant image. what we just took from Google Images. And it turns out that our model was able to, in just a couple of seconds, and all of this was offline. All of the machine learning ran on the device. So our model was able to tell me correctly that what kind of disease this is. It was a cedar apple rust, right? As you were talking about. It also correctly identifies the species, apple. So this is super helpful because while we were researching, we also found out that there might be a same disease. So I'll give you an example that came up extensively during our research. The disease was called scab. So the scab disease can happen in apples as well as in grapes. But well, how do you solve that? Which is what we also wanted to do, right? We also wanted to provide actionable ways to solve it. So what we ended up doing is seeing this example of apple scab and grape scab. Both of them are the exact same diseases, but solving them requires altogether different strategies. So our AI model also ends up predicting or trying to predict the species. So our problem would be better termed as hierarchical image classification, if you are interested in machine learning. So that is what we do over here. We first try to predict the species as well. So with the species in hand, we can give far better prognosis of how to solve the disease. That was also one of the things which we really wanted to do. Gives not only actionable ways to solve it, but specific ways to solve it, because solving the same disease in different species often requires completely different strategies. So that is something we are also really proud of, not just disease and not just identifying diseases. And since we are already beta testing our application, we not only have this nice interface which crop growers can start using, but we also have APIs for the machine learning model, for the chunky machine learning model we built, so others can use it as well. And in our beta testing, we also figured out that this would approximately decrease plant losses by as low as 25% in our community, India. So from 60, we could easily go from 67% plant losses in India to 25% plant losses in India, which I think is a really sizable gain. We also wanted to talk about existing solutions and how our AI model or how our project as a whole is different from them. And one existing solution I think a lot of you might be familiar with was called CropNet. There's a really cool research paper about this as well. And this was deployed by Google, a really nice project. And this does wonders, but well, this only works on cassava plants. So cassava is a really dominant species in Africa, a really dominant species of plant grown in Africa. But well, this just works for cassava plant. And we wanted to support a lot more species, a lot more diseases than just supporting cassava plant. So we end up supporting over 38 diseases and species with our project. Another existing solution was Plant Village by Hughes et al. In their research paper. And well, these were over 70,000 images of diseased plants and normal plants as well. But this was just a data set. You couldn't go on and make inferences from this. This was just a data set of images. Another two existing works which I'd like to draw your interest towards were a plant disease detector by Ramesh et al. And some other disease detectors of which you'll find multiple research studies on. And we found out that most of them end up giving us unsatisfactory performance to work in real life or on the ground, or some, if do give satisfactory performance, are not optimized or usable on small devices, which is a really huge thing we wanted to do, since a lot of crop growers might want to use this on small devices with limited network connectivity or do all of the machine learning on device. So none of the existing research studies were optimized for this. And this is how well our project is different from the existing ones as well. I'll go on and talk a bit about how we built this project. So I'll start off by talking about how we built our machine learning model. And as it always has been, we started by collecting data, which is very much required for any kind of machine learning algorithm. So we ended up training this on more than 100,000 images of real life plant images. Multiple of them were from online databases or from current online data sets, or some of them even taken on the ground itself. So all of these were so here I just show images of a couple of iconic images. So while collecting images for machine learning, usually we split images as two kinds, right? Iconic images and non-iconic images. So the ones I show on the screen are just iconic images, a large chunk of the data set we trained our images on, but quite a few images were also non-iconic images, which we trained our model on. So we started by collecting data and had over 100,000 images to train our machine learning model on. We'll also soon talk about how we keep improving our machine learning model, which I think is really important, since new diseases might come up in the market, or probably new symptoms for an existing disease might come up. So it's very important to update this machine learning model or retrain this machine learning model in some way. We'll also soon talk about that. But this is how we started. We then started experimenting with multiple architectures and hyperparameters. This was primarily done with TensorFlow, and we heavily made use of Azure on the way. We made use of Azure ML to manage and monitor our project, monitor searching for multiple hyperparameters or searching for multiple architectures. Azure ML was really in handy, which is what we used for building the model, TensorFlow on Azure ML. Then we ended up with a modified version of MobileNet, which was specifically designed for our cause. I'll not go into the details of how and why we modified MobileNet, but our main goal was to a couple of our main goals, to rephrase what I'm just saying. A couple of our main goals were to not just obtain good performance from the model, but it was also that the model should be easily compressible to run on a small mobile device, which does not have a lot of compute, because all of this model has to run on the mobile device itself, not on some server through an API call, because as it turns out, a lot of farmers don't have the best network connectivity. So we wanted to not only get good performance, but run all of the model on the mobile device itself. So likewise, according to our data and scenarios, we ended up creating our own architecture, a modified version of MobileNet. Then we also optimized the model to run on device. So as we were talking about, our project is essentially a PWA, a progressive web app. You can also use it offline. And the machine learning model would be running on device. No network calls needed, and any of that jazz. So all of the model was also optimized, and we did multiple kinds of optimizations, like folding multiple layers or fusing multiple layers. And we primarily made use of Grappler, which is a great tool to help us do some pretty standard optimization procedures for very large models. But we also ended up creating some of our own optimization procedures to allow the model to run on device. And finally, what I'm also proud about was at the end, this model was optimized to just be 12 MBs in size, which I think is quite small. and wait till you see how long this model takes to do a single prediction in a mobile device. So yeah, that is super small. And the model at the end was optimized to be just 12 MBs. And we'll soon show you how well this model works, especially for small mobile devices with limited network access. And because and on the web part, what we do is we also load this model through multiple network calls, not through a single network call, and through which we end up pretty much caching all of the model for next calls. So you can see all of the models are cached. This is just a screenshot of the background processes happening to show you how it works around. And this is how fast the model was able to make a single prediction on a low-end mobile device. If you see, this is not even 100 milliseconds, which is how fast the model was able to make predictions. We also wanted to make sure the model is able to not only run on device on a small mobile phone, but it's also able to make fast predictions, which, as it turns out, is a really important factor if crop growers are supposed to use this on a daily basis. We want crop growers to use this on a daily basis. So we also had to make sure that our model could inference very fast, could load very fast. And with the optimizations, you can see a screenshot. It barely takes 100 milliseconds to run a single inference, which I think is pretty good. Then we also worked on building the web app. And Rucha, would you like to tell us all about how you built the web app?
Sure. So the entire application that you saw in the demonstration is built around React.js, which is one of the very widely used JavaScript framework these days. And the deployment basically is all done on Azure. So I'll quickly talk about what all our app includes. So as you have already known, our app is a PWA, which is PWA basically gives you all the benefits of a website in an app, just more faster and more reliable, also sometimes more engaging version of your website. Also, the TFJS model that you learned about very recently from Rishit is very optimized. And how we do that is just the way that we individually fetch data flow, graphs and weights, and we normalize the images up to a certain extent, just because our model is trained over 87,000 images plus some augmented images, which is huge. So we need to normalize the images and resize with the nearest neighbor interpolation. Now these all together help us to make the model very optimized, quick, and energy efficient. So now the deployment, as I said, is done on Azure. So we're very excited to run our model on the client side, since the ability to run deep networks on personal mobile devices improves the user experience. Hosting the web app we built was quite easy for us using Azure Static Web Apps. This allowed us to set up a CI/CD pipeline very easily, and staging slots with GitHub Actions was again the very smooth part for it. So with Azure Static Web Apps, the static assets were separated from a traditional web server, and instead of being served from geographically distributed points around the world, the distribution actually, which Azure Static Web Apps provides, made the entire thing very fast, and it was actually made easier and energy efficient, as I said. So that is how we deployed our app. Now let's quickly talk a little bit more about what are the business plans, how interesting that is. Because since we are already in the beta testing phase, business plans is something that we really care about. So farmers, as we say, don't get charged at all through our app. So, well, how does it work then? Interesting. So because we also provide a pane where crop growers can see potential ways to solve the disease, we would allow plant product companies to place ads, which would pretty much mean that direct source of marketing could be done for them through our apps. The next thing could be, the data which we collect or our app generates could be shared with some companies, such as the field sizes, the crop grown in some areas, the materials used for curing some of the diseases or something like that could be shared with some product companies, and which could be used by them as well as it could be used by us to solve many problems in farming domain, such as what percentage of fields diseases were have been occurred or have been investigated or something like that, and so on. So this is how we generate our revenue, and that's what the business plan for this app currently looks like. So Rishad, would you like to talk about the impact that our app has had so far?
Sure. So finally, we also, because we want to detect plant diseases, and as I said earlier, it's really important to improve the machine learning model. So we also use plant images anonymously in real time to improve the machine learning algorithm. In part, we do this by a pseudo-federated learning algorithm and try to improve our machine learning model. And finally, that's all about our presentation. And this project was also featured on Microsoft blog and Microsoft's YouTube channel. So feel free to take a look at any of those if you want to know a bit more about what our project does or how we built it, and all about the Microsoft Learn Student Ambassador program and this project, feel free to take a look at the Microsoft blog and YouTube. I'll put a link to this presentation on chat. And with that, that was all about the presentation and all about our project showcase. Thanks.
Yes, thank you so much. Oh my goodness, your project was so exciting. I was literally navigating to the blog and the YouTube during your conference, like during the talk. So I was so impressed. I absolutely love the business plan at the end and the impact. Congratulations. We have one question for you, and that is, so of course, yeah, during your talk, I navigated to your GitHub page for your project and saw that you're looking for contributors or open to contributors. And so in what ways can our audience right now contribute to your project or just help grow their skills in this space?
I would love to take this up, and probably Rishabh and Richa could add something. So at the moment, I think we would really be working on trying to make the website more inclusive to everyone. Our website currently is only in English, and well, if you're addressing the Indian community for which this was originally built, India has over 30 languages, and making the website more inclusive, more accessible to everyone is our major goal. So we are definitely looking for contributors to help us with more of this stuff.
Awesome.
That is amazing. A call to action to our audience. Oh my goodness. I wish I knew another language because I would contribute. Awesome. Well, thank you so much for hopping onto the Global AI Student Conference today. We appreciate you. It was an amazing talk. I'm so excited to follow the project. And so now we have our next speakers. So I'm going to be introducing Shreyan and Meghana next. And so they are both Microsoft Learn Student Ambassadors. Woot woot. And so they're going to give us an introduction to the Azure Health Bot. And with that, I'll let you take the stage.
Just before, I just want to say something to everybody that's attending. Remember to complete the Cloud Skill Challenge. Just a reminder for everybody. And then you can go ahead. I'm sorry for interrupt you.
Thank you, Loxley. I'll just share my screen quickly. Is my screen visible?
Yes, we can see it. I think it'll be going live very soon. Yes, awesome. I can see it.
Okay, so greetings to everyone. My name is Shreyan, and today we'll be looking into what is Azure Health Bot, how to work with it, and we'll build some. There'll be some hands-on exercises right during this whole session. Without wasting much time, let me introduce myself. My name is Shreyan J.D. Fernandez, currently a Beta Microsoft Learn Student Ambassador. I have worked in a startup before. I'm a hackathon enthusiast and I've participated in around 15 to 16 hackathons so far. I'm an open source contributor as well. I'm MTA certified in Python and I'm a part-time blogger. My areas of interest lie in artificial intelligence, blockchain, DevOps, web dev, augmented reality, cloud computing, IoT, and robotics. And these are the links to my social handles. With this, I would also like to introduce my co-speaker for today. Meghana, would you like to go ahead?
Yeah, sure. So my name is Yashwini Sai Meghana Chikkam. I am currently a Beta Microsoft Student Learn Ambassador, and I have I have a lot of passion in technology, and so I have developed my skills in the same. And I have always been wondering how technology and healthcare together can help us solve problems. So I have also taken part in many hackathons, and I have also worked in a mixture of healthcare and technology. And coming forward, I have also taken part as an intern in 2 of the startups in the roles of Python developer and fundamental programmer. And my areas of interest lie in healthcare development, web development, cloud computing, and blockchain. Yeah, that's about me. I guess Shreyan will carry on.
Thank you, Meghana. So without wasting much time, let's deep dive into what is Azure Health Bot. It's just an introductory session. So basically, bots are nothing but that comes under the conversational AI, as we all know. And Azure has a pretty good bot frameworks that are up for you in cognitive services. There is a really huge services that they give us. So today we'll be focusing on one of such service called the Azure Health Bot from the healthcare domain. So Azure Health Bot service is nothing but it's like any other bot service that is there, but it's specifically designed for your healthcare organizations to build and deploy compliant virtual health assistants and health bots. So this is actually a service that combines built-in medical intelligence with natural language capabilities and more. As we all know, bots are having some mixture of natural language in them. So this is also nothing different here. So this allows the healthcare organizations to give people access to trusted and relevant healthcare services and information. So now, whenever there's a service, we need to design something of our own. Let's say our use case is something different, and not everything can come default built in with the particular service. So to enable this, organizations or the institutions that are looking ahead, looking forward to inculcate the Azure Health Bot need to build their own scenarios. But definitely there are a few starter scenarios for us, which I'll be showing in a while. So there are some default scenarios for CDC and some regular checkups and stuff like that. And if you are okay with them, then you can use that. But let's say you want to give some more personal touch to that, and definitely there's a scope that Azure Health Bot provides you, and that is called the custom scenario. You can integrate this particular platform with other Azure services like your database, you can build an APIs, you can build your own API and connect it to your website, or you can also go ahead and build your own Teams application as well. The best part of this is that there are particular channels where you can channel your bot to the widely used messaging platforms like WhatsApp, Telegram, so on and so forth. So overall, this is a great service that you can use to reduce your workload and also give a better service to your healthcare sector. So to get started with the Azure Health Bot scenario, you have several built-in scenarios, as I was just saying, and you can either look through them, or there is a Learn path which is available on the Microsoft Learn platform. You can also design your custom scenarios in the Health Bot service that can fit your organization needs. So now, without wasting much time, let's dive deep into creating a basic scenario and also how to provision your first health bot. So let me just go to my desktop. Okay, so this will take some time. If I just sit and deploy one right now in front of you, it will take some time, and it's not feasible to do it in a live session of 30 minutes. So what I've done is I've recorded the videos, and I'll just narrate you through all these. So firstly, we'll have to go to portal.azure.com, log into your particular Microsoft account with your Microsoft ID. if you have your student ID, you can log in with that as well. Now you can go ahead and click on create a new resource, and you can just type for Azure Health Bot, and this is your particular resource. And here you have to give a new resource group. Here, let me just type AI conference, and I'll just give a name like, let's say, HealthBot conference. And the region can be set to default, or you can change it as you want. And finally, I'll just click on create once the validation is passed. So I'm choosing the F0 tier. There's a paid tier as well, but if you want to follow along with this, just feel free to choose the F0 path here. So once your deployment is complete, you can go to this resource from this button here, and in the overview, you can see the management portal. This is the portal where we'll be working the whole custom scenario that I was just talking about. And again, it'll ask you to log in with your same Microsoft ID that you use. And here you can see the template scenario, the custom scenario, and the configured built-in capabilities. And this is your portal. Basically, this is where you'll be working with once you're done creating a resource on the portal. So on my left-hand side, you can see the menu that is scenarios, language, configuration, integration, analytics, users, and resources. Today, for this particular thing, I'll be using the scenarios, and in that, the manage section. And that is where you can find this particular thing that you can see on the screen. You can either select a template scenario, you can either create a new scenario, or the other thing. So now I'll go ahead and create a new scenario. We'll be basically building a paramedic bot, which will take in the vitals and other information from the user. So in this new scenario, I'll give a name like, let's say, paramedic bot, and give a suitable description. The scenario ID is unique. So this is something that will refer to your scenario once it's created. Once that is done, click on create, and now it will take some time to provision new one. And here you go. After validation is successful, this is the canvas that you can see once it is done. The best part of this is there is no piece of coding involved. It's all just a single drag and drop interface that you can see. The first block that I'll be dragging here is these are basically called the scenario steps, and this is the first scenario step that I'll be using. It's called the prompt scenario step. So here I'll just rename it to greetings, because I want to greet the user. So hello, how can I help you is the first thing that this bot asks you, and give it a variable name. And the variable data type here will be a choice. And in this, I'll just give, let's say, 3 departments here: services, departments, and more info. And maximum number of retries will be 2. Now, once that is done, the next block I'll be dragging here is a branch. Branch basically splits it. So this is the way we call it, scenario.greeting.index. So scenario dot is something that you invoke the scenario here. And this has 2 divisions here. One is the yes division, the other one is the no division. So in the yes division, the first place I'll give it to a services thing. So entering into services. And let's say we offer emergency and trauma as one of the service, ICU and CCU. And let's say next will be the pharmacy and microbiology and research wing, and then let's say OPD. And with that, I'll just give it OK. And now I'll just connect it here. Services. Now this is a switch. Next thing is a switch scenario step. This is basically to switch between all those 5 arrays. In that array, I had given 5 different entities. In order to switch between all those entities, I'm doing this. So let me just quickly give up everything here. And here, in order to include anything, I'm just giving this dollar symbol on the top, dollar, and in the bracket, it means services. That is basically referring to the variable that I had given. If you remember, a while ago, I had given services as my variable name. So with that, I have given include my variables dot entity, and also the switch case statements. This is basically very similar to the switch case that we have in, like say, C programming language. We have the switch case statement, and at the end there will be a default as well. So let me just rename this as services, and I'm connecting it here. So we can see the 4 switch cases below and 1 on the right side. The 1 on the right side stands for the default. Let me just quickly fill in these with the statement blocks. Statement blocks are basically just to show something to the user, and prompt block is something that receives input from the user. So if I compare this thing to my programming analogy, so that will be print statement for the statement block. And with that, I have completed my services switch. Now let me go to the other branch. We had other things, if you remember, departments and more info. So if it is a no, then there are 2 more choices left here. That is scenario, the department and the more info. Let me just quickly fill in for the departments. So in order to do this, I'm just giving some random department names here: cardiology, let's say dentist, and let's say neurology. And with that, I'm just giving to this. Now again, the switch case, as I did before, I'm dragging in a switch case scenario step here. And again, that dollar department stand for dollar and the variable name, whatever you give for. If you just have noticed in the previous step, I gave department names in the prompt block as my variable. So after doing this, the default case, I'm just giving all the statements here, the cardiology experts and whatever it is, whatever you want to display to your user or however you want to display to your user, I'm just giving it here. And if it is no in both the places, then definitely the third option is the right thing. And that's why I've given more info there. Now, while I'm testing, hello, how can I help you, entering into services? And this is how your basic bot is constructed. Now, as we had just seen, there are a couple of other steps as well. That is your interrupting and breaking scenario, which my colleague Meghana will guide you through. Over to you, Meghana.
Thank you, Shreyan. So now we will learn on how to build interrupting and breaking scenarios. So first, we will see what is an interrupting and what is a breaking scenario. Next slide, please. Yes, so what is an interrupting scenario? Interrupting scenario, like the name suggests, it is a scenario that interrupts the main scenario, and it will return back to the main scenario after the whole scenario is completed. So here we can see a small picture where the top level scenario is the main scenario, and from which the interrupting bot interrupts the main scenario and goes to the scenario 1, and that is called as a child scenario. And from scenario 1, we can again interrupt scenario 1 and go to scenario 2. And after scenario 2 is completed, it will return back to scenario 1. And then after scenario 1 is completed, it will return back to top level scenario. So that's what an interrupting bot does. An interrupting scenario interrupts the bot and interrupts the main bot and returns back once the scenario is completed. What's the difference between interrupting and breaking scenario? I'll let you know. So breaking scenarios does something very similar. It goes to the next scenario to interrupt the main bot and completes the other scenario, but it does not return back to the main scenario. That is what is the main difference between interrupting and breaking scenario. While interrupting scenario returns back to the main scenario, breaking scenario does not return back to the main scenario. So I'll show you a small demo on how to make interrupting and breaking scenarios. So let me just share my screen. Just give me a minute. Shreyan, could you please share the video?
Okay,
sure. Yeah. It's giving me a trouble.
Give me a minute, actually.
Yeah.
Yeah, it's like.
Yeah. So I have recorded a video just like Shreyan did so that I will not waste any time here. So let's start with the video quickly. So since Shreyan has finished building the basic bot, we will have to create 2 more bots, one for the interrupting scenario and one for the breaking scenario. So first, starting with interrupting scenario, once we click on the new button on the left-hand side, we will be able to build the interrupting scenario. So we have to give the name, description, scenario ID, returning message, and we have to enable the interrupting scenario. for it to work as an interrupting scenario. And for the name, I have given it as intermediate bot 1. And for the description, anything suitable. And in this particular scenario, we will be collecting vitals from the patients. And so I have given the description as so. And the scenario ID will be vitals. And this particular scenario ID will be used later for triggering this particular scenario. And the returning message can be anything that needs to be shown to the users when the interrupting scenario is running back to the main scenario. And here I'll be enabling only the interrupting scenario and not the breaking scenario. And then we can click on create. So once we click on create, we will be able to see the same workspace which we saw when Shreyan was building a basic bot. And here I'll be dragging out a statement box first to give a welcoming message for the users. So here I'll tell them, hello, welcome to the general checkup. And this particular interrupting scenario is only for taking the vitals from the patients. So I'll be taking in input from the patients, and that can be taken using the step called prompt. So here I'll be taking in their name, and name is a string. So I'm giving the variable name as string, and the variable name as name, and the data type as string. And here I can also change the name of the box so that we know what the prompt box is being used for. So next I'm asking them their age. Similarly, I'll be taking in their height and weight as well. So for age, since age will be a number, it is the data type will be a number. And next comes the height. And here I'm asking them to mention their height in the box, and I'll be giving the variable name as height. And since height is measured in number, I'll be giving the data type as height as number for the height. And same for the weight as well. Once I name the prompt box as weight, I'll be asking them to mention their weight in kgs. The display text is something that's going to be displayed for the users when they will be using this particular bot. And we will give the data type as number again. And once all of this is connected, we will simply thank them for giving their vitals. So for that, it's simply a display message. So I will not be using a prompt box. Instead, I'll be using a statement box. And here I'll be telling them that thank you for providing your vitals. And I'll ask them to continue with their process of booking an appointment with the basic bot, because this is an interrupting scenario. It will return back to the main scenario and continue with the appointment procedure. So once I've typed in the message, I'll just click on OK. So what this bot does is it welcomes the users and takes in their vitals, name, age, height, and weight, and then thanks them for the vitals. So once this bot is ready, we'll have to click on the save button and then click on exit. With that, we can see this intermediate bot 1 ready in the portal. Yes, so intermediate bot 1 is ready. Now we'll have to build a breaking scenario. So let's click on new, just like we did for the interrupting scenario, and give the name as intermediate bot 2. Here, the name breaking scenario will just collect temperature, will check the temperature of the user and return a dummy value. So here I'm giving the description as temperature checking, and the scenario ID will be unique. So I'll give it as temperature, which will be later used for triggering this particular breaking scenario. And for the returning message, I'm asking them to start with the procedure again because this is a breaking scenario. And for breaking scenario, we'll have to enable both interrupting and breaking scenario for it to work. And then click on create. We'll again come back to the workspace where we can work on. And here we will have to start with a statement box, asking them if they want to check their temperature. And just to make it look real, I'll be adding a small wait time for this. So here I'm adding a 3000 milliseconds wait time, which is 3 seconds. And after the wait time, I will be giving out a dummy value to the users, because as of now, we're not connected with any data type for us to actually check, database to actually check with the temperature. So we're giving out a dummy value. The temperature is XYZ. I'm just giving it out in a statement box. And after that, I'll be asking the students, these users, if they have anything else to check with, that is any other vitals to check with. And if they say no, I will be asking them to continue with the appointment procedure, but it will not go back to the main scenario, which means they will have to start with the procedure all over again. So that's what I'm going to be typing up in the statement box over here if they click on no. And if they click on yes, then that means they want to check with another vital. So I'll be giving them that option. So I'm giving them the option of selecting which vital they want to check. So I'm going to take in a prompt box because I want to take in an input from the user. So In the vital, I will select the data type as choice because I want to give them a choice of multiple options that they want to choose from. So any vital that they would like to check could be height, weight, and symptoms, I suppose. So this is how you would mention choices. And once we connect this, we would again give out a dummy value just for now. And I'm connecting a statement box, so I can give them a dummy value of whichever vital they chose to see. So here I'm giving XYZ that dummy value for this. And once that is connected, our breaking scenario bot is ready, and we will connect the last statement box back to the yes or no option box so that they'll continue to check whether they want anything else. And once I'm done, I'll click on save and we can exit. So now you will see both all the three basic bot scenario, interrupting scenario, and the breaking scenario ready. And for us to connect with the breaking scenario, the interrupting scenario will have to have a option for the users to connect to the breaking scenario. The breaking scenario ID must be triggered from the interrupting scenario. So from here, we will ask them if they have checked their temperature after all the vitals have been collected. And if they haven't checked the temperature, we will ask them to check the temperature by entering the word temperature, which was the scenario ID in our breaking scenario. So I have created a yes or no box. I have asked them if they have checked their temperature. For the people who haven't, I will ask them to simply check their temperature and get back with the appointment procedure. And for that, they'll have to enter the keyword, the scenario ID, temperature. So as of now, I'm giving a statement box. And after which, I will take a prompt box because it will take the input of the word temperature. So here I'm asking them to enter temperature as your input. And once the users enter the word temperature, the breaking scenario is going to get triggered and it will start working in the middle of this scenario. And then if they have already checked their temperature, then we would just ask them to enter the temperature. And since we're going to take the input of the temperature, I'm going to be using a prompt box here. So I'm asking them to enter the temperature in Fahrenheit, and variable type will be number. And after this, we will just connect the thank you box to the input box, the prompt box. So I'm also giving them an option of entering any common symptoms that they are facing, because this is going to be an entire appointment procedure. So I'm again giving options, choices. So cold, cough, fever, headache, and body pains. So that's how you enter choices. Please note the syntax. And after this, we could connect the last prompt box to the thank you message to finish the interrupting scenario. So I would just quickly save this scenario and exit it. So now we have both the scenarios ready, but we need to connect the main scenario. Before that, we have to create two models in order for them to work like we want them to. So for creating models, click on new. We have to give the name. So first being, we'll be using the interrupting scenario for making vitals, for collecting vitals. So the scenario ID was vital, so we'll give the name as vitals. And select the method as regex, which is regular expressions. And this is the syntax for the regular expressions. And select intent mapping as vitals and drop down menu also as vitals. And then we'll be creating another model, one as temperature, because that was the scenario ID for breaking scenario. And give the description as temperature collection or temperature simply. And select the method again as regex, which is regular expression. And just the word temperature is going to change. Everything else remains the same in the syntax. And intent mapping again will be temperature. And from the drop-down menu also, we'll have to click temperature since that is a scenario ID. And click on create. So we have two more new models ready. So once we have the models ready, the only thing left is that we have to connect the interrupting scenario to the main scenario for it to work, for the whole flow to work. So in the main scenario, we will just ask the users to enter the word vitals to get their vitals checked. And for that, we will have to give an input box because we have to take the user's input as the word vitals for it to go to the interrupting scenario. So I have just entered a simple prompt box asking them to enter the word vital in two places because those are two possible places where the users would reach in the flow. So I'm naming it as vitals and asking them to enter the word vitals because that is the keyword, the scenario ID of the interrupting scenario. So once that is ready, we could just click on save and let's run it to check if it's working. So here I'm clicking on services. And when I click on services, it should reach the input box, the prompt box, which I just built, which says we have to enter the word vitals if we haven't given our vitals yet. So since we haven't, I'll just click enter the word vitals, which is the keyword to trigger the interrupting scenario. So here you can see that the bot has reached the interrupting scenario and welcomes us to the general checkup. It's asking for my name. So let me just enter my vitals quickly. My name is Meghna. My age is 23. So once I have entered my vitals here, it will ask me if I have taken my temperature, like we have edited in this interrupting scenario. So since it's asking me for my temperature, to check if the breaking scenario is working, I'll just click on no. So yeah. So once I click on no, you can see that the breaking scenario is triggered and we have reached the breaking scenario and it's asking us to enter the word temperature. So by entering the word temperature, the breaking scenario must get triggered and we have to reach the breaking scenario. So let me just enter the word temperature. So here you can see that it's asking us if we have checked the temperature, and after which there's a 3000 milliseconds wait time. So it's giving us the dummy value and it's asking us if there's anything else that we have to check with. I've entered no, and you can see that the breaking scenario hasn't returned back to the main scenario. And that is what a breaking scenario does, right? So that's how interrupting and breaking scenario works, and that's how you can build it. So now I would like to hand back to Shreyan for explaining you on how to channelize a bot to Teams.
Thank you, Meghna. So now we'll learn how to the bot real quick. That's the next part, because once the bot is ready, you can't really keep testing it on the web chat before that we were doing it there, right? You want to get it out there, you want to share it with a user or do something like that. So let's quickly see how to do it. Again, there's no piece of coding involved here. And I'll just show you how to do that. Give me a second. Okay. So to channelize the bot, we'll have to first again go to scenario management portal that I had just showed you a while ago. And in this, the first place I'll be going now is the integration. And in here, there are a couple of channels that you can integrate it to, as I just mentioned in the beginning of this tutorial. That is the Microsoft Teams, Twilio, Facebook, Telegram, Alexa, and the WhatsApp. So I'll be quickly showing you how to do it with the Microsoft Teams channel. When you click on that, you'll get this bot ID. Copy this bot ID to your clipboard. Head back to your Microsoft Teams channel, I mean the Microsoft Teams app, and in the search section, just paste this ID that you just copied, and you can there see the healthcare. Now I'll just go and let's say hey or hello, just give it an intent. So I'll just give it hello. And here you can see, so hi, how can I help? But this is, if you remember, this is not the scenario that I wanted this bot to trigger. So this is something that is different. So probably it must have this hello intent is mapped to a different scenario. So let me just quickly change it to my scenario. I'll go to language, and under this there is models. In this greetings, it says hello. So I'll just quickly edit this. Yes, you can see in this greeting, it says built-in /greeting. So I'll change it to my particular scenario name, that is the bot1. If you remember in the beginning when I was creating, I gave it bot1. So I'll click on save and then go back to my Microsoft Teams channel. And now let's see, I'll type hello. So now it should probably give me the right one, the scenario. Yes. And here you go. Hello, how can I help you? Services, departments, and more info. So this is how you can connect your bot to various channels. Now I have shown you one with the Teams, and you can go ahead and create it with different channels as well, like Telegram, WhatsApp, and that would be more omni-channel, right? You can get in touch with your patients or with your customers very easily here. So healthcare organizations around the world are using currently the Azure Health Bot service to improve patient outcomes and reduce the cost. Definitely cost is a factor that every organization looks into, and Azure Health Bots is somewhere giving you an opportunity.
Thank you so much,
Partners
Shreyan.
have built health bots that help patients check symptoms, find appropriate care, and look up nearby doctors.
We've reached the end of our time, but this is such a fascinating
space. Like even as you were talking, I think you are, but we've reached the end of our time frame. So
hello.
Yes,
Yeah.
but I think we have to cut it there, unfortunately, which is so sad because this is such a fascinating space. As I was in the back end, I remember reading an article, like literally, I read it on the news that Microsoft has been using their healthcare bot to partner with the CDC to help detect COVID-19 symptoms. So it is so impressive to see the Azure Health Bot, Microsoft Healthcare Bot being used in the real world, like quite literally saving lives. Like what an impressive impact that AI is happening on the entire world. Thank you so much, Shreyan. Thank you so much, Meghana, for your time, for coming and introducing me to something I didn't know anything about before this. And now I'll pass it to Louisa to introduce our next speaker.
Sounds good. Thank you so much for your session. It was amazing. And right now we are going to go with artificial intelligence in public transportation systems by Sania. Are you there? Also, while she's connecting, I want to remember everybody that for each model on the Cloud Skill Challenge that you complete, we will be planting 1 tree. So go ahead, don't forget to complete that Cloud Skill Challenge and email screenshots to aiconf@globalai.community. I'm not sure
I need to do that. Well, we're waiting a little bit for it to come online. I need to fill out that Cloud Skills Challenge now. That's what I'll be doing after this conference. I need to grow my skills too.
Yeah, I think you will have 24 hours to complete it. So just right after the event, just go ahead and complete that. Hi, Sania.
Awesome. Hello. Thank you so much for having me here.
Oh, thank you so much for connecting. That's awesome. So what are you going to be talking about today with us?
So today I'm going to be talking about artificial intelligence in public transportation systems. So should I be sharing my screen now?
Yes, please.
Okay, great. Just one moment. Is my screen visible?
Yes, it's visible.
Okay, cool. So hello everyone, I'm Sania from India, and I'm going to be talking about artificial intelligence in public transportation systems. So what is public transportation? Public transportation is a form of travel that allows more people to travel across designated routes at minimalistic prices. So buses, trains, metros, all of them encompass public transport, and public transport can be said to be the lifeline of any sustainable city. Public transport has numerous advantages that it poses to passengers, to the environment, to the economy, and to the community in general. So these advantages can be said to be these advantages that we can see on the screen here, that they are environment friendly and that public transportation helps prevent global warming. So let's just take the example of a regular bus that we have, which has about 50 passengers on it. So the bus reduced the need of 50 private vehicles on the road, thus cutting down on harmful emissions. This also reduced the traffic congestion and increased the land value remarkably by cutting down the number of private vehicles that could have been used if the bus was not in function. Also, it's very important to know that public transportation facilities like buses and metro services are very economically feasible when you compare them with private vehicles. This is because you actually have to purchase the private vehicle on your own, whereas in the case of buses, you just have to complete a very economically friendly and a very viable ticket to the public transportation system that you are going to be using. Moreover, public transportation ensures increased mobility to those passengers who do not have their own driving licenses, like students or those who cannot drive. Also, it also provides increased mobility to tourists who are not very well aware of the road networks in alien lands. Public transportation is also safer for the elderly and for women because there are a large number of people who are traveling at the same time. But in spite of all these advantages, public transportation could not achieve the popularity that it was supposed to have achieved, and it's largely underappreciated, especially in developing countries. This could be owed to qualitative and quantitative factors. So let's take a look at these factors. Qualitative factors could include factors like overcrowding and unhygienic public restrooms that actually are major turnoffs for people who don't really, who are health conscious, and also for people who have another option with them to use private vehicles, and therefore only captive riders or riders who don't have any alternate solution with them choose public transportation. Now, let us look at the qualitative or the quantitative factor for this. Let us assume that this is the network architecture for a particular town, and that this arrow basically denotes the route of the bus that the bus is supposed to take. This, however, means that all the people who reside in this spot or in this spot are not actually provided advantage of the public transportation system and have to compromise on the accessibility. Henceforth, public transportation is largely non-uniform, and therefore measures need to be taken in order to popularize it further. The solution for this problem is artificial intelligence-based ITS, or intelligent transportation systems. So intelligent transportation systems are integration between conventional transportation techniques, communication engineering, Internet of Things, and above all, artificial intelligence. ITS tools can render public transportation operationally appealing and remarkably efficient. Also, if we take a look at the ITS World Bank 2016 toolkit, it states that retrofitting modern extensions to already established infrastructure is inherently tedious, as is the case of developed countries. This means that, like in developed countries, when there is already a well-established network architecture for public transportation, it is actually very difficult to take down that network and replace it with a modified version of it. However, developing and underdeveloped countries have negligible to minimal transportation pipelines, like India. It becomes really easy to incorporate modifications and changes in those countries. We can also think of this as a typical example by using an example of gardening. So if you have ever had an experience with gardening, you would know that if the field that you have is barren, it's really easy to go and plant flowers in it. However, if you already have a well-established garden, it would take a lot of time to actually tear it down, renovate it, and then plant new flowers. This is what the ITS World Bank 2016 toolkit means. We are now going to be taking a look at the various problems associated with public transport and how artificial intelligence-based intelligent transport systems can help us deal with those problems. So if you've ever traveled on a public transport in a developing country, you would know that there's actually no way to have the driver of the public transportation vehicle accountable. There could be inherent delays, and you would never know as to what actually was the main reason behind those delays. You would never be able to find out as to why were you kept waiting at the bus station for approximately 20 minutes and there was no note from the driver or from the control center. And so therefore, oblivion of buses or trains' tardy schedule is a major convenience hazard that prompts affluent riders to opt for private transportation instead. The causes of disruptions may never even be found. Also, cases like eve-teasing and pickpocketing are several highlighted issues that really increase the problems associated with public transportation systems. Now, the solution for this could be vehicle tracking by using GPS or global positioning systems, and AVL or automatic vehicle location, and AVI automatic vehicle identification. So GPS can provide real-time vehicle tracking per every vehicle. So movement of each bus, the trip length, the time, the stopping time per stop, and the complete movement of the bus or the vehicle could be monitored. The system can then inform the control system whether the bus is running on the right time or not, and then artificial intelligence could be used to deem as to why is the bus not running it on the right time. GPS systems can also help in controlling instances of eve-teasing and pickpocketing, as the driver or any passenger around can inform the control room and the police control room vans about the case specifics as to what actually happened in the case, and with a mere click of a button, your PCR vans would be at the service. It could also deem which routes are safer by analyzing data from previous tours or previous destination routes of the bus. AVL or automatic vehicle location or automatic vehicle identification are the technologies that track transit vehicles in real time using GPS, and they could also read number plates using techniques like RFID, that is radio frequency identification, and image processing. So these techniques are used to identify vehicles and even the letters that are present on the number plates. Information about the vehicle is conveyed to the control center and to the passengers as well. We can use facilities like Azure's cognitive services to identify and recognize vehicles. So if you can see in this example, the blue spots over here, this blue spot over here is basically used to denote the initial point from where the bus actually started. And this blue spot over here is basically supposed to be the point, the destination of the bus. And this red spot over here is basically used to denote where your bus is right now, and real-time information is passed on to the passengers, like expected arrival 7 a.m., running on the right time, and bus 441B on the way. Also, in the case of police or the cops investigating some unscrupulous vehicles, you could run the number plate through an image recognition or an object recognition, a text recognition, or an optical character recognition system, like the ones offered by Azure's cognitive services. And then it could be used for vehicle recognition. Like, for example, in this case, it says vehicle recognized, Florence, Italy. It's a state official vehicle, therefore access has been granted, and it has been labeled as a safe vehicle now. If you look at the applications of artificial intelligence and vehicle tracking, we can see that AI can be used to predict the arrival time of the bus or train with respect to its present location, and then deem whether the vehicle is running on the right time or not. This means that data collected by our services after every trip of the bus can be used to predict as to when would it reach a particular destination X at a particular time, and then if we could compare these times with the newer times after each trip, and we can see as to at what place should the bus be reaching so as to reach the destination in the given time. AI can also label certain routes as dangerous by analyzing the number of pickpockets or eve-teasing incidents that are taking place over there. If you take a look at this GIF over here, you can see that the previous week intel for Route 4B says that there were 10 eve-teasing instances and 5 pickpocket instances, thus labeling the route as dangerous on its own. And even before the crime has been reported, the police control room vans have already been alerted, and all the PCR vans on that route have been alerted, and they would keep tabs on the bus. Image processing and OCR text recognition technologies could also be used to identify and validate number plates. Now, we are going to take a look at the second problem caused by public transportation system. And that is that public transportation systems usually take a lot of time in order to cater to individual passengers. So passengers dislike public transportation because of comprehensive catering, and that means that they have to stop at multiple positions, while private transport caters to private demands only. And so since private transport basically has only one destination in mind, that is your ultimate destination, and public transport has multiple destinations and stops at multiple locations, it could lead to inadvertent delays, and that is why the population pool shifts towards private transportation, and it slowly started to desist from using public transportation systems. The solution for this is time control and traffic signal priority. So traffic signal priority is a major example of an intelligent transportation system that helps to incline the passenger pool towards public transportation. And how it does that is that it seeks to provide priority to public transportation at traffic signals by reducing their red time and increasing their green time. So TSP systems are integrated with automatic vehicle location frequently when there are very high priority demands. So this means that whenever a public transport is passing and it has to stop at the signal time, even if it was green, even if it was red, is changed to green and the vehicle is allowed to pass through. This is an example of something called zero wait priority, because at times public transportation don't even have to wait for a split second before they are granted access. All of these facilities have been taken into consideration so as to prompt more number of passengers to opt for public transportation. So phases are extended, the phases of the green time are extended or truncated sufficiently quickly, such that the light is always green when the vehicle arrives and it quickly turns to red as soon as the vehicle is gone. So there are bus-only turns, bus-only green phases, and bus gating for the bus rapid transit vehicles only. Also, how can we use AI in these instances? It's very important to know that image recognition is very important in this case, because the green time has been dilated, the green time has been enlarged only for those cases in which a public transportation vehicle has been detected. And as soon as the public transportation vehicle leaves, we have to quickly diminish its green time and revert back to the red color. So AVL and image recognition are used for identifying the bus rapid transit vehicles that are allowed to pass through. Identification prompts the signal systems to dilate the green time after assessing the priority request, whether it's actually a BRT vehicle or is it a false alarm. Signals should quickly change color again as soon as the BRT vehicle has passed so that no private vehicle has actually taken undue advantage of the TSP. Stop time can be reduced further if the BRT is found to be running behind schedule. Artificial intelligence is used to juxtapose or compare the defined arrival time and the predicted time to decide whether a privilege should be granted or not. So this means like examples of zero wait for public transportation systems. Even in some cases, in some countries where there is no system of zero wait for public transportation systems, this is an important example that it is in the case of a public transportation vehicle running behind schedule. So artificial intelligence can be used to actually decide whether the vehicle is running behind schedule or not, and that if it is running behind schedule, it is designated to make up to the loss that it had, the time loss that it had, by actually providing for a zero red time. Now we have real-time passenger information. Real-time passenger information system is basically built on automatic vehicle location and GPS technologies. Many people actually get all of them confused, but that's not true because GPS is the technology that is used for real-time passenger information systems. So RTPI is a transparent public information system built on AI transiting data in real time, and it basically gives you real-time updates about where your public transport is right now. RTPI conveys estimated arrival departure times, information about disruption causes before the queue travel. AVL, GPS, radio frequency identification, and image processing may be used to generate the data that is displayed by the RTPI, as you can see in these examples. RTPI also magnifies customers' experiences. So as you can see here, this is the initial location, whereas this is the final destination of our particular public transportation vehicle. So it says at this point that the bus 4C was on its way. Its current location was, let's say, ABC. Expected location was CDE. Its current status was on time, and its expected arrival was at about 8 a.m. However, if we look at the case for nearly 2 minutes after that, the bus 4C is still on its way. Its current location has changed from ABC to something called DEF. Its expected location is CDE. And it's now late by 5 minutes due to an accident, and its expected arrival time has been changed from 8 a.m. to 8:05 a.m. This is a very good example of a real-time passenger information, wherein if somebody is actually in a hurry, that person would actually know where the bus is located right now. So this is a very big advantage that ITS has brought for public transportation systems. Let's look at the artificial intelligence applications of RTPI. Like I said, AI can be used to predict the arrival time of the bus or train with respect to its present location, and then it is used to decide whether the vehicle is running on the right time or not. For example, let's just take an example of a case where the bus actually reached its designated destination at the right time. It was flawless. So it would use the data in that case and see that, okay, at a particular point called X, I was Y minutes away from reaching my destination. This means that if at the particular point X, the time that it still has at a particular point called X, if it's running at the right time, it would still take it Y minutes. However, if there is a little bit of traffic and other factors, then it would have to take them account and take them into consideration. Next up, AI analyzes metrics and enables passengers as well as fleet managers to exercise control over the operations. Image processing, OCR, text recognition technologies could be used to identify and validate the various number plates on the vehicles so as to find out and prove that the vehicles running are actually legal and qualified vehicles. Next up, we have intelligent ticketing system, where so there are various problems that are arising these days due to a sudden inclination towards cashless economies, and that is actually a very good idea. But intelligent ticketing systems are built for cases of cashless economy. They are much more, which make the economy be faster and which ensure more uniformity. The problems could be caused by lack of change, cashless transaction preferences that drive passenger base away. For example, look at this example. The bus conductor says that he only accepts coins, but the passenger only has a credit card. So to diminish instances like these and to have a more flexible payment option, the intelligent ticketing system was introduced. So as you can see in this example, this is a smart card. So intelligent ticketing system is a system that electronically stores a travel data on a microchip. And this microchip is embedded in a smart card. The contactless smart card is scanned by a transport operator, which in this case is a kiosk. And it could be stored either at a static or a handheld ticket machine or a barrier which authorizes your travel. So inside the smart card are all your tickets, bus tickets, metro tickets, train tickets, tram tickets, and this kiosk is basically reading all the data off of them, and now it has details, it has the passengers' complete details regarding travel. It can find out from where does it have to deduct the prices of the travel, from where does it have to, add any fines, and etc., and all the other features associated with travel. If you can take a look at the AI applications, there is just one smart card that is renewed every 30 days to render every public transportation, be it a bus, be it a tram, be it a metro, accessible to the passengers. So contactless transactions are very useful during COVID-19, of course. Fare deductions, extra road charges, and fine deductions are possible only by integrating optical character recognition and text recognition features in your embedded systems, so as to make it realized as to on what particular instances should it be deducting fares, and on what particular instances should it be actually giving discounts to the passengers, and so on. And AI is leveraged for deciding which passenger needs what faculties at what particular point in time. Next up, we have automatic passenger counters, and overcrowding is a very major problem in public transportation. This agitates passengers and they choose to opt for private transportation instead, obviously, and overcrowding, especially during times like COVID-19, is a very big disappointment, and it really needs to be checked. So solution for it are automatic passenger counters. So as you can see here, there is this bar, this infrared bar that basically is used to count the number of people who are actually on board. And it says the present capacity is 50, the total capacity says 10,000. So this means that it is safe and more number of people could be boarded. So automatic passenger counter is a technology that is used to record the number of travelers using public transportation at a given time. So infrared bars at the doors can be used for counting the number of passengers, and also image recognition and optical character recognition can be used as automatic passenger counters. AI is coupled with Internet of Things to reap the optimum results. Now we have the AI applications of automatic passenger counters. So artificial intelligence is used to understand the significance of the present capacity as to what is the present capacity of the train, and as to how much should the train be able to accommodate. And that's what I said, compared with the maximum capacity to deem whether more passengers are allowed or not. AI is used to set the weight and the passenger count limits also. It basically takes factors like the build of the train and the length of the train, the dimensions of the train, to decide as to what should be the weight and the passenger count limits also. Therefore, artificial intelligence has implications here as well. Now, electronic toll collection. So electronic toll collection is not something that is associated just with public transportation, but definitely it does give a one-up over private transportation in this case. So electronic toll collection, basically, the main problem that arises with toll collection is that it's a very lengthy manual process. And only when the first car, the car that is located before the second one moves, would the second one be able to shift and take its place, right? So this is a major problem that is associated with toll collection. And toll collection manually is a lengthy manual process. It renders the traffic delayed and sluggish. This means that a large line of vehicles is set to come up over here. Moreover, since cars are smaller, they could be accommodated, but bus and truck lines become huge and very, very lengthy. So how can we find out a possible solution to this problem? A possible solution to this problem is electronic toll collection. So electronic toll collection offers a facility of cashless and immediate tolling, which eliminates the delay that happens on roads. So as soon as your vehicle passes through an electronic toll collection booth, it uses services like Bluetooth and image recognition, as well as embedded systems and IoT to basically analyze, okay, what sort of vehicle is passing through it, and it then accesses the account details of the passenger, of the account details of the driver, driver and deducts the required toll fees, the toll charges from there. So ETC determines whether the vehicles passing through the toll plaza are enrolled in the program and electronically debits the accounts of the car owners without stopping by, leveraging AI for decision making. Like I said, artificial intelligence is basically used to understand what sort of vehicle is passing through it, because the rates drastically differ for cars, proportionately differ for cars and for buses. So public transportation rates are definitely lower than the ones for private transportation. So image recognition is basically used to identify whether the vehicle passing through our electronic toll collection booth is a public vehicle or a private vehicle. If it's a private vehicle, then more charges have to be deducted, and if it's a public vehicle, such charges have to be deducted. FASTag is a very important example that is coming up lately. So electronic toll collection initially started in Orlando, Florida. Let's just take a look at the examples of intelligent transportation, multimodal examples. Like in developed countries, we have London, UK. So London has a very comprehensive bus management system, and the Oyster card, which is a single smart card, is needed to avail all public services, from metros to trams, to all the trains available and all the buses available. You have an Oyster card. Zurich, Switzerland is another very good example of multimodal transportation in public sector. Zurich has a profound network of buses, trams, and trains. Very good systems, very good RTPI systems, both on the trains, on the public vehicles, as well as on the stations. Next up, we have Florence, Italy, as a perfect exemplification of a multimodal transportation. Florence has a well-managed system of public transport. There are video cameras and automatic passenger counters that are put up, and then image processing and optical character recognition are used to basically count the number of vehicles so as to ensure there is no overcrowding and overloading. If we take IT's examples in developing countries like India, Indore is a very good example where high-capacity bus-based rapid transit systems are used. Features like electronic ticketing, automatic vehicle location, and fleet management. Fleet basically means a set of buses that are governed by one control room. Fleet management systems are also very popular. So have started to become very popular in Indore as it became a smart city. So Bangalore, India is also a very good example for ITs in developing countries. There are CCTV surveillance systems in buses, and there are also integrated traffic management systems so that the images that are obtained from CCTVs can be analyzed, and then they can be used to deem various routes as safe and various routes as unsafe or dangerous. New Delhi, India has a very stable and it has a very sound multimodal public transportation system. There is a Delhi Transit Bus Info application that's an example of an RTP, real-time passenger information, using things like GPS and automatic vehicle location. It has automatic fare collection as well, using automatic ticketing, as well as CCTV controls, which really help in analyzing the images that are clicked and are used to deem whether the roads are safe or not. They are used to deem whether there is an instance of overcrowding or not, and so on. Thank you. This was all I had for today.
Awesome. Thank you so much, Sonia. I feel like I also use public transportation all the time. So this was such a fun talk to just like hear from. And I especially love the part about real-time passenger information. I've occasionally waited out for a bus for a couple hours and had no information about why was it delayed, when's it coming. So absolutely fascinating. I would love AI to come to the greater Seattle area for our public transport system. But we have time for one question for you. So out of all the challenges and solutions you presented, which one do you think will be the most challenging to implement in public transportation systems?
So it basically depends on the country that we're talking about. So in countries like India is still a developing country. So RTPI and so on are not very difficult to implement because they are just GPS-based systems. But instances like electronic toll collection would be really tedious to implement because of the machinery that is useful. Also, in India, there is a very big manual solution that we have, and that is that there are a lot of people who are actually working behind toll booths. So once an electronic toll collection system is actually put up, these people would lose their jobs. So that is actually a very provident example wherein artificial intelligence is replacing jobs. So this is actually a very big threat that could be taking place, and that is why electronic toll collections could not be implemented in India as of now. However, FASTags have been developed, and as people skim through it, more and more people, there are still people who work at the toll counters and who direct the passengers as to how should the FASTags be used. So yeah, there is a solution for everything as far as I believe.
Awesome. Thank you so much, Sonia, for coming on. An absolutely fascinating talk, and I learned so much. Okay, now we're going to transition to our next guest speaker. We have Carla, Florida, and I've heard your talk is called #No More Matildas, and I am so excited to learn more.
Hi, girls. I am a little scared, but I'm happy to be here.
That's cool. So no, you don't need to worry about anything. Just go ahead. So, what are you gonna be talking about today?
We will meet a scientific woman and how artificial intelligence can help us to know her. Meet them. My English is terrible. I'm sorry.
Oh, it's awesome. You're so good.
Thank you.
Awesome. Well, you can start whenever you'd like.
Okay, I will share my screen. Give me a second, please. Okay. Okay. I am sharing my screen. Okay. Well, hi everyone. I will talk to you about No More Matildas. No More Matildas is a movement, a global movement right now. For this event, I am with a special t-shirt, I think, with a scientific woman, but in the programming area. So in this project, we are developing a conversational question and answer agent to discover the legacy of women in science. We are using Hugging Face and of course natural language compression models and natural language processing. Okay. My name is Carla Marcela Florido Roman. I am from Bolivia, and I work in Institute for Computational Intelligence in the university, and I am a Gold Student Ambassador, Microsoft Learning Student Ambassador right now, and I have some advices. I am still learning English, so I am a Spanish native, and I will really try to speak in English, and I will try to all of you can understand me. So Luisa, if I need some translation, please you can help me. I will really try to speak the half of hour, and I will do my best to this presentation because I'm too happy to be here. Okay, we have two, I think, big numbers here about how women are in a STEM area or technology in general. We have a little number of women in educational material. What does it mean? If you go to the university, if you go to the school and you open a book, it's most common to see men. And this is good. I don't think this is a bad situation. But what happened with all the women who were working with technology, with science, biology, chemistry, they are not in all this book, no? So I think this is a bad situation for all these women, no? For this amazing woman. And we have other number who are women in STEM careers. In engineering, in general, we have a little number of scientific women. And I think this is a bad situation again, because we have many friends who are girls and who are intelligent, who are incredible, but maybe she don't want to study these careers. Maybe for some stigmas, I don't know what is the word, but maybe all people say, I am from Bolivia and I hear about this. Okay, technology careers or engineering is not for women, and I say, oh my God, no. And for that, I work. And I am trying to inspire more girls, more women to study these careers. Okay. Oh, the next one. Okay, I will talk about women in history and science, and I have 3 amazing women here. I don't know if you know about them, but I will start to talk from Maria Wickelmann-Kirch. She is an astronomer, okay, but in the history of astronomy, maybe not too much people know about her. But she has many contributions to this area. She is the first person to discover a comet. So this is a big step in the history, in the humanity, and all her work is not maybe in books, no? How I talked about, no? She was married with Gottfried. This was a scientific man, and he has all the glory for her contribution. But we are talking about a man maybe with a stolen work from other women, no? We have the second example. She is Rosalind Franklin. Okay, now she is a little. She's most popular. Okay, in this, I think in all these years, but she's an amazing woman. She is she worked with physics, chemistry, and mathematics, and she was collaborating with Watson and Crick. Watson and Crick have a novel, okay, but with her contribution. So we are in the second example with our stolen work, and she discovered the X-rays, and these images helped to the investigation with the DNA, no? And our last woman is Matilda Joslyn Gates. Okay, this conference is about her and about her vision. She was a feminist writer, okay, maybe in this, when she was alive, okay. Not too much people like what she was doing at this time, okay. She was writer in the National Citizen, and she worked with a woman, a scientific woman, like Rosalind Franklin or Maria Wickelmann, who has stolen investigation for other people, okay. She was working for our vote, okay. For her contribution, a woman can vote now. She is an amazing woman too, and I admire her. And okay, of course, she worked too about the women's law or rights, no? Okay, so now I can talk to you about No More Matilda. Okay, this is not a project. This is a movement who try to speak more about scientific woman and her contribution to the history. And okay, now I am working in a team. We are 3 women and three guys, but in the but first, okay, in 2 years ago, maybe we were 3 guys, and I was the only girl. And I was always speaking about I would really like to see more women in our teams, in investigation, in technology. And my boss talking me about Norma Matilda, saying, okay, we can do this investigation, okay, and we can combine this with artificial intelligence. And for that, we are working with Matilda Bot. We are in the first step in the project, but Matilda Bot is a bot, okay? It's an assistant who can, talk to you about a woman and her contribution. But we are using a little artificial intelligence with NLU, Natural Language Understanding. No, it's most popular here about natural language processing, but NLU is is other step from this, and NLU can help us to talk with a bot, with an assistant, but it's most friendly maybe, because this learn about how is the natural language, okay? Why? Because if I can introduce myself, I can say, okay, I am Carla, or okay, Carla is my name, no? Or in Spanish, we have many options to say the same statement. So NLU can help us to understand this, and maybe use a special techniques, okay, to communicate with us, and we can communicate with the bot too, no? So we are talking about dialogue systems. These manage human variance, no? Is what I was talking about. We have many options to say the same statement, and this can understand the intention of the human, okay? If you have 10 options to say this, to say the same thing, okay, this bot can understand this intention, no? This is a crucial part in this system. And we are working too with follow questions, okay? Our bot, our model is training with questions and answer, no? And okay, we are working too with intent and entity, no? In same in a same expression. And okay, in the first part, we have the machine learning pipeline, okay, and we are working with 3 steps. We have the data preparation. This is the special thing right now, because we are working with this at this moment. The data preparation, okay, we are various steps, okay. We have various steps in the data preparation, and finally we have the model evaluation. We have a little okay, this is a little evaluation, but we are working with results, okay. Okay, in the data preparation, we worked with Wikidata and Wikipedia, but we prefer to work with Wikidata, because in Wikidata all the information is maybe label, okay, and for our work this is the best option, no? In Wikipedia you just see the information, but in Wikidata is all in the right place, okay, and you can, and I don't know, if I would like search about singers, woman singers, no? Wikidata can show me all the woman singer, but in Wikipedia this is maybe okay, I need to go to some place and maybe click on some button, but this just show me, no? But Wikidata is all labeling, so for us it's a better option. And we were working with Spark QL too, because we need all this information for our CSV. So Spark QL could help us with this. Okay, the model selection. We are now working with Hugging Face, and we worked with a BERT model, okay. But for the training of our model, we found something peculiar. Okay, and I will talk about this data set. Call it SQUAD. Okay, this is one of the most popular data sets because it's from Stanford. Okay, and I will talk to you about SQUAD later, but we can talk about the model evaluation. In SQUAD we have oh my God, I don't know how to say the numbers, but we have this number. Okay, I'm so sorry. Sorry.
I think you can say 86,821.
Gracias, Luisa. Thank you, Luisa, for helping me. Okay, and we have this number of examples. It's a huge number, okay? But when we were reading, okay, this example, we found something peculiar. We don't have any information. We don't have information about a scientific woman. If you go to SQUAD, okay, you can find information about Tesla, about Einstein, about Shakira, Beyonce, and that's okay. But what happened with Marie Curie, with Rosalind Franklin? Maybe just for the training of this, or not the training, maybe for the structure of this data set is okay, but we have I don't know how to say in English, but we believe that the information about all these scientific women could help maybe to this data set, no? Because it's more information for a part, but for other part, we think that we can visibilize the work of all these women, no? And okay, now we have 1,700. I don't know if this is number.
Yeah.
Okay, thank you, Lisa. Questions and answers. Okay, so we just add all this information to the SQUAD model, and okay, we train the model, and we have okay, one of our results, and the precision, okay, we think is a good precision. You can see the precision here, and but we are still working with this model with Hugging Face, and we of course we want more information about scientific women, because we found around 16,000 scientific women information. So we have a lot of questions and answers. Maybe we can add 5 or 10 questions and answer for each woman. So our contribution, okay, for the first part, okay, we have a Matilda bot who can teach you, who can speak you about the woman, okay, the scientific woman, but we are contributing in the SQUAD dataset too. And we have the different types of questions, and we have open questions about her biography, what is her area, what she was doing, what she win in her year. So this is just a little part of the project. And this is our CSV. We okay, it's just a simple, maybe just a simple CSV, but we have a lot of information. So we are typing, okay, we are writing, okay, for our part, and we are building all these questions, and we are answering these questions with the content, okay, or the information about each woman, no? So in the evaluation, okay, we will really try to have a better result, okay, and we want to the people can talk with Matilda. Matilda will be a web, okay, but you can talk with Matilda, and Matilda will talk to you about do you know about Marie Curie? Do you know who was Marie Curie, or something like that, no? We are working with no more Matildas. We want to visibilize the projects of all these women, no? And okay, we are using Hugging Face and, in this area, no? And this is okay. Matilda is a bot in Spanish, but I will translate this conversation. Okay, we have a user who say just hello, and Matilda show 4 options. The first one is okay. You can meet a scientific, a random scientific. You can search information about some scientific, or what. Luisa, ¿cómo digo? ¿A qué científica me parezco? Perdón.
You can say what scientific I look like.
Okay, thank you. This is the third option. And the last option it was my idea. You can talk and let a message to some scientific. So we want to build maybe a mural, okay, with all this message, no? And okay, if the user say, okay, I choose the first option, I want to meet a scientific woman, and okay, but we Matilda bot will talk to you about what who was this woman, what she was doing in her area, when she born. What was the important part in science? So NLU can help us to have a better conversation. Okay, so artificial intelligence is one of the biggest, I think, contributions right now in the globe. Okay, and we want to use artificial intelligence with a specific point, and is to more people can know all these amazing women, no? And this is okay. More information about the woman, okay? And NLU, okay, if you have, I will tell you again, if you have 5 or 10 options to say the same thing, NLU can help us to have the better answer, okay, for your specific question, no? And we have here the a little demo, okay. I will say again, okay. We are in the first part, but with Rasa, we can emulate, okay, how is the interaction with Matilda bot with the user, no? So, okay, your input. This is the user. The user just say hi. It's in Spanish. Okay, Matilda shows to the user the 4 options, okay, and the user, okay, choose the option 1. He wants to meet a scientific woman, okay. This is a random answer maybe, and the choice of the Matilda bot is Maria Jose Figueras Salvat. And she is a Latin girl, okay? And I think in all our new data set, we have women from all parts of the world. So if you are maybe from India, if you are from China, you can meet all these women from your country, no? And I think this is an amazing thing, no, about our contribution. Okay, when she born, this is the year. Okay, and where she born right now, Matilda says Tarragona. And in our model and in our answer, we have a few problems, and we can see the semicolon or other punctuations, signs, and we are working right now with this, but because we want a clean answer. Okay, I hope we can work with that. Okay, so what is her area to teach? And Matilda says microbiology. Okay, in what university? In which university? Universidad Rovira y Virgili. Okay, and the user say, okay, bye. And this is a little demo. Okay, this is all what we have right now, and I will say this again. We want to combine, okay, the power of artificial intelligence and all this information about an amazing woman around the world, okay, in STEM areas, for more people can know her, no, but in the nicely way, okay, like you are talking with a friend, or for you have the better experience, no, with Matilda bot. Okay, so thank you so much. I'm sorry for my English. You can find me in Twitter, you can find me in Instagram. This is my email for if you have questions. And I have the user of my boss, who is Dr. Diego Collarana, PhD, I think. And thank you so much.
Thank you. You did amazing. So it was very exciting hearing about the No More Matildas movement. Thank you so much for sharing all that information about it. And I have a question for you. What are you most excited about the next steps of the No More Matilda movement?
Ay, ¿me lo puedes repetir en español, Luisa, porfa?
Sí, de que estás más emocionada, ¿qué te emociona más de lo que viene del movimiento de Matilda, del No Matilda Movement, de lo que sigue?
Okay, I think it's the inspiration for girls. We want more girls in technology, please. So for that, I think this is a big contribution, okay, and we are using artificial intelligence, so I think this is the most exciting part for me.
Yeah, definitely. And thank you so much for the presentation. Thank you so much for bringing awareness of women, of bringing more women in technology and more girls. Definitely, I agree with you. We need to increase our numbers. And yeah, thank you so much. You did a great job, and it was awesome to see your Azure, like your Matilda bot working. So it was awesome. Thank you, Carla.
Thank you so much. Bye-bye.
Thank you, Carla. And this is a perfect point. Carla brings up such a great message. And we actually are going to have a Women in Data Science panel at the very end of this conference, which is absolutely amazing. I'll actually be on it. So, of course, I will be hyping it. But now I'll pass it back to Luisa to invite our next guest speaker to the stage.
Yes. So our next speaker is called Valentina. So I don't know if she's already here. I think while we wait, she's gonna be talking about like her title of the presentation is "Can a machine learning system outperform humans in emotion recognition?" So I think she's here already. Awesome. So hi Valentina, how are you today?
Hello, I'm good. How are you guys?
Very good. So yeah, you can start talking about your presentation. So yeah, what are you gonna be talking about now?
Okay, so can I share my screen? I think.
Yes.
Okay. Okay. I think I need to quit and reopen, quit and reopen in order to share my screen because I needed to like change the settings.
Sounds good, Valentina. See you very soon. In the meantime, we'll hype up once again our amazing Cloud Skills Challenge. For every module you complete, we're going to plant a tree. That is so cool. I'm going to be like, first of all, I'm going to do it once this conference is over, and then I'm going to tell all my friends to do it because that is probably the coolest initiative I've ever seen for a conference ever. And then I think, oh yeah, the final piece. If you email the completion to, you can be entered in to win an Amazon gift card, which is extra cool. You just planted trees and could potentially win a gift card.
Yes, definitely. And remember, the email that you need to email that is aiconf at globalai.community. So I think in the comments of this conference, you can see like the link, and then you can see all the details and things like that. So yeah, just don't forget to complete your Cloud Skills Challenge. Oh, I think she's back.
Yep. Hello.
Hello.
Can now share my screen, I think.
Awesome.
Can you guys see my screen?
I cannot see it yet, but I think we're almost there.
Share screen. Can you guys see my screen now?
No.
Okay.
Please stand by. You might even be icy on my end. Valentina, you're frozen right now, so maybe it's a Wi-Fi connection thing.
Yeah.
Can you guys hear me?
I can't hear you.
Mm-hmm.
Okay. Do you guys know why I might not be like letting you guys see my screen even though I think I'm sharing it?
If I were to guess, I would say currently on my end, your camera screen looks frozen. So my initial hypothesis is maybe it's a Wi-Fi disconnection where it's like, oh, maybe I've shared my screen, but the actual, maybe it isn't working. So maybe, oh wait, it just appeared. We did it. Awesome. Yes, we can see your screen. We can see you. We're ready to go. Woo! Thank you for your patience, everyone in our audience. And this is going to be an amazing talk. Stay tuned. Stick around.
Okay. So, this is my talk. My name is Valentina Zhang, and today I will be talking about whether or not AI can outperform humans in emotion recognition. As I'm sure you guys have heard throughout today, there are so many ways that AI can like outperform humans in so many different fields, such as like playing chess or art or like better and safer drivers. And so my research that I started kind of over the summer is that if this trend continues, could there be a day in which AI is able to understand and express emotions better than humans can? And would that allow AI to eventually have consciousness? And these are like some of the questions that I wanted to answer. And so let's get started. So first of all, I just wanted to start off with how we recognize emotions. There's many ways. For instance, this can involve like the tone of the voice, language, gestures, body language. But I think one of the key ones, which is what I focused on, is facial emotions. In the past, researchers have classified 6 major facial expressions. These are happy, sad, fearful, angry, surprised, and disgusted. Throughout more research into what emotions actually are and what emotions are actually able to be expressed on faces, people have identified 21 different facial expressions. So you can see them listed here. But these are often like very difficult to identify accurately, and therefore for my research I focused on the 7 that was established in the 20th century. And so my research is mainly focused on in a field of medicine and medical care, but there are many ways that facial expression and emotion identification can be very helpful. So this involves like education, robotics, computing, like human and computer interface in order to make the communication between humans and robots feel more natural. And people expect that this emotion recognition will become a $56 billion industry by 2024. So that is very exciting. And you might be wondering now, like, since machines don't have emotion, since they currently don't have consciousness, how can we make them better at recognizing it? But this, in fact, is answered by, first of all, that facial expression is like a low-level response in your brain, and therefore there's patterns to it that machine learning is actually particularly good at recognizing. And additionally, since machines don't have emotions themselves, it cannot interfere with their understanding of emotion. So if you experience an emotion, this might influence how you understand other people's emotion, but machines don't have this problem. And so let's imagine there is like a contest today between humans and machines in recognizing emotions. And I did some research and I found that currently today, humans have an accuracy of 68% accuracy in recognizing emotions through pictures of faces. This is actually like a pretty surprisingly small percentage, at least in my opinion. I don't know about you guys, but I found that humans are actually not that great at recognizing emotions and faces. On the other hand, a convolutional neural network has been found to be the best at detecting emotions. And so the best one so far in machine learning is 65%. And while machines are still worse than humans at detecting emotions, they're actually pretty close. So now let's build a machine learning system that can actually outperform humans in emotion recognition. And so throughout this process of trying to build a machine that can be better at humans, I found 4 observations through different areas that helped me come to my system. And so first, it's a scientific observation that I made, which is a psychological discovery that humans perceive things differently based on the different stimuli that they receive. So one person might focus on a certain part of a person's face, while other people look at different stimuli. And the question is, can we help machines learn better by kind of copying what humans do? And so thus, I made a model. It is an image-trained convolutional neural network model. And this kind of matches the fusiform face area in our brain, which is a certain part of our brain in recognizing faces that doesn't show any preference for the singular features of our face, such as like a nose, a mouth, or eyes, but rather it looks at all the parts of the face holistically. And this is quite similar to how this image-trained model functions. And so how we trained this was a data set of images, labeled images, and we just fed the machine learning model the pixels. And this is kind of looking at the entire face, and we had an accuracy of 60% using this model. On the other hand, we used something called facial landmarks. And so the accurate identification of facial landmarks is a process in which each part of the face has a certain number of landmarks. So there are 68 landmarks in total, as you can see in this image on the side. and they are mapped to the facial action units on the face, which is like the muscles on the face that correlate with certain emotions. And thus, because this is such a suitable representation of data, it significantly increases the accuracy of a model. And so in the same way that the previous model is similar to the fusiform part of your brain, this one is similar to the occipital face area in the brain, which recognizes the different parts of a face separately. So you see the eyes, which are mapped by 6 dots each, and then sees the mouth as an individual piece. And so this is what we are trying to show in this system. And so for this, we created an ANN model. This is similar to a shape prediction model, which is basically how we can predict, how we can identify a certain shape based on points on this shape. And we had an accuracy of 56% here, probably because we had less data. However, this is still pretty good accuracy. And I wanted to test how these two models could work together well. So I created these correlation heat maps in which I have the 6 emotions and also neutral. And I used both of my models in order to identify, this is a deepfake, which is basically they have emotions, or they have one person's face and they map the emotions on that person's face to a different person's face. So here you can see Elon Musk and deepfake of him. And so as you can see on this correlation map on the left, the diagonal, which is the correlation of the correlating emotions on the original and the deepfake video, it's a significantly stronger. So it's significantly more red than the one on the right, in which that one was the one that used the image-based model. And so I concluded that the image-based model picked up more subtle emotions actually. However, you can see that there's a lot of potential for these two models to complement each other due to the way that they recognize emotions differently. So for the landmark trained model, it's going to recognize the bigger emotions, while the image trained model recognizes the more subtle emotions. And so my second observation was that the function of the visual system in our brain involves multiple neural networks. And so the fusiform part plays a very important role in face recognition, but other parts of the brain, such as the amygdala, is also very sensitive to emotion recognition. And all of these parts together form the face perception network. And so how can we compose different machine learning models to better recognize emotions and faces? And therefore, I analyzed how these two models of an image trained model versus a landmark trained model, how they complement each other in different ways. So we created complementarity metrics for both of these models. And at the top here, you can see the 2 graphs for the emotions that were detected by these 2 models respectively. And based on these complementary metrics at the bottom, as you can see here, we can see that the overlap in true positives between these 2 models, which are 33% and 25%, since they are both less than 51%, we can conclude that these 2 models complement each other pretty well. And we hypothesized that one of these models may recognize emotions better for a certain individual based on how they express emotions. So for instance, if a certain individual expresses their emotions in more of a subtle way, then this may cause the image trained model to be better at finding emotions for that specific person. So that's my hypothesis. And the third observation comes from evolution and nature and biology, which my idea is inspired by an observation that adaptive processes allows organisms or a system of organisms to be better able to do things that they need to do. So if in the small discussion group context, if we use group emotion change cadence as a reference, we could build a system combining both machine learning models that can adaptively reduce the noise. And what I mean by that is how often a person's emotion changes over time, right? So our goal is to adapt our model to recognize the major emotion changes of the individual while filtering out the other emotion changes, which could probably be attributed to noise or by errors in my models. And so that's, as you can see on the graphs to the right here, at the top left is the original graph that was produced. It's very noisy because as people speak, their face changes a lot, and therefore the emotion that is detected also changes a lot. When we filter out a lot of that noise, we can see a trend in the general emotion or like sentiment of a group. And so just quickly with like the technical stuff, we wanted to compute the noise level as a feedback system for the adaptive system. So irrelevant changes such as like the speaker, when the speaker is talking, there's a lot of noise, so we want to filter that out. And so what we did is we mapped it to a Fourier transform, and we removed the low energy frequencies, and this reflects like the major trends in emotion changes rather than like the frame-to-frame variance in emotion changes. And our goal is to create a system that can adapt to the individual and recognize when the individual is truly changing emotion rather than when the individual is speaking and there's just a lot of noise in the emotion that is produced. And so this is my system. I call it the adaptive facial emotion recognition, and it works specifically in small group discussions. So if I start off with a small group video stream, I first have the two machine learning systems that I use. So one detects the facial landmarks and produces an emotion from that using an artificial neural network, while the imaging processing system uses a convolutional neural network and thus can extract an emotion from that. And using both of these, I train a personalized model. And so the results from these two networks are processed through adaptive weights. And based on the specific individual and how often their emotion changes, I can determine which weight to give to each of these systems. And so I change the weights based on the individual expressions. Of course, in the middle, I reduce the noise. And then I produce a group emotion. And so if the group emotion is different from the individual emotion, then I can go back and adapt to see whether or not the individual was actually whether the individual emotion was an error or whether they were supposed to have the group emotion. And through that, I can create a system that adapts towards a specific individual and thus is a lot better at recognizing emotions. So these are some of the results for my adaptive system. So as you can see in the first test that I used in a small group, I used like videos from Zoom where there was like 4 people having a discussion. So in the first test, the adaptive model took some time to adjust and recognize how individuals expressed emotions, but afterwards they were able to detect false positives of SAD that were in the normal model. And in the second test, the adaptive model could detect false positives of fear, as well as there was an angry emotion that was not previously detected. And I went back through the videos and I manually analyzed them and found that the adaptive model was indeed more accurate at showing the true emotion that I, as like a human, could recognize than the original system did. And so lastly, my observation is from statistics, which is that, or mathematical observation, is that one of 2 strongly correlated variables could be used as a reliable predictor for the other. And so this is very helpful to help us build a better machine learning based emotion recognition system, because it can provide a critical ground truth for us to create additional label training data. And so the thing about emotion recognition is that finding a ground truth is very difficult. It is not always possible to know the true emotion of a human. The individual themselves might not know what emotion they're experiencing. However, we found that emotions of individuals are often very correlated with the group's emotions, because if you're in a small discussion group and the group becomes happier, you will probably also become happier. And therefore, we thought that if group emotion can be an indicator of an individual's true emotion, we could use these to provide more labeled data for that individual, and therefore create a better system that is truly trained just for that individual. However, one, of course, drawback of this system is that we would require like a synchronous group, such as like knowledge sharing conferences, in order to know that the individual is indeed matching with the group sentiment, and therefore we would have confidence in labeling the additional data. And so here on the right, we can see the formulas that are used for the correlation. And so just as like a definition of like what I mean by like a synchronous group or like a homogeneous group versus like an engaged group. So an engaged group is a discussion group in which everyone is engaged, like no one's on their phone, no one's like visibly looking away from the discussion, and this can reveal information about these individuals. However, this does not necessarily mean that they are changing emotion at the same time or that they are all experiencing the same emotion at the same time. And that's where asynchronous groups comes in. So a synchronous group basically, as I define, means that they change emotion at the same time. So for instance, if there's an event that happens in the discussion, all of them would change their emotion. And they may not change their emotion in the same way. So if something happens and one group member is very happy about this change and another group member is very sad about this change, they could have opposite changes in emotions. However, this would still mean that they change emotion at the same time. So the cadence of their emotion changes are pretty similar. And homogeneous groups would share the same emotion. And this could probably be for situations such as like a movie, in which we can see that most people at least would have a similar experience of the emotions because they are all watching the same movie. And so labeling can directly benefit from group emotions in this situation because we can directly map an individual's emotions with the group sentiment. So this is the correlation analysis of my personal machine learning model. And so my thinking is that if the correlation between the individual and the group increases after creating a personalized system for the individual, this approach would most likely means that my adaptive system had better accuracy for that individual. And so this is one of the tests that I made. The automatically labeling system removed a false fear reading of the individual. And of course, in order for this to work, you must experience a wide range of emotions. So this would have to be over time that a machine learning model better understands an individual and how different emotions show up on an individual's face in order for this to become more accurate. And so one application of all of this is, I'm sure if all of you guys know, Mona Lisa. People always want to study the facial expression of Mona Lisa. Many people think she is smiling, but like, is she happy? Is she sad? What is going on with her emotions? And so this is a very elusive ground truth. We do not know how she is truly feeling at that time. So there's been much research about how she is actually feeling. So for instance, at the University of Cincinnati, neurologists, they manually analyzed her face and found that the left side of her face indicated happiness, while the left side displayed happiness, while the right side did not show any happiness. And so from this, we can see that it's a very confusing face that Mona Lisa is showing. And then there is a machine model-based tool from Microsoft in which they found that she was 43% happy, but 55% neutral. And there's another one that determined with FER dataset, which is like this huge emotion dataset, found that she was only 5% happy, and in fact there's 21% angry, 16% fearful, and 33% neutral. While fortunately most people's faces are not as mysterious as Mona Lisa's, we can see that emotions are actually very hard to recognize, and it's very difficult to find a ground truth in which we know what the individual is truly feeling. And especially since this shows up in all different ways on different people's faces, being able to identify how an individual is truly feeling is pretty important. And so this is my study. So there is this book called Leonardo's Hidden Face that suggests that Mona Lisa is actually a self-portrait of Da Vinci, and they did like their own research into this and how this could be. But here on the left you can see Da Vinci's self-portrait, and on the right is of course Mona Lisa. And my machine learning model suggests that they actually have a similar emotion mix. So they have quite similar percentages of like anger, disgust, fear, both like very small amounts of happiness, sadness, very similar amounts of surprise, as well as neutral. And so, of course, you would have to also analyze the art in this. But as you can see, when we as humans look at these faces, we could think that Da Vinci looks very sad. However, very sad, while like Mona Lisa has a smile, but my machine learning model says actually somewhat the opposite, that in fact Da Vinci is happier than Mona Lisa. And so here we can see how machine learning models are a lot more unbiased because they have so much data. They have seen lots of very old people and how they express emotions and how very like young girls like Mona Lisa express emotions. And therefore they do not have this bias when recognizing emotions on people's faces. And some other things that you can take from this research, like why is emotion recognition, these are some like messages you can take from this research, which is like what makes emotion recognition important. Low level responses may not be aware in like your conscious mind, and having a machine learning system like help you better understand your emotions is like pretty important. And of course, having emotion yourself impacts your ability to recognize other people's emotion accurately, so machine learning may outperform humans in this. And of course, since this is all in small group discussions, as we can see, if you are able to interact with an individual in a small group, you may be able to better understand how that individual expresses their emotions. And so this is just an acknowledgement. I wanted to thank the Brainpower Institute for their guidance in this research, and also MIT Beaverworks Summer Institution. And that's my presentation. Thank you so much.
Thank you so much, Valentina. That was fascinating. I was literally sitting here, I'm like, wow, I hadn't even thought about Mona Lisa, but that's like the perfect application. I'm just sitting here like my mind is being blown. I'd never thought of that, but absolutely brilliant. I loved it. I want to like apply that to like a million other paintings. So our question for you is, you mentioned that being able to understand emotions will lead to AI becoming conscious. So how soon do you think this might happen, or maybe will a machine ever become fully conscious?
I personally don't believe that they will become truly conscious anytime soon. It could be like pretty soon actually that they have a better understanding of emotions and how humans understand emotions better than humans themselves do. However, I do think that consciousness is like pretty far way off, and like understanding emotions, especially since it's like a pretty low level response, doesn't lead to consciousness immediately.
Awesome. And I think we have time for another question. So I feel like one question I had for you is, when I first saw like the picture of Leonardo da Vinci, I'm like, oh my goodness, I think this AI is wrong. It's saying that Da Vinci's really happy, is happier compared to Mona Lisa. But your perspective was like, oh, actually, it's like this AI has seen a ton of data, like the AI might actually be able to perceive it better than us. So I'd be curious, like, how did you like jump to that conclusion when I jumped to the opposite one?
I definitely came to the same conclusion as you did first. That was like, oh, like why is this like data like incorrect, or like why is my machine learning model saying this when obviously like I see this differently. But going back like through the data sets that I had trained my model on, you can definitely see that, like, at least in my opinion, when I went back and look at the label data set that I trained my machine learning models on, you can see that there are certain like types of faces that just like seem angrier, especially in like the deepfake that I showed as well. The deepfake, which is the guy on the right, he looked like a lot angrier than the guy on the left, even though like the muscles on their faces had been mapped like exactly. And so I do think that perhaps there is like errors in my machine learning, but of course I do think that throughout like so much data, we think that like certain facial features cause someone to look angrier than they actually might be.
I absolutely love that explanation. I feel like I understand it so much better now. That was absolutely brilliant, Valentina. I feel like, man, I learned so much from that session. And I'm so excited to where you take this project next if you do. Like, oh my goodness, like hit me up. I want to know every single painting you throw into this. And now, awesome. Thank you so much for coming online, Valentina. I hope you have a fantastic rest of your day. And we now have a very special feature for the Global AI Student Conference. Like, absolutely surprised. This is going to be amazing. We have a special talk done by Hank Bowman and Amy Boyd about the age of applied AI. Let's get it rolling.
It is so fascinating to see that AI has been around already for so long. From the first moment the term AI became a thing, and now we are creating self-driving cars. But I want to take a step back and talk about what AI actually is. Let's call our colleague Seth Juarez and ask what his thoughts are. Hi Seth.
Seth, you're on mute.
All right. Can you hear me now? All right. Okay. Hello there. My name is Seth Juarez, and I'm so grateful that Hank and Amy have invited me here to talk about a couple of concepts that I think are a good overview for how you should think about AI and machine learning. And what better way to do that than to have my handy dandy Blackboard. So if you look over here on my Blackboard, there's usually a couple of terms that are used interchangeably, but they're not exactly the same. The first one's AI. The second one is machine learning, and the last one is deep learning. It turns out that these things are kind of the same, but not really. So let's start with AI in general. So AI actually includes all of these other things that are noted here. AI actually has as a sub thing of it machine learning and then deep learning as well. So let me draw this out. And then finally deep learning over here. Now, here's the thing about each of these, because I want to make sure we know the separation. AI is actually a really old concept from the 50s. And it turns out that the AI that has worked the best and probably seems like the most intelligent are the things that we do like for games, like a computer playing tic-tac-toe and chess. These things turned out to be search problems, but intelligent search problems. And there were some cool algorithms like A** and Minimax, which were very good at doing these kinds of searches for games. And it turns out that the search space was fairly small. And so imagine a scenario where you could literally look at a move that your opponent was going to do, see all the moves that you could do, and then you could search for the best one. It turns out that the search space started to get large in certain classes of problems, like looking at an image and knowing what's in it. So machine learning is another way of doing AI, but instead of having a search space to crawl over, you instead give the machine examples of the right thing and it figures out what to do. There's some cool algorithms like decision trees, SVMs, k-means, naive Bayes, and of course, neural networks. These algorithms, basically you give it data and it produces this thing called a model. Now, deep learning and machine learning are fairly similar. Deep learning is basically a class of neural networks, but much deeper. Now, the depth of the neural network for it to be deep learning really depends upon the marketing person. But reality, it turns out that these classes of algorithms are very good at doing cool stuff with vision, with speech, and with text. Okay, so let's get into the process here, because I think for programmers, it's really easy, at least for me it was, to get confused about what's going on. And I'm going to talk now specifically about machine learning. So usually when we're writing something, we're writing a program, we have some sort of input, and then we write some sort of algorithm, right? And then the machine does some stuff, and then the out thing happens, whatever we want to put out. So for example, imagine a scenario where we're giving it a bunch of numbers and we're supposed to find the biggest number, right? The algorithm just basically does a search and then out comes the max number. Pretty simple. Now, the thing about machine learning, again, is that the search space is fairly difficult. I mean, how do you write a bunch of if, else, whatever statements or for loops to look at a picture and figure out what's in it? So what machine learning does is it swaps around what we traditionally see as the right way of doing things. So instead of having the algorithm here, we swap this over here. We put the output and the input in, magic happens, and out comes an algorithm. This is the basic part of supervised machine learning. Then this algorithm we can plug back in, and we're back to the way we did things before. And I think it's a pretty cool way to think about it. Now, to be super precise, and I want to make sure that we use the right terms, the thing that comes in is the data. The thing that comes out are what are called models. And so when you think of a machine learning model, think of it as a learned algorithm from the data that is able to make predictions or to solve the problems. And the things that go in here are specific classes of algorithms that produce models, like a neural network. And a neural network basically produces a bunch of numbers in a network such that when the data comes in, it is multiplied, other mathematical operations happen, and the output tells you how it wants to predict. Other machine learning algorithms like k-means don't really produce models, but they describe the data in a compact way. So it kind of could be thought of as a model. K-means, for example, will look at your data, and without any other information, it's able to group them in a precise way. Okay, so that is the summary, I think, of AI, machine learning, and deep learning. You can see here, they're all subsets of one another. When it comes to thinking about machine learning, we flip around the concepts of inputs and outputs and what actually generates the algorithm. And then for precision, when we're looking at the data science terms, the input and the output are the data that we give the system, and then the output are the models. Hopefully this is helpful. Thank you so much, Hank and Amy, for inviting me. We'll see you hopefully in a little bit.
Thanks so much, Seth. That was brilliant. So, Hank, even with Seth's brilliant AI demo, I think we still need to see it in action. It's time for a demo. Do you have anything that could illustrate how easy AI is?
I absolutely have. Let's dive straight into that. One of the great things that happened in the past years is that AI moved from the research labs into a space where developers can use the power of machine learning without having data science skills. At the moment, there are over 50 cloud-based services available that expose an AI model through a REST API. These services enable you to add cognitive features like object detection and speech recognition to your application. By using the provided SDKs in the program language of your choice, like C#, Python and Java, you can create applications that can see, hear, speak, understand, and even make decisions. And probably you've seen a lot of these talks in the past years about these services. If not, go to ak.ms/Age of AI, where we've created a guide to help you get started. Today, I want to show you a feature that not many know exists. Because some companies don't have the luxury to connect to the cloud all the time, or need control over their data. To solve that problem, some cognitive services are made available in containers. Azure Cognitive Services in Containers give developers the flexibility into where to deploy and host these services. They come in Docker containers and have the same API experience as when they were hosted in Azure, but give you the freedom to run them into your own infrastructure. Let's watch a small video about this capability.
Every time a technology has moved from the hands of the few to a wide variety of people, a whole new set of capabilities that we never even imagined suddenly come into existence and change the world.
Cognitive Services enables developers to take advantage of AI without being a data scientist.
Some enterprises don't have the luxury of being able to call out to the cloud all the time.
Now with Cognitive Services in Containers, that opens up a whole new world of possibilities.
Containerization is really the act of packaging up an application that you can take and put on any machine.
Azure is the only cloud that enables customers to take Cognitive Services in containers and use them on their own terms, in their own control.
I can go from a development environment to a production environment fairly quickly and build on top of that and expand that.
For example, a remote oil rig may not have bandwidth to transfer all of its data back up to a cloud solution, but definitely has strong needs.
Let's say that you are a hospital and you have tens of thousands of handwritten documents and you need to start processing those. With OCR in containers, you can actually run the models directly over the documents without sending them to the cloud and get a digital version of all that information. If I was in retail and I wanted to process customer feedback about my products, I could run that through language detection and key phrase extraction. Being able to process my text with sentiment models helps me to understand if what's being said is positive, negative, or neutral. This is enabling an entire new set of applications and use cases for our customers to use AI that previously was not possible.
It's really exciting to see what other people are building on top. That's been amazing to watch, and it's really honestly humbling.
I hope this video gave you an idea about the capabilities and when you can use it. And to demonstrate how easy it is to use one of those services, I've created a small demo where we're going to take a text-to-speech container and deploy them in an Azure Container instance. In this demo, we're going to run a cognitive service speech container in an Azure Container instance and use the REST API to convert text into speech. I'm going to use the Azure Command Line interface to create all my resources in my Azure subscription. The Command Line interface, also called the Azure CLI, is a set of commands used to create and manage Azure resources. The Azure CLI is available across Azure services and is designed to get you working quickly with Azure, with an emphasis on automation. Everything in Azure always starts with creating a resource group. A resource group is a resource that holds related resources for an Azure solution. To create a resource group using the CLI, you must specify two parameters: the name of the group and the location where this group is deployed. The next resource we are going to create is the Speech Cognitive Service. To create this resource, we need to specify a few parameters. Besides the name in the resource group, you need to specify the kind of cognitive service you want to create. For our demo, we are creating a speech service. When the speech service is successfully deployed, we can extract the properties we need for when we are going to run the container in the next step. The two properties we need are the endpoint URL and the API key. The speech service in the container is using these properties to connect to Azure every 15 minutes to send the billing information. One of the easiest ways to run a container is to use Azure Container Instances. With one command in the Azure CLI, you can deploy a container and make it accessible for everyone. To create an ACI, it takes a few parameters. If you want your ACI to be accessible from the internet, you need to specify the parameter DNS name label. Copy-paste the billing endpoint and the API key. The deployment of an ACI should take around 5 minutes. The easiest way to validate if the container is running is to use a browser and open the container homepage. To do this, you need to retrieve the URL for the container first. This of course can be done using the Azure CLI. Navigate to the URL on port 5000, and if everything went well, you should see this page. To test our service, we need to create a post request. There are many ways to do a post request, but I'm using a program called Postman for this. In the request, we can specify the voice we want and the text we want to have converted to speech. Let's give it a try.
Hello world.
Nice, that worked. In this demo, I've showed you how you can run your own instance of the Speech API in your own infrastructure, giving you full control over the deployment and where your data is stored. To learn more about cognitive services in containers, visit ak.ms/Age of AI. I think this really shows how far we have come and how easy you can leverage the power of machine learning in your application. But with great power comes great responsibility.
absolutely right, Hank. And in this chapter, I wanted to talk a little bit more about responsible AI and some potential approaches we could take to it moving forwards. So let me ask you a few questions first. And when I ask you, would you trust an AI too? And then something on the end, I want you to really think about your immediate reaction to that question. So, would you trust an AI to recommend you a product or service? Okay, well, I use online shopping a lot, and so one of the things I find is those recommendations are often quite useful. They're quite targeted. They help me find something that I might like in, you know, a whole spectrum of different products. And so yeah, I would currently trust an AI to recommend a product or service. Okay, so the next question, would you trust an AI to help keep you safe online? This one's an interesting one, right? This one is, there are experts in their fields. They're probably much more of an expert than I am about different viruses that happen online. And so for something to be able to maybe flag things or tell me, you know, when something's not quite right, or maybe act on it as well, I think I'm quite comfortable with that, given that I am not an expert. And so to hand that off to something that would be, it is something I would feel okay with. What about you? Have a think about it. So let's take a step up into the next section. So, would you trust an AI to assist your driving? This one's an interesting one, right? Until very recently, I would have been like, oh, I don't really know. But if something can help me know when there's going to be hazards, or if something can help me maybe like reverse into a parking spot, or, you know, parallel park or something like that, then yeah, I'm more than happy for it to, as long as I have some kind of override capability, I feel fairly comfortable with that. So what about driving you? Would you trust an AI to drive you? This one is an interesting one. I'd say, oh, maybe, but then I think, oh, well, there's lots of car manufacturers out there that are creating autonomous vehicles, and we see them making their way through policies in various different parts of the world. And so I'm kind of like, yes, maybe sort of thing. I'm a lot closer to maybe yes than I am to anything else, but it's still an interesting one, right? It's still not something that I have personally tried. But I'm gonna go with a yes today with this one. Let's speed this up and take a slightly different direction. So, would you trust an AI to monitor your health? I'm not wearing it today, but I do have a fitness device. It gives me lots of interesting data, and it can give me great insights. So yeah, I would be fine with it monitoring my health. Okay, but would I trust an AI to dispense medication? Okay, this one's a little bit different, right? So this one is, you maybe start to see my pessimism here, but dispensing medication, it's obviously very critical if you need that medication. And so there is that immediate question that comes to mind for me, which is, what happens if it goes wrong? How am I alerted? There's a lot more for me to unpack there before I'm able to answer that one. And that's okay. That's okay to have questions about it. So this one is where we're going to go into a little bit of a case study. So would you trust an AI to help you choose a babysitter? So someone who's going to care for your child, your nieces and nephews, your family members, someone that you care for. Would you trust an AI to choose that person? Well, let me take you on a little journey where we can break down whether we would or whether we wouldn't, and what extra questions we might want to ask of, would we trust an AI to help us choose a babysitter? Okay, so we have an example family here, and they are looking to choose a babysitter for their child. And there's lots of people in their area that might be interested in doing something like this. And company X here, as an example, would go ahead, and the idea is they would evaluate, based on these people's social media accounts, whether they should be recommended for the job. Okay, so, and then we can see that there's lots of different things that they can actually measure each person by. So they take their social media account and they maybe look at things like, do they have disrespectful attitude? Is there any explicit content? What are some of their flags posts, etc.? And this is how they would bring together a score that would help you choose a babysitter. Okay, so before we evaluate our final decision on whether we would let company X choose as a babysitter, I want to talk to you a little bit about values and morals and what ethics, the word ethics, can break down into. Now, this is the word ethics not based on data, not based on AI, but just the definition of ethics in general. So you can see two different kind of sides: values based on the well-being of others and values based on our own well-being. And under each of these categories, there's different things such as non-suffering, the ability for us to have autonomy, equality, virtue, so what are our core values, as well as trust and trust in others. So if these are all the different values that we have when we have ethics for humans, what can we do when we have ethics for AI? Well, that's where I'd like to introduce you to FATE: Fairness, Accountability, Transparency and Ethics. FATE is actually a part of the organisation at Microsoft. You can look them up online, and they do a lot of research around this type of AI. One of the fascinating pieces when I first saw this framework by Michael Robson at Microsoft was the way that he broke each of these categories down into really core questions that we can ask ourselves of any AI situation. And so if we take an example of a few, please feel free to take a look at these in more detail afterwards. You can think about, is anyone being treated differently? Well, yes, I guess if you think of the situation with the social media account, the first people I think of is, what if someone in the older generation who doesn't use social media so much, does that discriminate them from not getting a good score, a bad score, any score at all in this system? That would be something I'd like to know more about. Is the training data just based on a certain type of age group? You could almost build on that previous conversation and say, well, who was it trained on? What kind of different people, what kind of outcomes were expected? So that's kind of in that fairness category. If we move on to accountability, there's this idea of, can we give feedback or challenge the results and the mechanism for that recommendation? Is there ultimately a human accountable for that final decision, or does it actually automate that part of it? If we move on to transparency, there's this idea that, is it clear in this process to everyone involved that an AI is being used? Is it well described and understandable? Do we know its shortfalls is always an interesting one. Are we actually using it for an appropriate use? And then finally, ethical. Is there any social implications? Is anyone discriminated against when using this system? Could there be any unexpected behaviour or human monitoring that could disadvantage people? There's so many different ways you could dive into this framework and use it to analyse your different AI solutions, just like we can with Company X. This framework shows that every person has a role in building responsible AI, and that this should be built in right from the first day. We've seen lots of different aspects of AI solutions so far in this session, but in the next chapter, let's talk a little bit more about whether you should build or buy an AI solution.
This brings us to the end of our session. We've covered a lot of ground, from the history of AI, found out what AI is, and seen some great examples on how you can use AI services in your applications. I hope you enjoyed it.
If you want to continue your learning journey, go to aka.ms/age-of-AI to find out more. Thanks so much.
With the right tools, ideas become the next innovation.
My idea is to prevent patients overdosing on prescription drugs.
I want diabetic patients to be aware of when they might get heart disease.
I'm trying to increase awareness about organ donation.
Microsoft helps ideas take flight.
Imagine a soil being able to tell the right quantity of nutrients it needs.
To help people with hard disabilities to live fuller and happier life.
Breaking through barriers.
We're trying to help people with disabilities lead more independent and inclusive lives.
Reaching across borders.
In India, organ donation is critical. If you don't get it on time, you could ultimately lose your life. I wanted to change that by introducing machine learning and AI.
Hi, Microsoft AI for Good.
Microsoft is putting innovation in the hands of people.
With our solution, the farmers can save up to 70% of weed killers.
We see a need to put AI in the process to empower doctors to analyze more patients. It will help them to detect critical cases much faster and preventing heart attacks.
Leaf AI is an automatic plant disease detection tool that can identify plant diseases with a simple smartphone.
To create change for the better.
Challenges like this allow people like myself to be able to bring our solutions to life.
I seize the opportunity and hope that others will use artificial intelligence to make this world a better place.
Okay, we good. Ian, we good. Okay. What is it that we can do that is unique, that is impactful? We are going to empower every individual to do more and achieve more.
That's what technology really is. It's possibility.
Listen. You have more power at your fingertips than entire generations that came before you. Tomorrow is here today. What will you do? What will you do with it?
So this is an augmented reality device called HoloLens.
Wow. People can really use it to take things to the next level. That's what technology is supposed to do. That can change the world.
Awesome, I'm here. We come back. So I hope you enjoyed that video and I hope you're ready for our next session. It's gonna be a round table about women in data science. So I hope you're ready to hear about these three amazing women that are gonna talk about their experience and everything about women in data science. So yes. Oh, here they are. Hello, Anshel. Hi, Ornella. How are you? And Luxley, how are you, everyone? How are you ready for your presentation?
Hi.
Yeah.
Yes.
Wow.
Very excited.
That's awesome. So, what are you gonna be talking about in the roundtable? Yeah, you can introduce yourself.
Yeah, so I actually have an introduction slide that I'm trying to share, but I don't see it.
We see it on the screen.
Oh, okay. Great.
Awesome.
So Hi, everyone. I am Ornella Altunian, and I'm a cloud developer advocate at Microsoft. And I'm joined today by Anjal and Loxley, who thanks so much for joining. And we're going to talk about women in data science. So I will pass it over to Anjal to introduce herself.
Sure, thanks. So hey everyone, my name is Anjal Bhalla. I am a senior data science consultant at Capgemini in Dubai. My role basically involves working with different clients to build and deploy their data science and AI solutions on scale. Previously, I started off working as a developer advocate at IBM and then moved to a data and AI technical sales role. I'm a graduate from the University of Wollongong in Australia, and apart from my job, I also love doing a lot of community work. Like, for instance, I am a co-ambassador at the Women in Data Science, which is a Stanford University community, and that's about me.
Great. Loxley, can you introduce yourself, please?
Yes, and first of all, Anjal, that was such a cool background. Oh my goodness, I'm like so inspired. So awesome to learn more about you. So hello, my name is Loxley. I am a software architect analyst at Accenture. A little bit more about me. I just graduated from the University of Washington, Seattle with a Bachelor of Science degree in informatics. But I'm actually still a student, which is probably why I'm still part of the Global AI Student Conference, because I just began my master's degree at the University of Washington 2 weeks ago. It's been a ton of fun. Outside of school, I've held internships at Microsoft and Accenture, as well as a data science internship at a startup, which we'll get more into later in this talk. And then now, in addition to my classes, I started full-time at Accenture as a technology analyst. Man, 4 months ago, I think 4 months anniversary, like 3 days from now, which is crazy. It's like, it's going by so fast. And let's see a little bit, just one fun fact about me, because I just have to say this at every single chance I can get. Completely unrelated to data science and technology, I have been training to climb Mount St. Helens for an entire year, and I finally did it 2 weeks ago to this day. So totally off topic, but if you have questions about climbing Mount St. Helens, hit me up for that too.
Congratulations, Loxley. That's amazing. On top of all of your other accomplishments, of course.
Thank you.
And just to introduce myself, so I'm Ornella Altunian. I work at Microsoft. I actually started here as an intern many years ago, and I was a product manager for HoloLens. You may know me from the VS Code videos. If you've ever downloaded VS Code, you might see my face pop up on the screen. But now I work on the education advocacy team here at Microsoft, helping students learn how to make really cool stuff with Microsoft technologies. So that's kind of where I focus my efforts now and why I am moderating this panel. So I would love for each of you to kind of talk about how you got started with data science. What was your first introduction to it? What inspired you about it? Loxley, do you want to start?
Yes, I feel like, my first experience with data science, it wasn't even that long ago when I think about it. It was technically, my goodness, like maybe 18 months ago, 20 months ago. It's kind of crazy. So actually, first time was 3 years ago when I first did the Girls Who Code Summer Immersion Program. And we did like 2 weeks where we learned like intro to like Python, specifically with a data science focus. But I feel like I didn't really latch on to data science at that point. That didn't happen until about a year or two later, where I took my very first like official data science class at the University of Washington, where we had it was called I think it was like technical foundations of my major. And we basically learned how to code in R during this program. And this was like the most craziest opportunity ever. Like I was in, we had a Slack channel for our group, and one of the teaching assistants for the class like casually posted like, hey, there's like a data science internship. It's like, just send me an email if you're interested. And I was like, oh my goodness, I am absolutely interested. I've got spare time. So somehow although I only had done like 1/4 of like data science at that point, got the internship, got to do that like spring and summer of, oh my goodness, this is 2020, which is feeling like a long time ago. Since then, more getting into data science, took a took a class in SQL a year ago now. So that's kind of how I got into data science. And now it's like, we'll get more into the passions later, but I feel like I'm interested in like the applied of the machine learning and artificial intelligence. And that's why I love the Global AI Community Day.
Thanks, Loxley. That's really interesting to hear about, having the in-class experience and then getting to apply that experience in an internship. That's really awesome. Anchal, do you want to talk about your background in data science?
And so that was very interesting, Loxley. So I also started my data science journey from university itself. I mean, I didn't start learning about data science at university, but I started my graduation project. So my graduation project was a data science project. It was a building a smart malware detection software. And that actually got me very interested in data science, and I wanted to start exploring the area more. And at that time, I also started working at IBM as well, where I slowly started developing my skills further and started working on different projects. And then I moved to a technical sales role in the data and AI team, and then now in consultancy, where I work as a data scientist for like multiple clients. Yep.
That's awesome. I think it's really interesting to hear about all of the different paths you could take, even like studying the same thing in school or even further in your career, kind of switching to different things that you realize that you like more. My background in data science is actually kind of really new. I never took a data science class in college, and I never had done any data science until my current role, which I started in April. So I was working through Microsoft Learn modules like everyone else, learning how to do data science. And I actually got to do this really awesome live show with one of my coworkers and friends, Chloe Condon. That's called Beep Boop. And we did a season, so it was like 5 episodes about data science. And it was actually kind of like a learn along format. So we learned a ton about data science just through doing that show. I will drop the link somewhere in the chat, but it's aka.ms/beepboop-replay if you want to see any of those. But yeah, it's never too late to start learning data science and practicing it. We did a show about how to create a Power BI dashboard. Like we just learned how to do it. And then that same day made a Power BI dashboard to like look at the analytics from our show. So it's really quite amazing how quickly you can pick up these really awesome skills just from doing a Microsoft Learn module. I think on that same topic, what we should talk about next is what advice we have for people who would like to get started with data science. Anchal, do you want to talk a little bit about that?
Yeah, sure. So as you all know, like data science is a vast field. I mean, there's so many subdomains, like there's computer vision, deep learning, predictive analytics. There's so much to do. So what advice I would give is to pick a focus area and then excel in it. Yes, before that, you do need like the basic skills, like learning about programming, feature engineering, data preparation, etc. But then you can, once you're done with like the basics, you can always pick a area that you like. Another route that you can take is focusing on the industry itself. So if you like, for example, finance or retail, you can actually increase your skills in that industry, and then use your data science in those particular domains as well. So that's the advice I would give. Either pick a subdomain in data science or pick a domain in an industry that you like. Or you can do both as well. You can mix both of them as well. Okay.
That's really great advice. Loxley, do you have any other advice?
Yes, I feel like I have a ton of advice, so I apologize if I talk for a very long time. But I feel like the very first thing, especially for students, is to like find those data science classes at your university. And it's kind of funny because although my very first exposure with like an actual course in data science was R, I spoke to a couple of friends of mine and they're like, hey, if you're interested in data science, like definitely make sure you're taking those SQL classes and those Python classes. Like if I could go back and redo my college experience, which granted wasn't that long ago, I would have gone out of my way to take a intro to Python, because right now my Python's pretty surface level, and there's like a very special class. It's like intro to Python, data science plus machine learning. And I'm just like, how did I only learn about this upon graduation? So highly recommend taking classes in those skills. And another cool thing is that's available at a lot of universities is to specialize in data science, kind of like what Anchal said. So my specific major was called the informatics degree, but people could choose to specialize in like data science, where they take a couple more unique classes in that. So if that's an opportunity at your university, I highly recommend it, because it's just a great way to go like, hey, maybe I have a degree in computer science or software engineering, but like my specialization, what I've taken core classes in is data science. Like I have those skills, even though I might only be an undergraduate. The next up, I think, is like data science learning. It's like, even maybe you don't have access to those classes or you're not enrolled in university at this time, there are so many amazing learning resources out there. Like I'm so glad Ornella brought up Microsoft Learn, because there's just fantastic resources. Even last January, I took remembering the name of it, a Azure Artificial Intelligence Fundamental certification, which was absolutely amazing. I loved it, but there's another data science fundamental certification. And that's a great way to like say like, not only do I have these skills and I learned it, I actually have a amazing Microsoft certification that tells me that I actually know it. And then the final thing, so data science learning, data science classes, the final thing is like the internships and the projects where you get the hands-on experience in the data science. And like one thing Anchal said is like in her graduation project, she worked on data science. And at my university, they had a capstone that we were required to do in our major before graduating. And they had amazing data science options, where actually one of my friends in the program did an entire one where he went through the database for like the King County, so in the Seattle area, like their entire like hockey system database. Like an absolutely amazing project, getting the hands-on experience. And then if you get the opportunity, go out and find internships, and even networking with people at like the roles and the companies and the specific interests you have in data science on LinkedIn. I absolutely love scheduling virtual coffee chats with people who have roles that I'm interested in.
Yeah, that's all really great advice. I think to echo on the interesting data sets portion, I think people can be a bit intimidated by the idea of like, doing something with a huge data set. And one way that I've been able to overcome that is to like pick a data set that's particularly interesting or like funny to me. So when one episode of Beep Boop, we used like squirrel data in Central Park. There's this group of folks who track all of the squirrels in Central Park in New York, and they have this open source data set, and you can just grab it and learn how to do, different transformations, how to clean your data, how to prepare your data. So I think if you can get engaged on the data set that you're working in, you're more likely to ask questions about it that then enable you to learn how to do those types of machine learning and all the different transformations to your data. So I think it doesn't have to be this big scary thing. And I think a way to kind of connect with it is to just pick something you're really interested about, which is also what Anchal said, or like an industry or whatever. But that's been really fun. Just like, I don't know if anyone has ever used Kaggle, but they just have like a bunch of open source data sets about like anything you could ever ask for. And it's really fun to just go through those and be like, am I curious about this topic? Is this something I want to kind of play with and see what I find? But yeah, I agree that, getting free online resources is a great way to start. Microsoft Learn has a lot of those. And I think you don't need a degree in data science to excel at it. I think that's something that is a big misconception. I mean, I came into an AI and ML role with zero experience in either of those things. And I think with the right resources and support, and maybe make like a little learning group with your people in your class, or people in if you're like a Microsoft student ambassador in that community, there's a lot of really, really good opportunities to learn on your own time. And I think that is just as valuable as learning it in school.
Yep. I agree with you. I've actually used Kaggle like a lot of times to get a lot of data sets from. And one way I see a lot of people doing it is by using the Titanic data set. I've seen that project everywhere. Like that is like the beginner data set, that beginner project that people usually do to start off with their data science journey.
Yeah, there's this really funny, I guess it's not funny, but it's just fun. A group of people on my team also made this GitHub curriculum, ML for Beginners, which I highly suggest that people check it out. It's really great. But they did this project with like food data that I think was also from Kaggle. And so they kind of tried to figure out how you could categorize like what country of origin the food was from based on like the ingredients in it, because there was an ingredients list. I love food, so I think that's fascinating. There's so many opportunities like that to just like play with random data and see what you can find. The Titanic one is so great. I need to look at that.
It is.
Let me ask you this, Loxley. You mentioned that you have, all of these awesome interests outside of work. Is there anything that you're involved in that also helps you grow your data science skills?
Man, that's such a good question. But first of all, I need to check out that squirrel data set. That's going to become one of my new involvements, is I'll be watching that Beep Boop episode, because that just sounds so, I'm just like super proud of those people in New York City who are doing that. That is so cool.
They have a website and everything. You should look at it.
What? That is amazing. That is, oh my goodness. Literally, I'll be doing that instead of my schoolwork this afternoon because it sounds amazing. So, okay, my current involvement, man, I feel like some of my favorite involvement to do, which is, so maybe this is kind of a good message for like kind of especially women in data science. Like I remember when I first like was in like first quarter at the University of Washington, like they have a huge hackathon in like October. I think it happens. It's like for students, it happens like this weekend. It's crazy. And I remember at the time, like I was at this hackathon and I was like, I don't know if I'm necessarily a hackathon person. Like I didn't know if I necessarily fit in with like this room of like hundreds of people. But then by the end of this hackathon, like the people who had the winning prize had done this absolutely amazing topic where they had used Azure Custom Vision. And I was like, oh my goodness, this sounds really interesting. I like winning hackathons. So do you know what? I'm going to try this. I'm going to just like lock this away. And the next time I go to a hackathon, I'll try out Azure Custom Vision because it sounds very interesting. And then at my next hackathon, which happened to be, it's called the Women in Informatics Hackathon at the University of Washington. And I created this super awesome data set with my team where it's kind of in like the area of like unstructured data, where we took all of these images and we're able to like kind of, and like very much like, no, like don't take it with medical credibility, but create a baseline of like, could you possibly be developing Alzheimer's disease based off of a test someone could easily fill out? So just an amazing way to apply like these image data. And so after this event, I was like, okay, like kind of the image and object recognition is what really interests me about like maybe the data science and the artificial intelligence machine learning field. But let's take it one step further, and actually I ran to become the hackathon director for Women in Informatics. And so all last year I was planning our first ever virtual hackathon at the University of Washington. It was probably one of the craziest months of my entire life, but it was such a fun way to kind of continue doing data science outside of school, kind of add that piece in. But now it's like, it's been a little while since the hackathon. What am I still doing? I love like writing technical blogs. Obviously I'm doing conferences like these, which I absolutely love. And the final thing, I've got just like these ideas like rolling around in my head. So right now I'm thinking I want to go into the realm of like artificial intelligence that's like from voice recognition. So look out for a project in another like 3 months where I'm actually going to record my voice. So I'll be creating my own raw data, which will be very interesting because I've never done anything like it before. And hopefully be able to like say something into like a microphone and it'll input out an emoji. That is the hope. Whether it actually happens, we will learn. So stay tuned for that. It'll be a ton of fun.
That's so cool. That's a really good idea to explore kind of a new technology, which is the speech recognition. That's awesome. I had a really similar experience with hackathons when I was in college, where I actually went to school for environmental science originally, and I ended up dropping that class on the first day while I was still sitting in the room. And we had to make a list for our advisors of all of, like a list of classes that were interesting to us that we wanted to take before we graduated. And so I just looked at that list and saw kind of what fit in that time slot in my schedule. And it happened to be Intro to CS. And I had 3 female professors who were like absolutely my role models and my motivation. And that very first semester of college, after doing, half a semester of coding, never coded before, my team won the hackathon. And that just like unlocked so many doors for us. Like, I really had no idea that, I could get a technical internship or anything. And so I spent the next summer like working at a startup, writing code. It was just so foreign and weird to me. And it really was unlocked because of this hackathon. Because, when you're a first year in college, there's not really a ton going on your resume. But like, if you have some hackathons under your belt, people really enjoy hearing about those projects and what you built. So totally agree with you, Loxley. Hackathons are a great way to get your foot in the door and also to explore technologies that you think are interesting, like data science.
I completely agree. And just to add on to that, first of all, congratulations. Winning a hackathon is like so impressive. Like, here's to you for that. So the one thing that actually made me think of is hackathons are an amazing opportunity because I actually applied right before the global pandemic started, like February of 2020. I applied to go to the Stanford Tree Hacks hackathon in like Palo Alto, California. And I got a free trip to go to Stanford and participate in their hackathon, which was so much fun. I like got to explore San Francisco. So like that was just an opportunity I would have never had if it wasn't for applying to attend hackathons that were outside of my town. And that's a lot of like these big collegiate hackathons. They provide scholarships so that people from out of the state can attend, which is so cool. So there's so many great things to do at a hackathon. And even if you don't win, you get awesome swag. You get to network with great people. Do technologies that you might not be learning in the classroom. And then there's always free food, which is amazing. So there's that as well.
Totally. If you're looking for a hackathon to participate in, CalHacks, which is UC Berkeley's hackathon, is next weekend, and I'm actually mentoring that one. So I think they're still even accepting applications. So if that's something you're interested in, it's all virtual. So folks can sign up for that and see what technology they want to explore there. I'm excited for that. A bit on the topic of kind of being a woman in data science, I wanted to ask Anshul if you ever experienced imposter syndrome and what advice you might have for people who might also feel this way.
Yes, so I have experienced imposter syndrome, and it's actually very true. That's something that I've realized right now. So it can happen at any stage, and for me, it happened when I was in the middle of switching jobs. And there are multiple ways to overcome it, actually, and you just need to find what method works best for you. So one way is to realize that no one is perfect. We are all humans. We all make mistakes. We're not going to be the best at everything. I mean, we can pick like a area that we're best at and try to do something that we're best at, right? Like we don't need to be perfect at everything that we do. And another way is to remind ourselves of the successes that we've achieved so far. Maybe you can write them down, or maybe you can make a mental note of it and see how you've contributed to your own successes and how you are going to be the reason that you will progress ahead. Another way is also by speaking with your mentor or your manager, and they can always help you out, like with any problem that you're facing. Yeah, that's the advice that I have.
Totally. Yeah, that's great advice. I think something we try to embody at Microsoft is like the growth mindset. And I think that really comes in handy when dealing with imposter syndrome too. Like, I kind of just realized one day that I could learn anything if I put some time and energy into it. Like, it really just, you've made it this far. You're so like equipped with so many different skills. What's one more skill? And yeah, I think just focusing on, areas for growth, and also what you said about realizing that everyone else is also growing and learning, really, really important. Loxley, do you have anything you want to add?
Even like imposter syndrome, even like coming onto a women in data science panel, I'm just like, oh my goodness, like, am I actually supposed to be here? But I think it's like, it's really, I think, at the end of the day, it's like, this has been so much fun. I'm just like, even like, I did some prep in advance to make sure like, okay, like, oh yes, I actually do know this stuff, even though I might not feel like I know it all the time. So I feel like it's kind of, yeah, I like completely agree with the growth mindset, and just even like putting yourself out there for opportunities that you might not think you're qualified for, but then like, heck, like apply for everything, and then a couple might happen, which is super cool.
Totally. Okay, I wanted to end on a bit of a fun question. So I'm curious to know what you both are most excited about in the field right now. Anchal, do you want to start?
Sure. So I'm actually most excited to see how AI can actually help with education. So I've been seeing that there is a lot being done in the education space, like where they're trying to improve the experience for students, for example, by providing more personalized education, by helping teachers with marking students' exams. So I'm really excited to see how AI will improve education and especially make it more accessible for everyone, since it's such an important subject.
Yeah, I totally agree with that. Loxley, do you have an answer to that one?
Man, I love Anchal's answer, like education. So yeah. In addition to education, I think what I'm so excited about right now is like the data visualization side of things, like taking all of these numbers and make them actually mean something to people. And I think like where this kind of comes from is like, there's like amazing apps, even like on my phone, that basically tell me like, how much am I like listening to audiobooks every day? How many steps do I walk in a day? For example, climbed Mount St. Helens 2 weeks ago. I've been so busy and it's been a little stormy outside that I've only gone on a walk like once since. And so I've seen that drop. So it's like, okay, I need to build that up again, although it is getting a little sad and the days are getting shorter. But then it's taking a data visualization and then applying it to like my actual work. Like I recently had a colleague who got into Power BI and created an entire dashboard that tracked our progress on our like weekly sprints. It was like absolutely mind blowing. So going into like that kind of low code data visualization is like something, it's like on my to learn list. So I'm so like, you inspired me, Ornella, even just reminded me of that, because oh my goodness, I need to get into that like immediately.
Yeah, check out that Power BI Learn module. Honestly, it was great. Thank you both so much for joining me today to talk about this really awesome topic. I had so much fun. And I just wanted to remind everyone watching, I'm just going to share my screen really quick, that you can reach us on LinkedIn or on Twitter if you have any questions or want to know more about anything we talked about. And just a little something for the Global AI Student Conference. If you do any of those Learn modules that we talked about today, they're planting a tree for every module, which is awesome. And there is the link to grow the Global AI Forest. So exciting. Thanks so much.
Awesome. Thank you, Ornella. Thank you, Anshul. And thank you, Loxley. It was amazing. I really enjoyed so much all the talk about like learning data science, all the different paths, using different sources like in Microsoft Learn or online learning, and also going to hackathons and stuff like that is definitely amazing. And I really feel very happy because all of you are women. And we also, right before 2 sessions ago, we had another girl that was talking about like women going more into technology and encouraging more women to go in these fields and improve like the skills and stuff. So definitely that's amazing. And I really like want to thank you for all the things that you said. It encouraged me so much. And I hope to all of our people that are watching, they are encouraged as well. So thank you so much also, Ornella, for reminding about the Cloud Skill Challenge. And definitely if you want to like complete it, you still have 16 hours. And remember to send an email with the screenshot to the aiconf@globalai.community. And yeah, I think, I don't know. Yeah, Loxley, you want to say something?
Yeah, I thank you so much. I think we're nearing the end of our conference. I think our final message is a thank you. Like, we can't do this conference. Like, you see us on the front. There are so many people working behind the scenes to make this happen. Thank you so much to our sign language interpreters to make this conference accessible. I feel like this is the only conference that I speak at that's accessible every single time. It's so inspiring and it's amazing. And the next 2 more people we want to thank before we'll close it out, or also be thanking people for the rest of the evening, is our amazing people behind the scenes, Hank Boldman and Dmitry Shoshnikov. They're the people making sure that we know what we're doing and they make us look so good up here. So thank you so much to all of our participants. Thank you to our people behind the scenes. Thank you so much to our sign language interpreters. Thank you so much, Louisa. And I think that wraps our 3rd Global AI Student Conference. See you next time.